CQ, CQ, calling CQ, calling CQ. Kilo Bravo 1, Oscar, India, Quebec. Calling CQ and standing by.
I think it was muted, so on the live.
Okay. Okay. Testing 1, 2, 3, testing, 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 testing. Are we good? I think we're good. Maybe we're good. Okay. Can I get an honest signal report?
5-9.
Everybody says 5-9.
This is not a contest.
No, I know. One hopes not. No, it's the first talk of the first day. Once they get everything adjusted, it'll be fine. And the folks are great about
By
that.
Sunday at 1 o'clock, it'll be great.
Yes, it will be. Absolutely.
If this were a contest, I need to know where to send my wall.
Yes, yes. My only reservation about this time slot, and I'm not going to say a word because it's a privilege to be here, is lots of people standing in line miss the talk.
Yeah.
And I'm afraid if I say something, I'll end up with Sunday at 11.
Yep.
And I'm going to
Sunday at 11.
accept the privilege and go with it. But people see the shirt, and they often stop me for coffee or soda or whatever. We'll go hang out under the one tree that's out there, and we have a good time.
I agree with that philosophy. Is this the same talk you do with Marlboro?
It's pretty simple. Yeah.
Very similar. I never make that one.
No?
There's always some conflict. So now
So,
I don't see it here.
I understand that they record these, and they have a YouTube channel, the Hamvention YouTube channel. They record the slides, and they record my voice. So I can dress any old way, and it doesn't matter. Right? But we're hams, too, so I'm not going to stand
That's
up
right.
there in a suit and tie.
This is not a fashion show.
But so if people are at one of the other really great talks in this time slot, they can watch it on YouTube. I'm going to claim it's not quite as good as live, but at least it's there for people to get the information.
Gotcha.
And my understanding from one of the gentlemen is that this talk has a lot of people who watch it online. He said it was over 6,000.
Wow.
And that just blew me
That's
away.
a lot of hits.
Yeah, I had no idea. So I'm pleased that people are interested. Now, maybe it's because they think I talk too fast and they slow it down when they watch the video. I don't know. But I enjoyed the subject, and I'm glad that people show up to do it.
I'm glad you're here.
If there's a half a dozen people in the seats, it's all good. If we fill, well, we won't fill them, but if we did, that'd be even better.
Won't fill up because they're all waiting in line.
Well, I'll believe that if you do. I'm good with that. Maybe I should get these gentlemen to put a speaker out by the front gate.
I think so.
I hadn't thought about that before.
There you go.
Yeah?
You should just hack the PA system.
Wow. Yeah, you think they'd invite me back?
Yeah, but you go out in style.
Well, there is that, yeah.
They will not forget you.
Mm-hmm.
Yeah, that's a 3D move right there.
Yes. No, it's worth the 900-mile drive for me. I do it in 2 days. I'm from Eastern Massachusetts. I do about 400 to 450 miles a day times 2 to get here, and this is my 3rd consecutive year. And I'm real happy to do
Yeah,
it.
I split my drive from yours.
Yeah.
I do like 4 to 5 hours and the next to 4 hours.
Yeah.
Yeah, because
Well,
it's 9 hours straight.
I know people that do, 14 hours they tell me, right? It's like, no way. I'm tired after
I
the
did
game.
one of the years I did it all the way. I'm like, no, I'm crazy.
Yeah,
I'm
right.
not doing that.
But
Why?
I'm retired now. I don't have to do that. Whatever talk you're looking for, you're in the right place.
Yeah, I talked to you earlier.
I know you did.
Yeah, the only problem with it, I got to shut this door because it doesn't help the air conditioning.
Okay.
Probably makes it worse.
It'll help the acoustics.
Yeah, okay. A lot of electric boxes in there. And I do hear a roar, so I think the air conditioning is working. Do you hear it?
I hear something here.
It's certainly quieter than passengers.
Wait.
It's quieter than passengers.
Oh.
This thing seems to be sucking in a lot of air. I could take out my ponytail and test that.
Oh, well, that is,
It'd be like that commercial with the speakers where the guy's hair's blowing back.
it's sucking air, right? Okay.
It seems to be. I can't reach over and feel it because I'll fall off the cliff.
You're dating yourself with that example.
I'm dating myself with my hair color.
You're talking about the 3M line for Hammer. The guy sits in the chair.
Pre-born.
Yes. Yes. It may not be honest.
Yeah, it's usually louder.
Wine glass
That's right. Yeah.
Nipper, thank you. Yep. Well, predates me just a bit, but I have seen the old advertisements. You're allowed to be comfortable in my talk. Please, if you want to take them off, you go right ahead. I don't care. Okay.
Are we still at 26C?
No, 26 Delta.
Okay.
3 weeks ago,
All right.
approximately. Not many changes, mostly just updates. I might have added one or two things, pulled a couple of things out, small stuff.
I'm sure you'll address this, but as, you know, with the previous distros, that sort of thing, now with the scripts, I'm sure you talked about this, but would I just run the script again and get the latest thing? Or
Yes.
should I have
And
to?
yes, you do, and yes, I will talk about it.
Okay, cool.
I tried to make it as easy as possible.
It seems like a great change.
Well, I talked about it last year when I gave this talk about how I was going to make that change, and then about 3 months later, I came out with it. And so far, so good, as far as I know.
I mean, as you know, with the forum matrix, you can't go to see everything that you want, so I didn't see it last year.
Well, they're recording this, and it'll be on the Hamvention
Okay.
YouTube channel. So tell your friends who couldn't be here, or maybe they're at some other great talk in this time slot.
I don't have it set up right now, but I did a sandbox test a couple months ago where I loaded it
On top of,
Dragon.
I'm not familiar with Dragon.
Well, you should look it up. It's another guy that does ham radio distro, so it's based on a lightweight Ubuntu. That,
Okay.
and so, you know, it'll be like a trifecta of all the.
And it worked just fine? I'd be curious about that, because if I could see the test.out file from that and verify that everything's cool, I will add that to the list of supported ones.
Okay.
Okay, if you're able to send me that file.
I'll try to remember to do that.
Okay, sure, that'd be great. I have a business card up here if you'd like to grab one with my email and such.
And
That would be cool information to have, John, thank you.
the Dragon one is mostly SDR oriented.
Okay.
And that is my initial focus here, but
All right.
I know it does other stuff.
There's so many SDR programs, I couldn't possibly put
Oh,
them
no,
all
no, no,
on.
no.
I picked a couple, right?
Yeah.
But everybody's hardware is different, and the software to talk to it is different. So, hi, Sam, good morning.
Morning. Sam Elby from Arizona.
Sam, nice to meet you.
I'm into these raspberries,
Yeah.
and I got an extra because I usually used to watch TV.
Yeah. Oh, I'm glad to hear that.
Free TV.
I'm glad to hear it, yeah, that's awesome.
But I
It's
got
great
it.
when any kind of computer thing works great.
Yeah, but I want to get another one. I want to get a 5.
Get a 5 with 8 gigabytes of memory
Yeah.
if you want to run this stuff.
Yeah, and I want to put it on the air.
Yeah,
Yeah.
yeah, you should be able to do that.
Beacon.
Sure.
Yeah. So you could talk about that.
I'm not going to talk about beacons specifically, but I'll probably talk about just about everything else.
Okay. Well, I'm gonna be here listening to
Okay,
every word
that's
you
great.
say.
Well, thank you for coming, I appreciate it.
All right.
Arizona, all right.
Yeah, Arizona. Hey, where at?
A road trip,
Yeah, it was a road trip. Where at in Arizona?
you know, by Catalina, well, that's North Tucson.
Okay.
I drove to see my cousin in Arizona. I live in eastern Massachusetts. I drove
Yeah.
to Arizona. It took me 6 days to get there. She lives in Kingman.
6 days,
Yeah.
that's a nice road trip.
Yeah, that was great.
Did you
That's the
go
first
on-
time I'd ever
did
done
you-
that.
Did you go on the Andy Devine Road?
Yes, I was on Andy
Did
Devine
you
Road.
eat at the old,
There's one restaurant there I ate
the
at.
Dairy Out Creamy Bar restaurant?
No,
thing?
it wasn't that one. It was a hamburger place.
Yeah.
Down near the touristy end of town.
Yeah, okay, yeah, I eat there all the
I
time.
met the folks at the Hualapai Amateur Radio Club also, and had dinner with them in December. That was a lot of fun.
Is Arizona nice?
It's really nice, yeah.
Did you go through Altman, the donkeys that walk around town?
No.
It's an old mining town.
Oh, okay. Now, I didn't see that, but we did go to the Grand Canyon. I'm not going
Yeah.
to drive that far and not see the Grand
Yeah,
Canyon.
that's it, yeah. Did you go to the North Rim?
I think it might have been the South Rim. I don't remember.
Get a chance if you go back over the North Rim.
Yeah.
You'll avoid a lot of tourists.
Okay. Yeah, there weren't many people there. It was about 35 degrees and windy, which
Yeah.
wasn't so cold for me being from Massachusetts, but
Yeah.
I'm sure it cut down on the local traffic.
Yeah.
You know.
35 degrees in
Very-
Arizona is like,
Yeah.
we're not even going outside.
Yeah, and it was very, very sunny that day. It was
What do you
great.
think of this humidity here?
Oh, you feel it right away.
Oh, man.
Yeah,
I don't know how these people live.
when I got to Missouri, you know, I'm driving through Kansas, about the time to get to eastern Kansas, you feel it, and start
Yeah.
feeling it. Missouri, it was just like, holy crap, this is, but, yeah, I kind of, you know, it's,
Where y'all from? You got anybody else from Arizona?
yeah, I just installed Fedora.
Yeah.
I haven't used Linux before, but I want to get away from Windows.
Farther north.
Do you have a recommendation for better OS for?
Montana.
I'm going to talk today about versions of Linux that work well with the stuff that I created. Red Hat's not one. All the derivatives of Ubuntu are the ones that I work with. And yes, in theory, I could make it work with Red Hat.
Yeah, you know, I mean, it's enough just getting used to it.
Sure.
To make stuff work. I keep having the size of background, just easier to slide.
Yep. You need a big screen to do a lot of this stuff. You need a big monitor to do a lot of this stuff. The small laptop monitors, if you do FTA, grid tracker, and watch things on DX Summit, and fire up Amplify, before you know it, you have no screen left. And you really do need a good 40-inch monitor to do it. You'll see pictures on QRZ. Many people's shacks have 2 and 3 of those nowadays. And they're not particularly expensive anymore. Yeah. A couple $100 a piece in many cases.
Where you're traveling, I just got to do
Well,
that.
sure.
You know, I mean, it's another hassle. It's a minor deal.
Yeah.
Just changing the background size in order to get files.
But see, with my laptop, I just use that for traveling around and doing the talks. Here, I put it on a thumb drive because I knew they'd have the laptop set up. I didn't want to take all that apart. You never know what you'll run into. But I'm looking forward to the talk, and thanks for coming. Appreciate it.
Yeah, I want to talk to you out.
No, we're going to start in 6 minutes.
Glad for change.
I got the one that's about.
How you doing?
Good morning.
Can I ask you a real quick question?
Sure.
First of all, it's nice to meet you, but WinLink, do you do any work with that?
I don't because it's proprietary.
Okay.
I only will put free and open source software on the collection for 2 reasons. Philosophical, and if it's proprietary, I don't have the legal right to register it.
Okay. What about something like PAC or something along those lines?
What's this now?
Here's the problem. Okay, I work for Aries in the western Pennsylvania region, and the Red Cross insists that you use a means of communication that involves WinLink in order to send information back and forth.
Yeah.
And I want to stay in the Linux environment, but in order to do so, you're either using Wine to do the proprietary stuff, which I don't want to do.
Right, I can't do that.
Yeah, but they also have this thing called PAT.
PAT? I'm not familiar with that.
Okay. Let me take your card, and if you're interested,
Yeah,
I
send me an
will
email
send you
after.
information about
Remind me
it.
that we had this talk, and we
Okay.
can go further
I
into
would
detail.
really love your help if you can help me get this fixed. All right.
Oh, there you are. How you doing? Great to see you.
Sorry, I'm all over the
That's okay.
Just test your microphone, make sure you got something.
CQ, CQ, calling CQ. That's a little quiet, perhaps. CQ, CQ, calling CQ, calling CQ. Kilo Bravo 1 Oscar, India, Quebec. How copy? Back row, how copy? Good? Okay. All right. Got it. All right. I'm going to use 2 of these. Testing 1, 2, 3. And I don't know if those audio settings relate to what he's doing in the back to record it. I'll let you guys handle that. And thank you for putting the fence around here so in my animation I don't fall off with too much coffee.
I expected them to, I expected this to be a little different. They should have had the stage up against the back, but you know what? I couldn't change it.
Testing, testing, 1, 2, 3. Testing, 1, 2, 3. Kilo Bravo 1 Oscar, India, Quebec. It's got a nice echo to it. All right, let's try the other one. Testing, 1, 2, 3. Testing, testing. Testing, testing. Nope, they say it's too low. It's got to go up.
I know, you just keep talking and I'll be the audience.
Oh, telling me to keep talking is an easy thing to do. Oh, there we go. I can hear myself now. Okay. I don't plan to kiss this microphone. I'll be back a little bit.
Yeah,
Okay.
yeah, and get closer than that, so that we don't have to define a law.
Get closer than that? Okay.
Source closer to microphone equals less or better signal to noise range.
Okay, very good. Thank you, sir. Appreciate it. Folks, don't be afraid to sit in the front. This isn't Blue Man Group. I'm not going to throw water at you. Although if you're a heckler, I might. Check your back monitors.
Yeah. They're working on the it's just price monitor information
Okay.
that'll come up there.
No sweat. Is that the beep that says I should get started? 1 minute. All righty. Good morning, everybody. Welcome to the Dayton Hamvention. Welcome to the talk about Andy's Ham Radio Linux. My name is Andy. I'm KB1OIQ, and I spent Tuesday and Wednesday driving here from Eastern Massachusetts, and I'm very happy to be here today. So thank you all for coming. So just a little bit about me. I've been in the hobby since 2007, and I gradually earned up to my extra class privileges in 2009. I was a ham radio club president for about 10 years in Westford, Massachusetts, which is about 25 miles or so outside of Boston. And I did some stuff with the section for a couple of years to help out. I founded my first Linux users group in 1997 when I lived in Worcester, Massachusetts, and that is still going strong today, although I haven't participated since about 2006 because I moved out of that area. I founded and was acting president for many years of the Chelmsford Linux Meetup Group. That's the town to which I moved after I lived in Worcester, and that went until 2020, and unfortunately COVID killed off that group, but people still get together and do fun things. I did some instruction for the town's adult education program at night between 2004 and 2011, and when you think you know something and then you go to try to teach it, you find out whether or not you really know it. And that was a great experience both for the students and for me. And I've been a Linux user since 1997. None of my computers at home run Windows or Mac or anything else, and I've been very, very happy that way. Recently, I retired in August of last year. I was a computer engineer. I did digital logic verification, so I literally lived in simulated reality, and I could change it with one line of code. Wow, it's too bad life isn't like that. But I very much enjoyed the career. I spent my last 14 years at NVIDIA and had a great, great time. So now I have more time to do ham radio projects, Andy's Ham Radio Linux, and so forth. So my most recent interests, I've actually developed an interest in bringing antique radios back to life, mostly AM radios, FM, a couple of ham radios I've done so far. I wouldn't call it restoration because I'm not trying to make it look original, but I do repair it and make it work again. I also joined a makerspace up in Nashua, New Hampshire called Make It Labs, and they have all sorts of great equipment available for people who want to build things. And it's the largest makerspace in New Hampshire, and it's a really great group of people. I'm glad I joined. So my first project there was I fabricated a wooden box for a 1940s FM radio chassis, and I was very happy with how it came out, and I got to use a laser cutter to cut the wood to the desired proportions, so that was great. And Solder Smoke had a direct conversion 40-meter receiver that I built recently with some friends and had a lot of fun there. Fox hunting, POTA, lately I've been watching DX World and chasing some rare DX to get my totals up. And of course, I spend time with Andy's Ham Radio Linux, recently having put in some updates for the AHRL Teachers Institute, which I'll talk a little bit more about later. So what are my goals here? Well, my goals are to promote Linux, of course. I personally think it's the way to go. But I also want to give something back to both the ham radio communities and the Linux community, and this is one way that I do that. So I wanted to create a software collection that contained as much ham radio software as I could possibly find, but nothing proprietary. Everything has to be free and open source or similarly licensed for two reasons. One, philosophically, I'm not into proprietary software. And two, I don't think I can legally redistribute somebody else's proprietary software. So I just don't go there. Now, if you use this and you choose to install a program that's proprietary, that's on you. We could have an adult beverage and I'll try to talk you out of it, but it's your computer, so you need to do what you think is right. And I don't do anything to stop anybody from doing that. The goal, and it's a lofty one, everything just works. Now, that's almost never true on any computer on the planet, but that's the goal, because I want people to use the software to have fun with the hobby, not have yet another headache of a computer to deal with. So that's the goal. And that's how the idea of Andy's Ham Radio Linux started. Now, you can tell I'm not a marketing person, I'm an engineer, and that's why it's named the way it is. So what is Andy's Ham Radio Linux? As I mentioned, it's a ham radio software collection that I found on the internet. Maybe 2 or 3 of the programs I wrote a long time ago. Everything else was written by other people around the world. And all I've done is collected it all in one place. I packaged it up and made it easy for you folks to install and use. And now multiple Linux flavors are supported. So if people heard my talk last year, I was talking about making that possible to run on more flavors of Linux and also on Raspberry Pi. And 3 months after I gave the talk last year, I released the first version where that happened. And so far, so good. So Raspberry Pi OS is supported now, and the menus are customizable for ease of use, but I customize them for you, and I put things in categories that I think make sense. But if you know where to poke for the text files and whatnot, you can change that if you wish. So in the past, how did I do this? Well, version 25 and earlier were heavily customized, or we might say remastered versions of Ubuntu Linux. So I took it, I remastered it, I created an ISO file, and I put that on SourceForge for people to download. And by some definition, it worked very well for about 13 years, but it wasn't perfect. It was not easily customizable by the user. You got Ubuntu, you got what I put on there, and if you knew how to do, install and remove packages with the APT system, you could customize it, but many people haven't yet learned that skill, so they felt it was limiting. And no other flavors of Linux were supported. And many people would say, well, why can't I run it on Debian Live or this version or that version? And it just wasn't possible back then. And every release was handcrafted, New England old world handcraftsmanship, and it took a lot of time, especially when I did both the 32-bit version and the 64-bit version many years ago. I was doing the same thing twice. And so that was kind of tedious and kind of time-consuming, and I didn't write anything down. It was all up here. So when I would do the next release, I'm like, oh yeah, I have to put a hack in for this program to make it work. What the heck did I do? And I would have to relearn things, and it was just kind of slow and inefficient. But worse, there was no documentation. So if I ever get sick of the project or somehow fall off the edge of the planet, nobody knows how I did it. And that doesn't serve the community well. So I wanted to fix that. And also, the ISO file was huge. It was 5 gigabytes pushing 6. And some of you who have high-speed internet would say, well, that's not a problem. But for other people, that's a big problem. And on a few occasions, I've mailed thumb drives to people so that they can use this because they had issues downloading it. And there was no good upgrade path between versions of Andy's Ham Radio Linux. You had to save off your home directory, reinstall a whole new ISO file, put your home directory back. And yeah, many people did that, but granted, that wasn't as convenient as I thought I could make it. So I think I've addressed all of those issues with the new way that I'm doing it. So starting with version 26, which was around, July, August, September, I forget exactly when that came out. The first thing the user would do is install a supported flavor of Linux, and I'll talk about which flavors are supported. Now, there may be flavors out there, and there probably are, that are not supported, but this works anyway. If you discover that, send me an email, and I will add that flavor of Linux to the supported list so that it opens up the options for people. So after your Linux is installed, you get the programs you want, you configure it the way you want, you grab the tar.gzip file off of SourceForge, and you install that following the instructions that I provided. And then, by magic, everything just works, right? Or at least that's what we hope, right? One person said theirs worked. I'm glad to hear that. Thank you. I hope everyone else can say that. And then lastly, have fun with the new software. This is a hobby. We want to have fun. And so go through the menus, see what's there, and you might find out a different aspect of the hobby that you had never tried, and you might try it because of this. So what are the, in more detail, what did I change for version 26? Now there's an installation script. It's just a bash script, and it serves not only as documentation, but you execute that script when you do the installation of Andy's Ham Radio Linux. I released that as open source. So if I fall off the edge of the flat planet, then somebody can pick that up and go with it. Or if somebody believes that they can do something 10 times better than what I did, please do it, right? It's all right there. It's open source. It's meant to be built upon. And the installation script is customizable. So if you look through it and say, I just want these programs, I don't want those, there's a very easy way to customize it. And I discussed that in the Getting Started document. The file that you download is much smaller. The tar.gzip file is now 600 megabytes. And in that is the installation script and a few source tar files so that you don't have to chase them around the internet or worry that the link changed since I released it and now you can't do it. I've taken care of all that for you. And multiple Linux flavors are supported. And let me go down that short list. Debian Live and Linux Mint Debian Edition are now supported. Various Ubuntu flavors, regular Ubuntu, Kubuntu, Xubuntu, those are all supported. The one I use is Xubuntu, just because that's what I like. Linux Mint Cinnamon is now supported, and Raspberry Pi OS is supported. I recommend Pi 4 and Pi 5 with 8 gigabytes of memory. You'll have a much happier experience if you load it up with memory. And Pi 5 I think is better than Pi 4. Pi 4 is a little pokey to me, but Pi 5 seems to work pretty well. Someday, if you want to update Andy's Ham Radio Linux, all you have to do is download the more recent tar.gzip file and install it. And it goes right over the top of the previous one. And again, in theory, everything just works. If you discover that that's not the case, file a bug on SourceForge or send me an email and I will address it. So target computer. Well, nowadays people have computers where other operating systems say, oh, this computer is not good enough to run their stuff. Linux will run it just fine, right? You hardly ever have an issue like that with Linux. Now, maybe you don't have enough memory, maybe your CPU is a little bit slow for what you want to do, but it will load up and it will do the best it can to run, and largely you'll have a good experience. Why? Because most ham radio programs are not CPU intensive. So an older computer will work just fine. If you've got a 5, 6, 7-year-old laptop that you thought you were going to throw away, no, load Linux on it, give it a try. You'll be pleasantly surprised. And I also mentioned Raspberry Pi 4 and 5. 2 gigabytes of memory is an absolute minimum. I don't recommend that you really do that. I recommend that you go 8 gigabytes, and that's more important with Raspberry Pi because I believe you have to purchase it with the desired amount of memory. You can't just install memory after you buy it. Storage. After you've done the Andy's Ham Radio Linux installation, AHRL takes about 10 additional gigabytes. That's hardly a problem for anybody these days. And you have to have a functioning network. Why? Because about half of the programs are installed from an Ubuntu repository. And of course, you have to have the network to be able to get there. And the other half of the programs are compiled from source, again, which I supply. So now that I've convinced you all to run Andy's Ham Radio Linux, well, let me ask, how many people are running Andy's Ham Radio Linux? Show of hands. Quite a few, okay. How many people are going to go run off and do it at the hotel tonight after the day is over? A couple of you, thank you, I appreciate that. Okay, so if you want to download this, go to sourceforge.net or abbreviated, SierraFoxtrot.net. Search for Andy's Ham Radio Linux or my call sign, KB1OIQ. The current version is version 26 Delta. I just came out with that at the end of April, and so far so good. It's around 750 downloads in about 3 weeks. I'm very pleased about that. Now, when you go to that website, you'll see the big green download button, which I configure to give you the most recent version, and right now that's version 26D. Please, please, please download and read and follow the Getting Started document. It's just that, getting started. How do you install it? What do you do? It's really pretty simple, but people who file bugs and have problems, 99% of the time, it's because they didn't read it. So I didn't create it to waste your time. It's only a couple of pages, and you will save yourself infinite grief if you would please read it. So when you go to the SourceForge website, it looks kind of like this, and you'll see the big green download button there, and usually that's all you have to hit to download that tar file. And if you click into the files area, you'll see the different versions of Andy's Ham Radio Linux there, and the latest one will always be on top, version 26 Delta. You could download an older one if you wanted, but I'm not sure why you'd want to, but they are there. And then if you click within that directory, you'll see a whole bunch of files here. You'll see the Andy v26 delta.tar.gzip and the MD5 checksum file. Download that. Run the MD5 checksum before you install it to make sure that your download was not corrupt. That causes very strange problems when you have a corrupt download and try to install it. And then you'll notice some other files in there. There's a list of the software. There's a change log. What did I change from the previous version? The changes file has that. You'll see the Getting Started document. And it's there in 3 other file names because, believe it or not, people still can't find it. So README, README.txt, and README first are all copies of the Getting Started file. If folks can't find it after that, I don't know what to do, right? It's like I tell people, if you can't cut a tape measure to length when you're making a Yagi, I can't help you. So please, follow the instructions in there, and afterwards it tells you to reboot the computer, but please do so anyway. Yes, I know on Linux you don't normally have to do that, but because accounts are added to groups and so forth, you really do need to do that to get that stuff updated. And then peruse the menus and see what's there. So there are some differences in the way the menus are presented. Now, some Linux flavors support multi-level menus where you'll go down the menu and it says Andy Ham Radio Linux, and you slide over and there's a bunch of categories, and you slide over and you see the software in said category. And that's what I prefer, and there are some flavors of Linux that support that style of menu, but not all. So for example, Linux Mint and Kubuntu don't support that style of menu. So you'll see a menu that says Andy Ham Radio Linux, and then a big long list of about 90 programs in alphabetical order, sometimes with a quick hint as to what the software is. To each their own. I mean, they all work. One of the things I do, I used to be a verification engineer for digital logic circuits, so every single menu, I go through it and make sure the program comes up before I send it out to you, because that's just a dumb error. I don't want to hand you software like that. So yeah, it's a little tedious because there's about 90 of them, and I do it for multiple flavors of Linux because once in a while I find a weird glitch in a Debian version that doesn't exist in an Ubuntu version, as one example. So I check it all as thoroughly as I can, but I'm only human. If I make a mistake, call me on it, I'll fix it. So real quickly here, this is what the menu structure looks like on a Raspberry Pi 5. You can see the Andy Ham Radio Linux, the second level menu, and then so forth. And the only difference in these is they're just graphically, they appear different. They all have the same information and the different menu structure. So here you can see on Debian Live where it goes through, that's the multi-layer menu structure that I was talking about. Whereas here on Linux Mint Cinnamon, it just has one layer, and I've scrolled down a little bit to get to software that begins with the letter D. And Kubuntu is similar. The graphics are different. It's all there. So what I wanted to do is go through at a very high level. I'm not going to have time to go through 90 pieces of software, and you'd all be walking out on me after the 5th one if I did that. But I wanted to give you a feel for what's in here. And these are things that I found. If you find other free and open source software that's related to ham radio, send me an email. And if it looks good, I'll put it in. I'm happy to. Many programs that are in here I didn't know about, and the user community educated me on that. And so that's where a lot of this comes from. So in the antenna-related software, you can see there's quite a few programs in there that do antenna modeling and talk to your rig expert analyzer and things of that nature. This is a program that I wrote many, many years ago called FL MoxGen. It copies the look and feel of a similar Windows program, but it was totally written up in a clean room environment for people who want to compute the dimensions to build themselves a Moxon rectangle antenna. This software will also create a file for antenna modeling, and you can print it and have a PDF printout so that you can take it to your workshop and build it. And I built one of these, and it works very nicely. You can also model that antenna in XNEC 2C. It creates the file. You just load the file in. You don't have to know anything about the tool to see that, okay, it's the vertical orientation of the antenna, there's the radiation pattern, and the window that's partly occluded on the left shows, the front to back ratio, max gain, predicted SWR, and that sort of thing. And we all know with antennas, your mileage may vary, but this is at least, a good starting point. This is a program that I found out recently, and I like this program. This is the community edition of Morse Runner. It's been available in the Windows world for a long time, and typically I did not install anything from the Windows world because those programs typically are not open source. But this one is, now that it's the community version. So I took a dive and said, well, my experience with Wine hasn't been the best, but let's give it a try. This program works very, very well with Wine, at least in my experience, so give it a try. For people who like CW and want to simulate field day and other contests like that, this software is very, very good for that. You enter the call sign that you heard in the exchange, and you hit enter, and it creates a window that looks very much like your logging program, and a few seconds later it will tell you if you logged it correctly or not. And I think it's a lot of fun to run this program, so I'm happy to put it in there. AHRL Teachers Institute, I hope people have heard of that program. It's a great program. I spoke to Steve Goodgame last night. He leads this up, and my understanding is that first of all, about 6 months ago, a year ago, they asked me if I would put in a bunch of software to aid their efforts to do the STEM education of teachers with Andy's Ham Radio Linux. So I gave them their own menu and put in the programs that they asked me to put in. Many of these programs are already there. Some were different, and they are also listed in other appropriate menus as well. And I talked to Steve last night. The first time that they're going to use this software to teach the teachers is going to be in early June. So I very much look forward to hearing how that experience goes with Steve and company. So I appreciate that headquarters knows about this and sees the value in it and wants to give it a try. So you can see a whole bunch of different programs there that I put in just for the Teachers Institute. Documentation. How many people ever read the documentation? Wow, that's a lot. I'm actually surprised. So, people who are familiar with Linux systems know about man pages for some of the programs. You can go off to various websites and find it. And I put a few documents on here just to help people out. But if you have trouble with a piece of software and it's not related to Andy's Ham Radio Linux, if you're not sure, ask me. I'll direct you in the right place. Go to the website for the software. I could call it RTFM, read the friendly manual, and maybe I will in another release, but that would get people's attention for sure. But I tried to put some things here for you, and some of them are links to the website for the software, but I wasn't consistent. I didn't do it for all of the software, and maybe I should, or maybe I should just get rid of this. I don't know. But it's there for now. And if you click it, it will bring you into the directory where I keep these files. And this set of files in this directory is how-tos that I've written based on my experience. So how did I get M17 going, which is the digital codec, codec 2 that folks are using on 2 meters and 440 and so forth? How did I get some of these other programs working? I have a friend with manual dexterity issues due to Parkinson's, and I found ways that people with some dexterity issues can still use this by making the window borders bigger, slowing the mouse down, and so forth. And so I wrote up the manual dexterity solutions in that first file, hoping that somebody would find it useful. And then, of course, you can see at the bottom one of the manual pages for one of the older programs. Digital modes. We have lots and lots and lots of different digital modes and lots of software to help us, utilize that part of the hobby. So you can see a long list there. The FL programs, I affectionately call it the FL family of programs from Dave Freese, W1HKJ and company. A lot of programs that those folks have put together for us to use. People have probably heard of FL Digi, at least, if not the others. And those run on all 3 major operating systems, and it's my pleasure to put them here. So WSJTX, anybody who's done FT4 or FT8 is probably familiar with this software. You've got the waterfall at the bottom, you've got the decode of the digital information on top. This program not only saves a log of your contacts, it can communicate with Grid Tracker, and your logs can be uploaded one at a time if you've configured Grid Tracker accordingly. And it also will send your log to Xlog. How do I know this? I'm the Xlog maintainer. I made it work because Xlog is the logger that I most often use. So I'd be surprised if you're not familiar with this software, but this is what people usually use when they're doing FT8. The other one is MSHV, which is also included. Grid Tracker 2. I think this is an absolutely awesome piece of software, and my hat is off to the people who wrote it and continue to maintain it. This software will help you keep track of grids, and it's not just for 6-meter fed fish. Whenever you communicate with somebody via FT8, it will put a mark on the map. And when you configure this to talk to Logbook of the World, for example, it will download the log and say, oh, that contact was confirmed, and it changes the color. And so you can see which parts of the world you and your antenna system and your time of day and whatnot are able to communicate with. You can't see it very well, but there is a green line on that map that shows a QSO in progress. There's a couple of them, and that's what your radio can hear. Okay, is those QSOs in progress. And when you make a contact, that's a red line that shows who you're talking to. One cool thing about this is you get an idea of your antenna's behavior and the power that you're running and so forth, time of day and whatnot. So I find it very helpful. I also find it really helpful because the bottom screen allows you to filter all the contacts that are coming in. Maybe you're only interested in people calling CQ, or maybe you're only interested in grids that you have not yet confirmed or DXCC entities that you have not yet confirmed. This will let you set all of that up. Or maybe you only want to focus on that DX station. Where are they? You can set that up in here. It's highly customizable and really, really good. The top right actually shows you, and I think it talks to PSK Reporter to get this information, what band is everybody hanging out on? And so if you get on there and you find a dead band, you look at that and say, oh, wait a minute, everybody's on 40. Okay, you might want to go there. So this is a fantastic piece of software, and as far as I know, it also runs on all 3 major operating systems. Electronic design. This is a part of the hobby that I don't know if as many people do it as they used to, but I wanted to put some software here for people who do. So how many people are familiar with Arduinos and maybe have programmed them in the past? Good number. So the Arduino software is in here for you to use. I've used it for various projects and found it very helpful. The micro-BitX and other BitX related projects from India, last I knew they were using Arduino inside there, and I had fun hacking the daylights out of the software to make it work in a way that I found more pleasurable. And because it's open source, you can do that. And there's many people out there that do that for micro-BitX, for example. I think they're up to ZBitX now. There's a newer one out. For people who want to wind their own coils, there's always well, how many turns do I have to do? And oh, darn it, I didn't put enough wire on, start all over again, and all of that. I suspect many of us have been through that pain. This software will make a prediction if you give it the wire gauge and the diameter of the thing you're winding it on and so forth. You get a ballpark idea. Add 8 turns anyway. and then measure it, and then trim accordingly. It's a heck of a lot easier to subtract turns than it is to solder the wire together and try to make that work, although you can. So I found this to be a nice piece of software, and it also understands the different ways you might wind it. Is it just one layer of wire, or is it two, or are you spacing them out? What are you doing? And all of that matters for the inductance that results. I haven't drawn schematics in a lot of years, but many people still do. The KiCad software is in there for you to draw schematics. There's many people out there that design kits and do circuit boards and all that kind of thing, and this software can be very, very helpful for that. HF propagation, we're supposedly on the downside a little bit of the peak of the sunspot cycle, but propagation is still very, very good for most of us. And there's quite a bit of software here that you can use to make a prediction. Okay, I want to talk to, pick a country. What's a good time of day? What's a good band to do it on? Put in your power and something about your antenna, and you can make a prediction as to what that might look like. Now, the sun might have different ideas. There might be solar storms and whatnot, but you get a good idea of, do you even have any chance at all of making this contact? Sometimes when it says 10%, you get lucky. You make the contact anyway, but it's not highly likely in most cases. So I found out about this program recently. This is called HamClock, and this is a really excellent program. Some people make standalone systems with a Raspberry Pi Pico and this software with a monitor. This stuff looks, forgive me, way cool on a 45-inch HDI monitor. Don't ask me how I know this. Okay, it really does. So this software has more bells and whistles than I think I can articulate. Each of the panes across the top can be customized. So the one that has my call sign can be customized. The one that says solar wind next to it, you can customize all of these. The map and what it displays can be customized. And in demo mode, it cycles through all of the different possibilities. So you can see just what this software can do. My only very, very minor complaint is when you click the window to configure it, it's like a 6-point font. It's awfully small, but it's there, and it's kind of necessary because they're jamming a lot of stuff into a small piece of screen real estate. But it's excellent software. I encourage you to give it a try. One of the things I did with that is I put in the grid for a recent DXpedition, and I wanted to see what band are they on? Now, sure, I'm looking at DX Summit, but sometimes people post false info there and whatnot, and I could see, okay, they're mostly on 20, and it's getting to this part of the world, which is not me. So, okay, either they're not talking to my part of the world, or maybe propagation isn't amenable for that. But this helps an awful lot with that sort of thing. VOA cap. VOA cap has been around for a long time. It used to be a standalone program, and several years ago, it turned into a website that anybody can use. So if my Eastern Massachusetts location is on the red flag there, and I said, well, what happens if I want to talk to South Africa? So I put in, well, I'm not running 1,500 watts, but you could fill in your information about your antenna and your mode, and then you get this really nice chart on the left-hand side where the closer you are to red, the more probable it is that your communication will succeed at that particular time of day. So you can see on here, if you were on the like 15-meter band at 1700 UTC, you would have a really good chance of making the contact from Eastern Massachusetts. And whereas at 0 hours UTC on the 10-meter band, you basically don't have a prayer. Again, not to say it couldn't happen, but it's highly unlikely. So this is a really good program. You don't have to know much about propagation, just what's your mode, what's your power, and at 50,000 feet, what's your antenna like, and that's it. Logging. Almost every ham that I know logs in some sort of logging program, and I put several in here for you. And one of them is a relatively new addition, which I'll be sure to touch on. So this is CQR log for Linux. People have told me this is a contest level logger, but I'm not really a contester, so I can't say for sure. But this feeds its information to a database, and it will talk to various online resources to help fill in the blanks when you type in a call sign. And you can log all sorts of different information in this logger, and many people like it. Not 1mm. How many people here have heard of N1mm, the logger? It's apparently pretty popular. Somebody thought it was so good that they decided to write it for Linux. Okay, this is a free and open source version called not 1mm. Not to be confused with N1MM, but that version is not free and open source software. This one is. And I'm told that the person who wrote it admits on the website, I blatantly stole the look and feel of N1MM. And plagiarism is indeed the highest form of flattery, right? So now we have this on Linux. Other than dabble with it quickly, I have not used it, but it looks like it has a lot of promise for people who want to log that way. And if you know N1MM already, in theory, you should feel right at home here. So this is a fairly recent addition that a user told me about. Xlog. Now, people have picked on me. They think this slide's a little old just because at the bottom right it says August 2010. Well, it is. This is mature software. Why? Because nobody's reported a bug to me about it in the last 5 years. Although I have updated its ability to output an ADIF file that matches the most recent ADIF specification. That's about all I've had to change here. I use this logger all the time. It does what I need it to do. It's meant for casual operating, but if you know a few keystrokes, I have used it for field day. I am Kilo 2 Hotel, 13 Colonies, Massachusetts. I'm one of about a dozen operators. And in a week, I put 2,200 calls in the log with this logger. It can be done. And it's not difficult to do. When you have to move the mouse and click and this and that really slows down your QSO rate. But it saves everything as a flat text file, which is great when you mess up because Emacs or VI or whatever you use can go in and fix it if you're careful. It's yet another logger. And many years ago, I took over maintenance of this program from the gentleman who had written it because he just didn't want to do that anymore. So it's out there and many people use it. NBEMS, the Narrowband Emergency Messaging System. I'm not an MCOM kind of guy, but I put some software in here for folks who do that sort of work. And it is an alternative to WinLink. And the thing that where this wins is twofold. One, it's free and open source software. Anybody can use it. WinLink is proprietary. And secondly, it does not rely on any existing infrastructure to work. So if something hits the fan and my radio works and your radio works, we can do this. It doesn't involve any servers at all that have to be there. And you'll see that the FL family of programs is well represented here. FL Digi, FL AMP, which makes sure that the message was transmitted without error. It does a ping pong back and forth between the sending and receiving station to make sure that the message got through clearly. FL Message has the different ICS forms that MCOM folks use. And then SILFeed is an email tool that integrates nicely with this for sending very short text-based emails. This does run on all three major operating systems because the pieces of software that are used run on all three. Rig control. I put a few rig control programs in here for your use. And well, let me back up a second here. Chirp. A lot of people really like Chirp for programming their HTs, for programming their mobile rigs, and so forth. I've used it with great success. Once you get over the fact that it comes up with a blank screen, like, okay, now what do I do? Once you get past that, you're all set. It looks very much like a spreadsheet. You fill in the blanks, it programs your radio, and there you go. Nice piece of software. WF View is a program that's been out there for a couple of years. As far as I know, it only supports ICOM radios at this time, but you get a selection of features of the radio that you can run from this graphical interface. I don't know if you can use this in a remote setup or not. I've never tried that. And naturally, with any graphical solution like this, you're not going to get at every single feature of the radio. It just wouldn't be likely to do. But you get at a lot of features this way. And this gentleman continues to update the software and come out with new versions and so forth. Yes. Okay, so it would work in a remote situation? Okay, so I'm informed that it does work in a remote situation, and I know more people are doing that kind of thing for any number of reasons. Is it? Okay, so some people believe that this is better at doing that than the software that you pay for from ICOM. I can't say for sure. I haven't run it, but this is at least one gentleman's experience. Okay. Right. So I'm told it works with radios such as the ICOM 7100 that don't necessarily, well, that one does not have a waterfall. I've tried it briefly with my 7300, and then when I bought the 7610, I tried it with that. Seemed to work just fine. Okay, satellites. I dabbled with satellites many years ago. I built myself the Kent Britain cheap Yagi for satellites on an old broomstick. I built myself an AHRL rotator, and one very cold January day, I set this up in my driveway with lots of trees around, and I made my first satellite QSO. Now, I lived in Chelmsford, Massachusetts at the time, about 15 minutes south of the New Hampshire border, and wouldn't you know it, my first contact was a gentleman in Nashua, 15 minutes away. But he had a beautiful QSL card, right? So it works. And I was happy, that something I built actually worked pretty well. So for people who are, hang out with AMSAT and do, those sorts of satellites, the Foxtel-M program is in here. It lets you decode telemetry information from the satellite, and I believe this software also sends it to AMSAT so that they can keep track of the health of their satellites. I'm getting a nod here. GPredict is software that I use. This software has been around, probably 10 years or so, maybe a little bit longer. It is mature software. It's pretty solid. Not only can you configure the satellites that you are interested in, and it will show you the footprint on the Earth, it will download the TLE file, which allows the software to predict with high accuracy where the satellite will be. And when you start doing that, you find that your life revolves around the satellite, not the other way around, right? But that's okay. And so this software also will talk to various AHRL rotators. It will talk to various radios to deal with Doppler shift and things of that nature. And I made sure that this would talk to the homebrew AHRL rotator that I built and work quite nicely. Software-defined radio. More and more these days we're seeing software-defined radios out there for people. There's a lot of software out there for software-defined radio. There's no way I could put all of it in here. Some of it is specific to a piece of hardware, some is more general purpose. But I picked a few programs that I'm pretty sure at least work with the RTL SDR dongle, which is very inexpensive. It's a good way to get your feet wet and see what's possible. But usually after that, people buy more sophisticated hardware that has more capability. So one program that I put in here that I think people will like is the GNU Radio Companion. And with this program, you can literally draw a block diagram of your signal processing algorithm. And you can, so like, for example, if one of the blocks was a filter and you right click on it, you can set the filter bandwidth, you can set how steep the skirts are and so forth. And by setting all the blocks the right way and interconnecting them, when you push the go button, it will create Python code for you and it will run that signal processing algorithm. One of the boxes would represent your SDR hardware and another box represents your speaker, for example. And so many different SDR devices are supported, and there's an awful lot of tutorials online. I would encourage you to go to those tutorials to try this out. This is very sophisticated and complex software. It can do a lot. So this is an application that I borrowed from the internet where I have the RTL SDR source on the left. I've got a low pass filter and some other things, and the audio sync at the end is where this comes out your speaker. And there's some GUI information on top. I basically set this up to pick up 4 local FM broadcast stations, and with a click box to pick which of the 4 stations I wanted. I don't think I put that slide in here, but it was that easy to create an application that does signal processing. Another program that's out there for doing this sort of thing is called GQRX, and folks might recognize that frequency as a NOAA weather radio, and I'm lucky to have a few stations nearby that do that, but I centered on the strongest one. When you configure it on the right-hand side to tell it what kind of signal to decode, you'll hear it out your speaker, and it works quite nicely. I didn't know what to call this menu, but people asked me to put in a variety of programs for tracking objects or people, and not in a surreptitious way, but so for example, APRS, if you have a GPS hooked to your radio and you wish to transmit your coordinates, you can do that and people can track the location of your car, let's say, or maybe you go hiking and you transmit that information. And there's a couple of other programs here. Zaster is one for APRS. I believe YAC, YAAC is another one that does that. But there's other things in here that people will often want to track. And one of them is aircraft. And so this program called Virtual Radar Server is included. Now, I live within reasonable proximity of both Logan Airport and Manchester, New Hampshire's airport. So there's lots of air traffic. This stuff is on 1.09 gigahertz. It's the ADSB protocol is what they use. Stick any old antenna out there. If you're close enough to an airport, you'll hear it. And after 5 to 10 minutes or so of this software, it will draw pictures for you of the aircraft, and you can click on those, find out the aircraft's call sign, where they're going, what kind of aircraft, and so forth. So this is along the lines of tracking objects. Now, what is the status of AHRL? So I first released this in May 2011. I released version 8 because I didn't think the first 7 versions were worthy of leaving my house. So I didn't release them. And 35 versions later, and no, I did not number them consecutively. So we're in 2025. I've highlighted that more flavors of Linux are supported. I think that's a good thing. Raspberry Pi 4 and 5 are supported. The users are telling me that's a good thing. So I want to thank all of you and the rest of the community, because I could do this work and I'd be happy with it, but it makes me happier that many of you are using it and trying it and having a good time, not only with the software, but with the hobby in general. The community has been very good about actively reporting bugs, which I do jump on and fix them. The community has been very good about suggesting new programs that I should include in this software suite. And if the download counts are any indication, their interest seems to be very, very high in this software collection. Now, I've theorized that maybe a couple of people have bad internet connections and they're persistent, but that doesn't answer how many downloads there have been. There have been a very large number of them, 750 in the last 3 weeks of the new version. So I remain very enthusiastic. I plan to keep doing this work for quite some time. I don't have an end date in mind, but I'm very happy to do this, one, because I like to use my computer this way, and why not do it so I can share it with all of you? So this slide was created about a week ago when I did a presentation for a local ham radio club. But at that time, so May 7th, there were just about 650 downloads of this software in not quite 3 weeks. So that number has gone up a little bit and probably will hit 1,000 downloads after it's been out there for about a month. So by version, now careful here, when I say version 26, I'm including version 26 alpha, beta, Charlie, and delta, because there are minor differences between the two. So you can see where the first few years, nobody knew about Andy's Ham Radio Linux, so the downloads were small, and then all of a sudden things jumped. One year somebody gave a talk about this at Pacificon, and they spoke to me about it ahead of time. All of a sudden the downloads jumped. One gentleman that I know went down to Brazil to talk to college students about Linux. He must have mentioned the ham radio work, because all of a sudden I had 500 downloads from Brazil, right? So word gets out. I don't know how it gets out, but this is one way for sure. So you can see where I've been very pleased to see the number of downloads. It doesn't look particularly steady because I don't keep each version out there for the exact same amount of time, but the gist is, it's getting a lot of attention. I was curious about this, downloads by geography. The SourceForge website creates this, and they go by IP addresses, so I don't know quite how accurate that is, but the first 3 or 4 countries are United States, New Zealand, the United Kingdom, Germany, and Spain. But if you scroll down, I don't have it on here, there's onesie-twosies from a large number of countries across the world. And so somehow people are finding out about this. In 2022, I was very pleased to get an email from the SourceForge folks that said, congratulations on 100,000 downloads. Thank you. I didn't download those, you folks did, so thank you very much. So SourceForge is the place to go. Search for my call sign or search for Andy's Ham Radio Linux. Hit the green download button. Be sure to actually read the Getting Started file. And please, if there are any problems, contact me. Send it to my personal email, put it on SourceForge, wherever. I have business cards up front here. If anybody would like my email, it's my call sign, Kilo Bravo 1 Oscar India Quebec @ARRL.net. And I will get back to you. It may take 24 hours, but I will get back to you, and whatever the issue is, I'll do my best to address it. There are several online videos of this presentation that are available. The folks in the back of the room are recording this on the Dayton Hamvention YouTube site, and I understand that this particular talk has had an awful lot of people watch that video, on the order of 6,000 or more. So thank you for your interest. I'm wondering if it's because I talk too fast and people slow the video down to hear what I've said. I don't know, or maybe they were at one of the other really great talks in this time slot. But either way, there seems to be a lot of interest, and I'm happy about that. The Rat Pack folks, if you search for them online, I think they have a fantastic library of talks, and they've been doing a lot to keep it up to date. And I was privileged to give them a talk via video conference earlier this year. And so you can search for Rat Pack KB10IQ as well. The difference there is you'll actually see my face, whereas on the Dayton Hamvention one, you won't. You get to decide. Okay, and look on YouTube for other videos. There are people out there that have done reviews of this software. I have not yet found a review of version 26. The reviews are for older versions, and they were spot on, but those issues have been since fixed. So this really is the last slide, and I think I'm right at the end of my time here, 2 minutes. So again, there's my email. Thank you very much for coming to the talk. I'm sorry it was warm in here, but I appreciate your patience. And with that, I will say have a lot of fun, and 7-3. Thanks for coming. Yes.
I found this because I'm looking at the forum still on Hamvention. Last week I just downloaded it on Sunday. And
Yeah?
the only mistake I made was it said enter your Linux username, the default software set.
Yes.
And I accidentally typed the name with an Apple. And I didn't see that at all. Okay.
Are you the speaker? Okay. This is over at 12:05. So I'll know about 12:03. Okay.
How will you do that? Lay that down.
Down there with airplane stuff. Yeah.
How about air conditioning?
Or it's on. Okay. And the other room's better. So what's going on? This is best for you right now.
Okay.
But if you look at it,
Thanks, Bob. John.
Yeah.
Thanks for all
You're very welcome. Hope you'll learn a few tricks today. All right, good.
yeah, go ahead and start at 10:15.
Yes, sir.
Anything else you need? I need
Air conditioning, I don't have any video to play. The live stream is working. Okay. We do have people waiting to watch it on the live stream.
Yeah.
You can probably check it on the web. We're a trash.
Here, I'll take it.
Well, I'm gonna have another one.
Okay.
And he also electronic still like that. And first thing you know, man, that yeah, they are okay. Six a.m. Probably slow down. Keep it TV and the serious development all night. Kind of put a super force. I get two and a half right from the shoulder. I hear the same TV was. One that were blue just like him. One that were blue and gold and came up. Fun thing. Former scout, scout then. He had two stars and I had two stripes in the front. I knew when he said I need a ball, I need ball, I need a right hand. Yes, sir. Right hand. When I had Brad, right hand.
Oh, there you are, Dave.
How you doing, buddy?
Okay.
You let me know when you want me.
Yeah, at the very end,
That's fine. We'll talk about VPN and start.
basically, if you could give people some tips on how to get going.
I'd be happy to do
Well,
that.
there he is.
All right, I'll just go find a place and sit down.
All right.
Oh, you got my case here too?
Okay. I'm going to do a quick audience poll. Sir. Testing. What? No, sir. What's your call? Oh. Is it working? Thank you. I'm glad it worked. Thank you. Try to help.
Never a picture
Of the group.
of the group.
I have the camera. In the back of the room at the end. Or?
Well, we take it now and we'll Photoshop.
I'll remind me because I'm going to forget.
I know. That's why I did it.
You want to get a group photo of everybody who's on the Zoom call?
Yeah, and basically for Carl, he put that thing together, and for years he's been trying to get a picture here at the forum of everybody.
Okay.
And I don't know.
We'll get over on that wall. There's room. And,
Yeah,
yeah.
I don't know what the health issue is there, but he's 80
Yeah.
plus.
I'll mention it. All right, welcome everybody. This is the K4 Users Group. I'm going to start with a quick audience poll. So if you could watch the screen, there's plenty of seats up front. You might be able to see the slides a little easier. If you come up closer, feel free to do that. So let's do a quick audience poll, and then we'll introduce Eric, WA6HHQ, to take some common questions and then any others you might have. There is a mic up here I can hand you if you want to come up and ask a question so the folks on the live stream can hear. I'm Bob, N6 TV, and let's do a quick show of hands from the audience. First question, anyone here who has owned a K4 for less than 6 months? You're new to the K4, please raise your hand. Whoa, we've got mostly experienced people here. I only see about 3 hands. So you've owned a K4 for more than 6 months. Most of the room. So you guys may find this stuff too basic, but I do have some new stuff at the end you'll see. Of that group, who owns 2 K4s? Smaller number, but there are a few. The only way to do remote until we get that box over there. Now, how many in the room do not own a K4, but they're seriously considering a purchase? 1, 2, 3, lots of hands in the room. So maybe you'll get something out of this too. Eric will have plenty to show you. And of course, he's got the booth right across the way in the building room, in room 1, in the building 1. All right, how many of you that have the K4 or want to get a K4 are planning to operate your K4 or a K4 remotely? So quite a few remote users in the room, almost half the room. That surprises me. I only have a little bit about remote in the talk today, so maybe and how many plan to order the K4 Zero remote control head that Eric's got over there? I'd say about a third of the room. Pretty good, maybe a fourth. Finally, how many want to plan to order the V-Pod, which is the enhanced tuning knob? It's like a K-Pod, but with the outboard, and it'll work with software. I guess I have one more question. And how many want to order the K4 HD Superhead, the front end? Whoa, more than half of the room, it seems. Eric's happy to see all these things. Come on up here, Eric. And just out of curiosity, anybody who plans to order a brand new KPA 500 or KPA 1500 soon, raise your hand. How many already have a KPA 500 or KPA 1500? Eric, we've what was it? Flooded the market? Satisfied the market. There we go. Not a problem. All right, Eric, you're up. So introducing Eric Schwartz, WA6HHQ, the co-founder, along with N6KR of Elecraft. Come on up. And you can use this mic here. Yeah.
I don't want to close that.
Don't close that.
I need to be able to put this down somewhere.
All right.
Slide that over sideways a little bit.
Right here.
Just to,
Yeah, I won't be able to face the room, but.
I'll hold it up. That's fine. Put my water down here.
Okay,
Okay.
so I've got some prepared questions for you. And I just want to remind you that this is live streamed and recorded. You have the right to remain silent. Anything you say, you're not under oath, but anything you say can and will be used against you in the forums, and you already know that. So here we go. First of all, when will we be able to get this in our hands if we order now?
Well, that's a good one. I should take a vote and see how many people can guess correctly. But no, this one seriously, one of the nice things with the K4.0 is we're using the same core software as the K4 to K4 stuff. So we worked out all the early bugs that many months ago. Minor changes for slightly different I/O in here, but not a whole bunch. Internal I/O, talking to the external stuff on the back of the radio. Right now, the determining factor for us is just the long lead time parts. We've nailed most of that, and they're coming in over the next 6 weeks or so. The overall date that we're giving at the moment, and this is pretty confident. It's going to be going to the field testers first, because obviously they want to make sure they catch all that, but we're actually producing production right after they get their units. We're bringing everything in continually. So we'll be shipping starting, it looks like, before the end of July on this. Everything comes in on time. There's no design issues. The final PC boards are out. You know, they're basically all getting fabbed there. By the way, everything is fabricated in terms of the sheet metal in the U.S., actually in Silicon Valley, or one facility down in San Luis Obispo does it for us. We have all the circuit board stuffing that takes place in California, as in our designer courses in the U.S. also. So we do all of our own stuff that way. Little things like accessories, like microphones and stuff, certainly come from offshore, but beyond that, and parts come from all around the world. That's the biggest if right now, also on pricing. But
So you're hoping end of July?
Well, hoping end of July or maybe even earlier for the field test.
Start shipping?
Yeah, start shipping. We started taking deposits. How many people have put deposits down in the room here? If you haven't, you can do it online. Just go to our website. It's a $500 deposit. It's refundable, of course. Have to do that. And that helps us to make sure that what we're ordering is sufficient to cover the people for the early adopters, obviously, for you guys.
All right, let's keep it rolling here.
Okay,
Next
go ahead.
question. When will the VPod and VK4 software
Okay,
ship?
VPod is after VPod and VK4. VK4 programmer's working on it now. We're adding a few more features to it and fixing bugs. It's basically working. I've had the VPod firmware working on a modified K-pod, and I'll digress just for a second on that. For those of you, including you, that want to modify their K-pods, how many K-pods owners do you have? Okay, got quite a few. We can run the same software that does CW in the K4.0 and also K4 to K4, the protocol that's sent up there. We can put that in. We already have put it into a K-pod for testing. And there's if you guys, anybody use the outputs on the K-pod that can turn on and off relays or something? I thought so. So you can take, there's a little stereo jack in the back that you could do that with. And if you take the box apart and take 3 transistors off the board, they just stick to your soldering iron when you heat them up, and you bridge across them, that becomes an input. You actually have pull-up resistors inside the PIC processor. I have one working in my booth like this, and I can send with the VK4 stuff, it'll send that protocol up. So the VPod also has more I/O and stuff, so it's going to take a little bit longer to come out. So you were asking VPod first, or yeah? So VPod is probably in the fall time frame here. I want to get the HD board out, and that's in process right now first.
That question's coming up.
Okay.
So VPod is
In the fall time frame, I think.
End of fall
Or earlier.
for Christmas for sure.
I sure hope so. Yeah, that'd be
And
a great Christmas.
you don't have a prototype of the VPod at the booth?
I'm sorry?
No prototype of the VPod
No,
at the booth?
no, I don't. I have a 3D case back at work that we're doing for it, but it
Okay.
hasn't been.
But it's like a larger K-pod.
Yeah.
When will the HD module be ready to ship?
Good. What? Oh, VK4, the software will be out, gosh, that's going to be out before the end of the summer because the stuff we have on the to-do list is not that long. I've got functional stuff in the booth. I can transmit CW and sideband with that. I'm not doing that here because you probably hear more noise in the background than anything else coming out down the sideband. But that is in pretty good shape, but I have some features that are missing on it right now. We have to get into it, but they're not like big bugs or tough to fix things. So I've got a person working on that right now.
And you can plug an unmodified K-pod into
Oh yeah, it
VK4,
works. It just works as a
and it works
K-pod with all the usual K-pod stuff
All right,
works.
how about that HD board? I've seen it at the
HD
booth.
board, I have one in the booth. You can actually see it. It's real. This actually has now been fully tested out in the lab also. Just to give you an idea, before I answer time frame, we're getting about, the key thing with the VPod is giving you better blocking dynamic range. That single signal immunity from guys on field day, verticals on the beach for DXpeditions, your neighbor down the block that runs a kilowatt in the same band. K4 has no problem with different band stuff because the bandpass filters protect you. And even with in-band for field day if you set it up properly. But this gives you, for those weird cases where you need that, over 140 dB of blocking dynamic range. You know, as good or better than the K3S. So it's doing very well. And the IMD dynamic range is in the same range of the K3 and K3S.
And when can we order it?
That one I should have up on the website probably in the next 45 days or so. This one has priority first, and then that's following that. We're right now ordering key long lead time items for it for production. That's the determining factor on it. So I'd say August timeframe, maybe if I can get everything in-house in time, we'll start shipping on that. And I'll be taking orders as soon as I have commitments on the final parts that we've ordered. Crystal filters have for a high dynamic range, for IMD dynamic range, they're the weak link left in any system. And so we have the special crystals made that are actually polished better. Think about what they do. They're just vibrating, right? So like a speaker, if you overdrive them, they go into distortion. That's where your IMD dynamic range issue is. So you want to make sure those are clean so it doesn't get worse, right? So we can't just take off the shelf ones and do that. So
My understanding is there'll be perhaps a menu item so you can turn the HD module
yeah,
on and
HD
off.
you'll be able to even do it the macro, so you can assign a key and turn it on and off like a noise blanker if you need to. So if your buddy down the block on 160 or 80 is running 1.5 kilowatts and on the same band, 30 kilohertz from you, yes, you want to hit that on button, and otherwise you don't have to use it. But
So speaking of noise, there's, of course, the spectral subtraction noise reduction that some of the competition has. Folks say that even without that, the noise reduction in other radios can be better than what the K4 has now. So if not SSNR, would you be having any plans to just improve the NR algorithms that are there now?
We're looking at that. That's going to happen after I get the softwares freed up from the current stuff we're releasing. So probably you'll start work on it in the fall timeframe. I can't give you a hard date on it, obviously, but both of those are important for us, so they're not going to go away.
So probably not before Christmas.
No, I don't think so.
This time, okay.
I might surprise you, but I'm not going to. I'd rather surprise you than commit to it.
We'd love to be surprised early.
Yeah.
That never
No,
happens.
I've got the hooks in there, but these are both a lot of work. So.
All right. And adaptive pre-distortion, which is, clean signal initiative. They want us to be super clean on transmit.
Yeah. That's actually, I was referring to both of those when I said that. So about the same time frame starting both of those.
Not by Christmas.
No, I don't think so, but it's in the works I'm planning here for that. We actually built hardware in on the K4 to support that, so it has the feedback path for adaptive stuff. But we committed to get everything else finished first before we did that, because otherwise I'll delay this stuff. I don't want to do that.
But you're strongly committed to delivering that?
Yes.
Okay. Any questions from the audience?
Okay, the fun part.
I guess we don't have a rover mic, so I'll try to repeat it. Lots of questions from the audience. Let me start with N7TS. When you
gosh, yeah. Okay, so the question go ahead. I can repeat them, Bob. I can hear them fine if you want. So the question was K40, is it compatible with the HD? Yes, because that's on your remote radio. This doesn't care at all. This is like you just took your control panel on your K4 and just moved it halfway across the country or whatever. But this gives you it's the same front panel as the K4. So as you can see, I'm on batteries right now. You can see what it looks like here. I was going to connect to my phone, but the 4G is not strong enough in here to do that. In the booth, actually at dinner last night in the all-you-can-eat sushi place, we had great Wi-Fi there, so I was able to get on the air from there and listen and stuff.
Should have contacted someone in Japan.
Yeah.
And 2Z,
But
go
anyway,
ahead.
it doesn't, everything you can do on your K4, whatever's in it, it'll let you do it.
Let me give it N2Z, Zedek.
The question is, to answer your second question, will the original people that ordered the K4 HD and say maybe you took a K4 or you're still waiting for the HD, but if most of them's converted to a K4D and then we put you on the KHDR4, that's the upgrade list, you're priority for that, absolutely. So everybody, as long as you confirm your order and we come back and say, do you still want it, you'll have priority for that.
And the cost?
It's going to be roughly like going the same upgrade like you did going from a non-D to a D, about $1,000. Everything, including the price of this is the K4 Zero, we're quoting about $21.95, the $21.95. That is variable because everything's sourced internationally for raw parts on these things, even though we assemble everything in California. We buy resistors, capacitors, flat panel displays, everything. There's a good chunk of that comes from offshore, and that's unpredictable right now. So we've got actually initial production of K4 Zero. We do have the LCDs embargoed that we bought. I mean, we said got them at a decent price, so they're not going to have a surprise. But after I sell the first couple hundred, or watch out, I don't know what's going to happen. Yes, sir.
Maintaining an annoying pulse on pin 8, remote power.
I actually don't have an answer to that. That was something Wayne did.
The question
before
was.
Oh, I'm sorry. I'll answer. Let me get confusing with two of us here. I can play it back. Yeah, okay. The question was, and this is a K3 also, both the K3 and the K4, to turn them on, you have to pulse a pin remotely on the back on the ACC connector. That's because the way the front panel was designed, when Wayne did that, and we actually had it laid out by someone else, but the basic concept on it, on the K3, and I transferred to the K4 before I caught it, is that panel shuts down the single board computer that connects to the Ethernet. So there's no way I can get a power on Ethernet to do that. I apologize for that, though you can pulse it or just pull it down and let back up. Bob solves that for us with his little K-on board, and I use an Amazon light switch deal that basically powers my little switching power supply, and when you power that up, the radio comes up. So that's the way we get around it. I apologize for that, but that's how it came about. It was not a conscious design decision on our organization.
Not something you can easily fix in the future.
Not in the future, just because the front panel it's universal for that. So
Front panel turns on
I
the
got too many of
computer.
them out there already, too. Okay, the expected battery life in the K4 Zero right now, I think, is around 3.5 to 4 hours. In that range, it's a 6-cell, 16850? I forget the cells, the standard cells. And when you have it plugged in, if you have a 45-watt USB-C, because we have USB-C power for this, and also if you want an APP, you could do that in the home station. It will charge it at the same time. There's full power delivery negotiation on it, but you have to have a 45-watt charger to run it and the charger at the same time, a 30-watt one just to run it by itself if you aren't using a battery. So if you have a battery in it, you want to have the 45-watt because it'll try to charge it.
And 1RM.
Okay, and where are you? Go ahead.
Remembers me, RM. Got it.
Yes. Internal and external, yeah. Yeah, we left the external as a teaser for you. That's why you always saw that jack on the back. So you knew it was in there somewhere. I hope, oh, well, the RF sampler would be just for, a non-Elecraft amplifier. The Elecraft, if 500 doesn't have if you're going to do it with the 500, you need an external sampler for feedback. This is for pre-distortion. If you're going to use the 1500, we built it in. 100-watt amplifier, yes.
Okay, it's about 15 minutes up here. One last question, blue shirt in the back.
Oh, the input versus, I'll certainly, I think it's pretty standard. I forget how many dB down. Is it 60 dB or whatever the most common couplers are, but 60 or I don't have it in front of me, but certainly input distortion, pre-distortion input, the sampler input you're talking about, we will publish that. Sure.
Quick question? All right.
Gosh, those work awfully well right now. I don't think we've not planned any changes to the DSP filters.
The skirts aren't as sharp.
We can if you're down below.
Yeah, even at 200, it's still not as sharp, yeah.
Yeah, I don't know if you really need that. You're going to get more ringing if you do that. That's the trade-off. And that's true on a lot of them. And also you get more delay through the DSP system when you do that. So it's a standard trade-off on those two. We haven't planned to do that because I haven't had a lot of complaints about it. I mean, you can look at it, but I don't ever have a lot of blow-by. It's a problem for us.
And only Rob Sherbert is talking about it.
Well, that's a lab test. That's fine. I know Rob real well. He does great work, so.
Thank you very much for everything you do for Elecraft.
Yeah. If you have more questions, you know where to find me over in the booth. I'd be glad to talk to you and pull stuff apart and show you. I have an HD board to show you too. Come by and take a look at that. So it's real. Thanks a lot.
Thank you. By the way, Eric and I are not related, even though it looks like we might be. Yeah. Three bald heads. There was a lot of glare on that photo. All right. So folks who've seen this on the web, I apologize. There's some repetition from last time, a few enhancements, tried to make the slides a little easy to read. But there is some really valuable stuff at the end. So if you can stay awake, and I'll give you a hint, it has to do with keeping Windows updates from messing everything up. Yeah, it's called Use a Mac. No, it's Windows updates. So these links are all live in the PDF copy that you will see uploaded to my website after the convention. Go to my QRZ.com page as my website. And on there, if you scroll down to presentations, this should be at the top of the list. K4 Tips and Tricks 2025. I'll have the link to my QRZ.com page at the end here. But all of these guides are very, very useful. And even the release notes are where they put stuff that doesn't make it into the manual or programmer's reference yet. And these are all on the Elecraft websites. If you're brand new to a K4, definitely read the introduction. Or if you just plugged in a K4 to a new computer, go back and read that introduction. It tells you how to get the COM ports back and everything else. We have an active K4 groups.io page. Anybody here who is not yet subscribed to it? Okay, just a few folks. I highly recommend subscribing to it. You can't, unfortunately, it's marked as a private group. That was a mistake that somebody set up. So you can't be searched with Google or anything. You have to sign in and use the search box in there. But in there, there's a files area that has the following files listed, including a new Mac OS setup guide by AI6W and the FT8 setup guide by WT8P. And every Sunday at 20 Zulu, we do a interactive problem-solving, ask any question about Elecraft or the K4 hosted on Zoom. Was started by K8 and you. And he, unfortunately, couldn't be here today. We want to get a picture, a group picture of everybody who's been on that Zoom chat after this talk over there on that wall. Please gather, and I'll get a group shot of everybody for Carl, who couldn't make it. In case you get messed up, you might forget about this. You want to hold down the norm button. It's a knob. It actually acts like a button. Hold it down for a long time. And in the yellow text there, that means hold function. That's kind of universal throughout, except for those buttons on the right. But you do want to always, your filters get messed up. You change bands, you change VFOs. All the filters are different. They save all that stuff per band and per VFO, unfortunately. You just want to normalize things for the current mode. Just hold down that button. There's no way to, right now, to program what norm does. It just does a factory default just for that filter, just for that VFO, just for that band. So you have to repeat it. If you're plugging in headphones to mute the speaker and unplugging headphones to unmute the speaker, you're doing it wrong. You don't need to do that on a K4. By factory default is they program the PF3 button on the front panel to toggle this menu setting, speakers plus phones, between yes and no. So you can leave your headphones plugged in all the time. If you want to listen to speakers, hold down PF3. You don't want to listen to speakers, hold down PF3 again. No reason to do any wear and tear on your headphone jack or your headphone cord. If you do want to use separation, stereo separation or diversity or two-band listening or something like that, plug something into the external speakers jack Because if you don't, the internal speaker is mono and you'll get a mix when the internal speaker is on. You turn the speaker off, then you'll get stereo in your headphones. But if you set speakers external to 2 and plug in any stereo plug, doesn't have to have a speaker, into the external speaker jack, then stereo will be maintained whether you have the speakers on or off. And if you just have a mono speaker, just connect one side of the stereo plug, the left side, and which would be the tip connector. So I'm going to cut this one short a little bit. There is built-in help text in the K4 itself. It does have a search feature. You tap the question mark to bring it up, and then you tap the magnifying glass to search. You'll get a pop-up screen where you can enter a string. In this case, I entered IIR, and it starts highlighting those fields, and those arrows can be used to navigate. But I found it much easier to use the exact same manual on the web. There's a link to it on the K4 manuals page in HTML format. And then you get Control F in any browser and find things that way. You get a little more powerful search. But the built-in manual is there if that's all you have. And there's even this kind of mysterious button that people forget about. What does that do? Well, it makes the help text full screen. It looks like that. And if you want to scroll it, that little symbol on the right, that means the little curly Q and the A, that means turn the VFOA knob. That's what that icon is trying to represent, is use that knob to scroll through the page. And if you hit that button on the left there again, let's see if I got an arrow, this one here, that one will take you out of full screen mode. And very useful to know, like I just touched something on the radio, something changed, I forgot what I touched. Hit the question mark and then tap the last control button and it should jump into help text to tell you what button or what thing you just changed, menu item, whatever. And then you can figure out, oh yeah, I didn't mean to touch that. The factory default, the way the display comes, I think doesn't look very good. You've got way too much noise in the waterfall. You can't see the weak signals. They're covered up by the band noise. So I have some number of recommendations for optimizing the display. And they're kind of all listed here, and I'll show you that, some screenshots of that. But you might notice that on this screen I have S units on the left. The factory default is decibels or dBm. So I don't know too many people who say, you know, you're negative 63 dBm here. No, we say you're 10/9. Sounds much better, doesn't it? So you want to see that peak on the display, and therefore I think most folks will want to change that to S units. That's that menu setting I listed there. It's a little obscure. It's called spectrum amplitude units. The default is dBm, and I think most of us probably change it to S units, but maybe I'm wrong. The scale is the vertical scale, how many decibels of space you have at the top. And the factory default is something like 35 dB, and there's a much larger range in signals. So loud signals are going off the top of the page, and weak signals are kind of buried, or too much noise. So I increased that to 80, and you can adjust it as conditions warrant. You tap the display button and then the ref level button, and it should be set to auto in most cases, but you can set it to manual for specialized measuring of things. And the menu setting for auto ref offset is -2, and I think that puts a little too much noise in the display, or maybe too little, I forget right now. But I think I've kind of settled on offset 4. These are kind of my personal recommendations. And as far as the scrolling goes, I'm not a big believer in leaving the cursor in the middle of the screen and shifting, smearing the whole band up and down as you tune. To me, that's like reading a newspaper by holding your head still and moving the newspaper up and down. I don't think we read that way. Of course, we don't read newspapers anymore, do we? Span, I've just settled on kind of about 40 kilohertz on CW. In a contest, I may go narrower because they're so crowded. And about 100 kilohertz span seems to work pretty well on phone. And the good news is you can store those in the quick memories, and then you don't have to keep messing with the span knob. And the RIT knob, when you're not using RIT, has a couple of useful functions you can assign to it. And I like to use it to shift the center of the center of the display, so I can just keep the band edge on the left. And that's the menu RIT knob alternate function. Once you get everything set up and everything looks just perfect, double tap that A to B button. What does that do? That's copy all. Just single tap just copies the frequency. If you double tap, it copies the mode, the scope settings, everything else. So then when you tap the A-B button to swap between two frequencies, the display, if B is still in the same part of the band, won't shift around and jump all over the place on you. So just reviewing that real quick, you tap the display button. There's the scale. If it's in yellow, what do? You hold it down to get to the scale. and then the scale number pops up, and then you've got that twist the A knob to adjust the scale, and here's where I've set it to 80 dB. You have to keep tapping this button here in the display menu, single tap, to cycle through the various scrolling modes. There's fixed 1, which does a whole screen. Fixed 2, I've settled on, does a half screen scrolling. And I think I like the cursor moving and only the band moving when I get to the edge. And then it gives me some context because if I want to go back the other way, it doesn't jump. So I think fixed 2 is a good one to use. And you, of course, can adjust the span by a similar way. You rotate the knob, and that gives you the 40 kilohertz or 100 kilohertz or what you want. And here's the menu item. I mentioned the RAT knob alternate function. I think the default is none. The other option besides pan center and pan span, which would be like a zoom in function, is VFO coarse if you want to use the RAT as a coarse tuning knob. And of course you tap menu, then you unlock to scroll down, then you unlock the little icon there and tap there, and you can change the function by rotating the knob. And the little curly Q arrow in the lower right corner there, that's your dismiss, like I'm done. And you can tap that, and then when you're all done, you use the RAT knob. Kind of funny, on the panel it says OFS for offset, but everywhere else it's called the RAT knob. All right, quick memories are really helpful. The per band quick memories, they're not on other radios. If you haven't used them yet, it's really worth learning how to do them. And every quick memory is per band, and you tap the store button first, and then the M1 button to save it. When it saves your scope settings, your filter, the mode, everything, and frequency for both VFOs. And then if you hit recall in the M1, then it resets all that stuff. So you get all the stuff that you had set up perfectly can come right back, but it is per band and per 4 memories. So I just use the 4 memories for the 4 different modes that we operate. I just listed them in order of they were invented. The CW first, then sideband. Maybe RIDI came second, but anyway, not too many people on RIDI these days outside of contests. So learn to use the per band quick memories. Don't confuse them with the band stack. That's something completely different and not nearly as useful as the quick memories. All right, the factory default is all antennas are available, and that's not a good thing because most of us don't plug 3 antennas into the K4. You tap the antenna button, and you're going to not do what you want. So you tap the TX button down there, and then antenna configuration, and that's where you can uncheck all, and if you just have one antenna connector or maybe just an amplifier, just check one box, the ANT1 box, and don't check ANT2 and ANT3. Then when you tap the antenna button, it'll either do nothing if you only have one TX antenna, or it'll cycle through whatever check boxes you have checked. What if I want to label my antennas? You notice I had main on one. I have dummy load on 2. And so I wanted to name antenna 2. And the way you do that is you go ahead and tap the main RX button. I'm sorry. You tap the receive antenna button on the K4. And if it switches antennas, well, then you have to do another thing. But the default from the factory is when you tap RX antenna, this set of buttons comes up that says which antenna do you want to pick. And that's the only place you can rename your antennas for the display at the top. So you have to hold down that button in yellow, and then you'll get a pop-up keyboard where you can type in the name, and then you have to tap that enter key to save it. Some people hit the X at the top, that doesn't save it, that cancels. So hit the enter key to save it. By the way, anytime you see this keyboard on your display and you don't want to touch the screen because it's real cumbersome to type, especially when you're doing macros, plug in a USB keyboard, any USB keyboard, and start typing. That's all you have to do, especially if you're doing a lot of labeling and naming and entering macros. Plug a USB keyboard into the K4 temporarily and do it that way. Then after you got all your antennas named, go back into the main RX and antenna config buttons and select use subset. And you only want to select the antennas that you have available. And a lot of people make the mistake of checking antenna 1 and equal TX antenna when all they have is antenna 1. And it's kind of dumb the way the system works. Every time you press the receive antenna button, it just cycles through these checkboxes in sequence. So if you have equal TX antenna and antenna 1 both checked, then you tap RX antenna and nothing happens. Why? Because it jumped from that one to that one. It just went through a cycle and there were duplicates. So in most cases, if you just have antenna 1 and maybe a couple of receive antenna ports, just check those 3 boxes. But don't forget, you also have to do the same thing on the subreceiver. They're completely independent settings. You tap sub RX and then antenna config for the sub RX. When you see that B set symbol at the top, that means you're working on the subreceiver setting the B. And I would make them identical. And once you do that, all you have to do is tap the RX antenna button. And as long as use subset is selected, it'll just cycle through all your receive antennas. And you can hold it down if you want to cycle just the subreceiver antenna. And if you say, whoops, I forgot to name my antennas, how do I get it back? You tap main RX and antenna config, and then select display all again. And then when you tap the receive antenna button, you'll get that prompt where you can enter the names of your antenna and rename them. People do this once, they change from Yagi to Quad or something, and they forgot, how do I rename my antennas? You have to go back to display all mode. This big RX antenna thing here is trying to tell you this is what the RX antenna switch will do. They call them switches. Physical buttons on the radio they call switches, and buttons on the screen they call buttons for terminology. And so the radio always displays what antenna each receiver is using. The main receiver on the left. You don't have to have dual pan mode like I have here. It's still, these are displayed whether you have dual pan mode or single pan mode. People think I have to turn on the second pan to see the subreceiver. You don't. The VFOs are in both. This is the antenna, the transmit antenna in orange in the middle, and the subreceiver antenna on the right. Now you may notice that I've got the subreceiver on a higher band than VFOA, which is normally not going to work. But if your subreceiver is using a different antenna, then you can put the subreceiver on any band you like. But if they're listening to the same antenna, the transmit antenna, well, the transmit antenna has bandpass filters or low pass filters, and you'll get a big warning if you try to turn on the subreceiver when it's set like this. It says subreceiver frequency too high, and bandpass filter or low pass filter would not allow you to hear anything. So I usually recommend setting the menu VFO-B different band to no, and then both VFOs are always on the same band. Folks who do like to monitor multiple bands, you have to always put the lower band on if you just have one antenna. But there's a little mystery. Here's a bonus item you guys haven't seen talked about before. What is that? Well, that's the clock and a status area. It's called the status area, and people don't realize that the status area is a button. You can actually tap the clock, and when you do that, you'll get a whole new set of buttons that say, well, what do you want to see in the status area? And I think a default is TX param, and the voltage and stuff. But this last button on the right here, time and TX, is the one that I was using before. So it just displays the time, not the date. And it shows you when you transmit your watts and your SWR. And there's a lot of other options. This signal level thing is an audio meter. You can actually zero it. That's kind of what you see displayed here is the audio level after I zeroed it. And then if you tune in a signal, it'll show you how much audio output you're getting. But it's not a signal level in decibels, it's the audio output level. So you generally want to turn AGC off if you're trying to get precise numbers of dB measured. All param gives you a big long screen. You can scroll with the VFO knob to show you all your voltages and temperatures. And this edit ID button down here, that's where you can put in your call sign. If you want your call sign displayed for your screenshots or whatever, you can edit your call sign in with this edit ID button and then select ID and time in the status area. And you'll see time at the bottom and your call sign at the top. So remember, the clock button is a button, and it's the status display. So this dialog for the display kind of confuses people a little bit. There are buttons on the top left there. These here tell you what are you changing. So if I just want to change, for example, the waterfall height on the external monitor, I want to see more waterfall there, but I want like 50-50 waterfall on the LCD. Well, you can tap LCD, hold down this waterfall button here, and then turn the knob to adjust that to 50%. And then you tap EXT, and you can separately set the waterfall height on the external monitor. If you want to do something that applies to both A and B, you can hit this ampersand. Something that applies to both the internal and external displays, you can tap this ampersand. Not all of these things apply independently to both receivers. I don't remember the entire list. NB is the waterfall noise blanker. It eliminates snow from the waterfall. and there's a couple of modes of that. I personally don't use the noise blanker on the waterfall. Oops, I want to see everything. I want to see the noise. Here's a tip for copying weak signals on CW when you want to really pull them out, and that is to set the APF bandwidth. You'd have main RX and then the APF bandwidth. Set it to about 50 hertz. I think the factory default is 30. They used to have a bug that would reset it to 30 every time you restarted the K4. Now or installed a firmware update. Now it remembers 50 hertz, but it's still, unfortunately, per band per VFO. So you have to kind of set your APF on all of them. You can do it with one big long macro string. But that really pulls out the weak signals. But one other tip there, your pitch control, the center of your CW passband should be a multiple of 50 hertz. 450 hertz, 500 hertz, 550 hertz. The factory default is 600 hertz. I think that's kind of unpleasant to listen to, so I changed the pitch control down to 450 when I want to use the APF peaking filter. There's other bandwidths, 30 and 150. 50 seems to be very helpful. And how do you get the APF on? Well, unfortunately, it's not real convenient. You have to hold down the filter button to turn the APF on and off. But there's these macro strings you can just program into a K-pod switch or use in your logging software to just turn on the audio peaking filter. AP/ means toggle it from current state to the other state. AP $ means do it on the subreceiver, so I'm doing it for both at the same time. All right, Windows, and this is where some important things happen. A lot of people make the mistake of plugging their K4 into a different USB port, and all of a sudden everything changed. The sound card's different, the COM port's different, everything changed. Why does that happen? Well, Windows is pretty strict about where you plug in USB devices. It goes by internal hub number, and so if you plugged it into another port on the same hub, then it's probably not going to renumber everything. But internally, the PC may have USB 2.0 hubs, a separate USB 3.0 hub, and as you move that cable around, it's going to end up with a different COM port number, and it's all going to reset all the things to the factory default. And the factory default is what you see here, the Windows default, which is the serial enumerator is checked in the advanced settings in Device Manager for that COM port. What does that mean? It means look for a mouse that's connected to the serial port. Well, how many people connect mouse to a serial port? So you want to uncheck that box every time you plug in any FTDI device, including a KPA1500, though it's not as critical there. And you also don't want it to look for a dial-up modem every time you plug in a new device. So you'll want to check the box, disable dial-up modem control at startup. What does this fix? If you've turned on the keying feature of the K4, you ever power up a K4 or power up your PC, reboot your PC, and you hear dot, 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 dot. What is that? Yeah, there it is. That's because these options were set back to the default. A Windows update might change them back to the default, or moving the USB cable, adding a hub, moving the USB cables to a different hub. So a recommendation is, once you get the K4 all working, the COM port set, the sound card set, always plug that USB cable into the same port on your PC. And if you're trying to debug things and you want to unplug a USB cable and see what COM ports go away, do it at the back of the radio, because it's too hard to figure out which COM port on my PC is the radio. Go to the back of the radio and pull it out there, and then you'll see. Once you've got those options set, you have this convenient feature of being able to send CW or PTT over the USB cable. You don't need a WIN key. You can still use the paddles, of course, but you can have computer-generated CW working on these pins, and this applies to N3FJP software, which didn't work so well with the K3 because it needs its own COM port for CW. It works with N1MM, DXlog.net, FLDigi. All these programs can send decent CW using those virtual pins on the USB cable, and I like that feature very much. In N1MM contest software, any here use the N1MM contest software sometimes? Okay. People may not realize that it can talk to the K4 by TCP/IP, by Ethernet cable. It can use the COM ports, but you may want to use the COM ports for some other program at the same time. So in N1MM, you can select the port type, not just COM, but you can select TCP. And when you put in TCP, you don't have to put in the hard-coded IP address assigned to your K4. You can just put in the serial number. And in most networks, it will find the K4 that way by its host name, it's called, K4-SN, and your 5-digit K4 serial number. .local, and then :9200. 9200 is the port number that the software can talk to locally, not remotely. It's not password protected or anything. And then you can do your CW keying on one of the virtual COM ports. Can't do that over the Ethernet except by sending KY commands. But don't forget to check this CW other box first, then hit the set button, and then you can say, I want to do CW on DTR and PTT on RTS. Sideband operating tips. The factory default is flat equalization, and that sounds pretty bad. So most microphones are wide range to bassy for punching through a pileup. You tap the TX button and then the TX EQ button, and then you get a graphic equalizer. And this is what I recommend to start with for most wide microphones, like a typical PC mic, an Electret mic, maybe the MH4. And you want to hear what it sounds like, you can just tap this flat button on the right, and it toggles between all your settings. But don't turn off the radio, then it'll go back to flat. But as long as you don't turn off the radio, you can tap that flat button on the right there as much as you want. It'll toggle between flat mode and equalize mode, and you can listen to how it sounds in the monitor. I recommend using voice memories to hear how you sound, because if you talk and listen at the same time, the sound comes through your head and it doesn't quite sound the same. So record a voice memory, which is always recorded unprocessed, unequalized in the current firmware. And then when you play it back, you can play with the equalization and the processing and listen to the monitor. And I've listened on the air and also to the monitor at the same time. They sound almost virtually identical, unless you're getting a bunch of RF arcing in your antenna or something. So that's a setting. One little error here. This graphic was a little old. I've decided to bump up this last band pass here, this 3200 hertz, which is technically above the pass band, but I bumped that up to 5. And the rest are set. You can just send this one command, and I'll show you a neat tool for sending commands like this to the K4, and it'll reset everything to that as a starting point. So I'd try that. So how do you record a voice memory? You tap the record button, not the recall button. People get mixed up with that, but this is the record button right here. Oop. And then you tap the key you want to record the voice memory in, and as soon as tap that button, start talking. Otherwise, there'll be a gap at the beginning of your voice memory. And then as soon as you stop talking, tap that M1 button again, and that'll save it. You'll get prompts on the screen, but that's too slow to tap the screen. Just use the buttons to record things. And once they're recorded, you can just tap the button once to play it back. You can turn on TX test mode by holding down the XBit button. That is kind of unique to the K4 and K3. It is a way of testing everything on the radio, including the PTT output, without transmitting any RF. And that is a useful feature, especially for listening to your voice messages without transmitting anything on the air. And then there's these handy commands. You get 2 banks of 4 messages or 8 total messages. And you change the bank with holding down this record button. It says bank. That means swap between memory bank 1 and memory bank 2, and there's a display that shows that. Spectrum display. People say, I want to put the call signs in my screen on the K4. Well, they're not going to do that for you on the K4. That's too involved. But when programs like N1MM and some others, you can select windows. As long as you're connected to the K4 by Ethernet in N1MM, you can select window and then spectrum display, and it will put on your PC screen in N1MM this pan adapter, and you get to choose which ones you want. And it'll, if you're connected to the cluster in your software, it'll start labeling all the call signs where they are. And how do I set this up? Well, all you have to do is connect that Ethernet connection, like I showed before, with the IP address or the host name. This little button here on the right, if you tap that, you get the settings screen. Spectrum source is not an external SDR. You actually have to say external wideband flex. I'm not sure what WB stands for. But flex, you select that one, and you can pick radio 1 pan A or radio 2 pan A or whatever you want to monitor. And there's some other options over here for which frequency you want displayed. And it will follow your frequency as you change. But it somewhat follows the span of the K4. It's kind of fixed that way. Yes, sir. Yes, the question was, can you simultaneously connect by TCP and serial port in one program? And yes, the answer is they all work independently. Not only that, you can have multiple programs connecting, like WSJT can connect by TCP port as well. I'm about to show you that. And so you can have everybody sharing the same TCP port, and there's no conflicts. Everybody gets what they need. So it's actually using a different port number. I think it's 9201 or 9202 to stream this data. So it's a separate, TCP IP port, but it figures that out. It just adds 1 to 9200 or something and gets to the right port and gets to the data that way. But yeah, there's no problem using all 3 serial ports of the K4 and as many TCP IP connections as you like at the same time. Unlike the K3, which was very restricted that way. So most of the guys just want to operate FT8 these days. That's where most of the QSOs are being made. And it too, you can use COM port for rig control, but you can also just, where it says serial port, you can just type in the host name and IP address, or IP address and port number in WSJT or JTDX, and all of a sudden you're talking to the radio by TCP IP. And in that case, you have to generally use PTT via CAT. My preference is PTT via RTS, but that's just because I think it's a little more reliable. If the command gets lost, it won't keep the radio keyed. But you always want to use the test CAT and test PTT buttons in these to make sure everything is working. And I recommend if you are using split equal fake it these days, sometimes the commands to put the radio in split are kind of slow and they don't always work and they don't always put the VFO in data mode for you. So if you use split equal fake it, then it just keeps VFO A as your transmit VFO and it offsets it during TX cycles to compensate and keep your audio pitch in the middle of the TX passband where there'll be the minimum distortion. You can set the audio I/O using the devices in WSJT to the USB audio codecs. I like to number them TX audio and RX audio using the sound control panel so I know which is which, but generally they only let you pick one. Leave the power slider in both programs set to the maximum and adjust the level using the menu. That should produce minimum distortion. How do you adjust the transmit level? You tap TX and line in. Make sure that sound card is highlighted in white. That means it's selected. People say there's no audio. Well, you probably selected and line in jack, which is separate and nothing plugged in there. I've a lot of customers that I helped just setting the level of 36 and all the sliders to max. When they transmit the tune button in WSJT, they'll say ALC, get right to hash mark 5, and we're all set. Folks with Dell PCs, some have no problems, but others have had terrible problems getting WSJT to work. The only way I fixed it was to run the services, go to the services menu of Windows, and disable the Waves audio services. You right-click stop, and then right-click properties, disable, and then reboot the PC, and then all of a sudden all the sound stuff works. What's the Waves audio service? It's some kind of enhanced noise canceling thing for Zoom calls or something. You really don't want it active for WSJT. And that's the other important thing is you really don't want Windows to use your K4 sound card. You want only WSJT or JTDX or your logging software to use it. And you don't want Windows sounds and beeps and dings to use the K4 sound card. And it'll happen by default. So you never want to leave the USB audio codec as the Windows default sound card. How do I know what the Windows default sound card is? It's got these little green marks. When you run the sound control panel, the easiest way to get to it is just to run this mmsys.cpl that I showed here. And you're going to see as soon as you plug in a brand new K4, and this is in the new owner setup checklist, but people forget about it because they move stuff around and all of a sudden nothing works anymore. Windows puts these little green marks. The little telephone icon here means that's the default communications device for Windows. And over here on this communications tab, you'll see it mutes that thing. That's the last thing you want. Also, you don't want the speaker's device of the K4 USB audio codec to be your default either. You want to pick, these are disabled in this picture I got a screenshot of, but you want to enable the speakers in your PC to be used by Windows. So you click on that and then hit the set default button. That moves all the green marks to your PC's internal speaker, and then Windows will hopefully leave your K4 USB audio codec alone. But a lot of people say it was working last night, Windows did an update, and now it went back and used the K4. So always check the sound control panel if you're having trouble with WSJT. And here's the probably most valuable slide of the day. So if you're asleep, please wake up now. This is really helpful. I just learned about this recently, and it is a way to prevent Windows updates from messing with your sound cards and COM ports. First, never run a device driver updater program that somebody tries to sell you. They will install the wrong versions of the FTDI device drivers. You don't want to do that. If it happens to you, you can delete those device drivers and go back to the right ones. But if you run, and I haven't figured out an easy way to get to this dialog except by typing in the Windows taskbar search box, Advanced System Settings. And it ends up with this Advanced tab being highlighted. But then you go over one and click on this Hardware tab. And then there's a button down here that says Device Installation Settings. Choose whether Windows downloads manufacturers, apps, and custom icons available for your devices. That means, do you want Windows Update to mess with your sound cards? They ask you the same question again when you click that button. The default is yes, recommended. My recommendation, once you get everything working, is click no. And it says your device might not work as expected. If it doesn't, then I can go back and put yes and do a Windows update. But chances are you don't want any Windows updates messing with your devices. Click that button no, click Save Changes. Hopefully a Windows update won't mess things up. It's still possible, however, that if you leave WSJT up running all night to just monitor what was heard on the band while you were sleeping, and then a Windows update happens overnight and they restart your computer, all bets are off. So I wouldn't recommend doing things that way. Here's a really easy use program. I used to tell people to use Telnet or PuTTY or something like that to send commands to the radio, especially if you want to program some macros. This program by NF7Z is kind of underrated. There's also NK7Z, who's got a similar program. It's more fancy and has memory buttons and stuff for programming macros. But if you just want to test a few commands, and you shouldn't be afraid of the commands, they're very useful to program into kbaud switches and other functions on the K4. You can just type the serial number in this field. I've got an IP address there, but it doesn't need that. You can just type in 3-digit serial number of your K4 or 4 digits. You don't need the leading zeros. It just figures out what you meant. So if you just type in the serial number of your K4 and hit connect, it will connect to that. And it'll remember that connection. The next time you start the program, it'll auto-connect and you don't have to do anything. And down here, you can just type in a string of commands, and not just one, but any string of them, and click Enter Macro, and then you'll get a feedback at the bottom. You get a feedback at the bottom that in green, that's what the radio responded with. So if you're getting, and not only that, it says here in the fine print, up and down keys bring back your prior commands. So if you make a typo, say, oh, that didn't work, just hit up arrow, and then you can edit the command string and test it all out. You can add the delay commands that are needed sometimes. Great little tool, and the link to his page, you can just Google NF7Z macro tester, or when this PDF is uploaded, this will be a hyperlink. You can just click on to go right to the right page. MacroMaster's fancier, lets you save buttons, has some pre-programmed things. Great tool, that macro tester. So here's an example of programming a macro. This button, people don't realize, the remote antenna button holding down the antenna switch is like a fifth function key. You have PF1 through 4. They're already programmed by the factory to some not very useful settings. But once you run out of those, if you don't have a K-pod, well, you've got this fifth button here, the remote antenna button. And when the auto ref level is on, you may find sometimes a static crash comes through or a big loud signal, and all of a sudden the waterfall looks way too noisy or way too dark. Even though you have auto ref enabled, it's going to take a while before it averages out and then refreshes the screen. Or sometimes you just turn on the subreceiver and its reference level is all messed up and not correct. Kind of a bug in the system, but you can easily overcome it. Program this button or any button you like to do the following commands. So how do we program our first macro? Again, you have these function keys F1 through F8 on the screen that you can program. One tap is the white, the yellow is hold. I've got a few programmed and labeled there, and I haven't programmed 6, 7, and 8 in this picture. But you tap the function, and then you tap hold. You hold macros. It's in yellow. If you just tap it, you get a screen capture. But if you hold it down, it brings up the macro dialog. And then you scroll down to which button you want to program. In this case, the remote antenna switch is listed after F1 through F8, and the PF keys and the K-pod switches come next in the list. And here's where people make the biggest mistake. you got to enter the command in the right-hand column, and the middle column here is labels on the buttons if they're on the screen, or it's a self-documentation of what this command does. So my recommendation is put in the label first, then you're sure you got the command in the right place, because there's no vertical bars telling you where to tap. But you got to tap there just to set the label. Again, the keyboard pops up. I ran recommendation, use a USB keyboard to type this stuff. It's too hard to do it on the screen. Then you tap enter to save it, and then you go ahead and tap the next column, and this is where you put in the magic command. And in this case, the magic command, AR1, means automatic refresh. Refresh the auto ref now. Do it now. And clean up my waterfall display. Tap enter, and it saves it. It's kind of a long list of how I've programmed some of my macros. You see that auto ref offset button programmed at the top. I use the K-pod switches. They're very handy for stuff that takes too long on the K4. For example, you need to double tap to copy all, or you want to take an error log on a USB stick. Something's going wrong. You want LCraft to see the log file. This log command right here, very useful to have. I put it on the #1 K-pod switch with a long hold, and if a USB stick is connected, it captures an error log, and then you can send it off to LCraft support. I've found it very handy to make screenshots. Please, folks, when you're posting to the group for asking for help, always try to provide a screenshot. You don't need the whole external monitor screenshot unless it's something related to that. But it should be just the LCD, and that's what the SS0 command does, is just screenshot the LCD and ignore the external monitor. And then SS1 is a screenshot for the external. I like having in the lower left corner that quick button, function key for a tap, which toggles that audio peaking filter on and off that I mentioned before. If I hold it down, it turns the subreceiver on and off. And you may have noticed that when you tap the AB button on the radio, it's very slow to swap VFOs. Too slow for contesting SO2V style 2 VFOs. This command AB2 is a fast swap. It just swaps the VFO frequencies, not the filters, nothing else, just not the mode even. It just swaps the 2 VFO frequencies. So that way I have an instant AB swap, and that's the AB2 command, and that's what that's doing there. And then I've overloaded these, so if I hold them down to a log, they still do the same thing, turning off the RIT and turning on the RIT. So this is a new part of the talk, talking about connecting a KPA 500 or a KPA 1500. A lot of folks don't really understand how this works, so I want to educate folks. There's a menu setting that's off by default, and it's called per band power, and I've highlighted it here. I recommend setting that to yes, even if you're using a non-LCraft amplifier, because each amplifier, especially the solid state ones, they need a different drive power on every band. And if you do it this way, the K4 will remember what drive power to use on every band. And if you're connected to an LCraft amp by a proper aux cable, then it detects when that amp goes into operate or standby. So you want to put the amp in operate first, and it'll remember that setting for what power level you want to use in operate mode. And then you want to set the drive. I've seen people make the mistake of they set the drive to 20 watts, and then they put the amp in operate in that order. Well, now all of a sudden, the power says 5 watts. Why did that happen? Because it remembers 2 settings, one for when the amp is in operate and one for the amp is in standby. And the default factory is 5 watts, so in an operate mode. So don't forget to turn the amp to operate first. This is with the LCraft amps. Then adjust the power, then the K4. Remember it per band. So if you need different drive level on every band for your amp, then this is the option to use. Set that to yes. If you're using an LCraft amp, they have very fast switching, and it's almost a little too switching. And people have said the QSK is kind of unpleasant. There's this loud pop I hear when I go back to receive. They added this option here. Why is that happening? A lot of amps will hold their TX relay closed longer than the radio requests it, because there's some radios like the infamous IC, 706, that have this RF tail. They unkey the amplifier and they're still transmitting RF. That's hot switching. So some amplifiers, to overcome that, they hold their relay, or in the case of LCraft amps, their pin diodes, closed and in a transmit state, no audio, a little longer than requested. But the radio comes back to receive right away. Then the amp unkeys and you hear this big loud pop because there's a sudden spike in RF input to the receiver. That's what this unkey to receive setting does. The default is 0. You should leave it at 0 if you're not keying an amplifier. But for almost every amp that you want to key, I would increase that until you hear the loud pop go away when you unkey the radio. And the TX delay, 5 milliseconds is fine for Elecraft solid-state amps. If you have a PGXL, set it to the max, 25 milliseconds. They require 25 milliseconds of PTT lead time. Otherwise, you get RF early warnings out of the Flex Power Genius amplifier. So here's the summary of all the tips that you saw today, just to review. There's one bonus item coming next. But just to review, the norm switch to get your filters right, using the speakers plus phones button to mute your speakers instead of plugging and unplugging headphones. You searching the manual, STFM I like to say, and especially the one on the web. Get the scale and span of your scope set correctly and use those per band quick memories. Get your antenna configuration right so those buttons cycle one antenna at a time and there's no dupes. And you can use the display menu to make the scope look better. There's some peaking functions and others in the display I didn't go over. You can use the APF to hear those weak CW signals. And of course, you can set up the FTDI properties to prevent unwanted keying, and then you can do keying by DTR. Get that equalization good for maximum punch, and use the voice memories in the radio that sound better than using an external sound card, always. Use the N1MM Spectrum display, if you like. No green marks on the USB audio codecs. It's like most of my time is spent helping people with FT8. It used to work, now it doesn't. What do I do? Okay, check that sound control panel, check all the settings, make sure the power knob isn't at 0, make sure enhancements are not enabled, make sure you've got TX line in selected correctly, and block those Windows updates to your device drivers. And don't be afraid of K4 macros. They're really helpful for doing stuff like, I want a button that does this. You can do that. And if you're using a linear amplifier, enable the per band power and the delay settings. So here's one bonus tip for you. If you do have an Elecraft KPA 1500, a lot of folks don't realize that it has some nice features when connected to the K4. If you set the radio type to K4, and if you don't see K4 in the list, this is the KPA 1500 menu on the left here. If you don't see radio type K4 in the list, it means your KPA 1500 firmware is out of date. Update it to the production model 2.67 and you'll see radio type K4 and it'll track the K4 better. There's an option in the menu, I think it's on by default, which is ATU XCVR key. What does that mean? It means when I use the ATU button to start a tune cycle, it'll key the radio for me. So I don't have to hold down a straight key or go to RIDI mode and go to XMIT like you did with some, Yaesu rig or something that doesn't have a tune button. Don't have to do any of that when you have the Elecraft amp and an Elecraft K4 or K3. You just tap the tune button on the amp. I showed a picture here I kind of zoomed in on it, of where the tune button is, ATU tune it's called. And you tap that, you hold it down to enable the ATU, that's what lights up the in light. And then if you just tap that button, it's gonna, you don't have to change modes on the radio, it's just gonna key the radio, but how much power is it gonna give? Well, it's all set by this menu item in the Elecraft K4. Tune LP, low power tune. If you set it to 20 watts, this thing sends a command to the radio, give me the low power tune power output, and I'll run my tuning cycle. 20 to 25 watts is plenty for the 1500. Even if it's in operate mode, it temporarily goes to itself to standby, tells the radio to give me 20 watts of carrier, finds the match, goes back to operate, one tap. Repeat that on all the segments. The segments are listed in the 1500 manual. And now your 1500 is programmed. One thing I forgot to mention right there at the top, people don't realize, I can just go directly to any band I want by tapping the band buttons on the amplifier. That moves the radio to the same band. If people think, well, I have to change bands on the radio. I mean, I have to tap the band button and then I have to pick a band on this LCD. You can go direct to any band you want by using the band buttons on the amplifier. If you got the radio menu set right and you have the right aux cable. All right, here's a list of references. Don't forget to use the Elecraft K4 search box. The groups page has a search box. Reminder, for those who have participated in the Zoom call, we'd like to get a photo of everybody at the left side of the room. There's one more guy who is going to talk here today, K4SV, and then we'll get the photo. And now I can take quick questions from the audience. Oh my goodness, a whole bunch. Let's start way in the back of the blue shirt there. Number 5? Tip 5, okay. Yeah. No, there's the downside of the quick memory buttons is that they change the mode and frequency as well. And so what I would recommend, for whatever you're clicking on, whatever software you're using, is supposed to send commands to the radio to put the radio in SSB mode, which will switch the filters to the SSB filters. And then when you want to go back to the FT8 frequency, well, you can just click on WSJT to do it, or you can hit recall in M1 and go back to recall in M4, I guess, to go back to the FT8 frequency. But whatever logging program you're clicking on, whatever band map, if it's not changing the mode of the radio to the mode of the spot that you clicked on, then it's not set up right. And you have to teach it the band segments where phone is, where CW is. What program? So the pan adapter will jump, it'll say zoomed or whatever. The span will not change. The span is not per mode. The filters are per mode, but not the span. Okay, let's go this side of the room. Okay. So I don't recall seeing that too much on the reflector, but the question was having to do with, if he has the span set to 10 kilohertz, he clicks on VFO-B to go chase someone there, and then when he goes back to VFO-A, I guess you're hitting the A/B button? Okay. Okay. And he's seeing it jump to 100 kilohertz span. Remember, the spans are saved per band, and per VFO. Now, if you double tap AB, and you really did get the double tap, it should store a 10 kilohertz span in both VFOs, but only on that band. If you change bands, you're going to have a totally different span. It remembers the span per band and per VFO. So when you tap AB to go back to VFO-A, it should never go back to 100 kilohertz. If you can repeat that and make a repeatable scenario, that's a bug they can fix, but I haven't seen that myself. And I also recommend using the quick swap macro, the AB2 command, instead of tapping the button on the screen. It's much faster to swap and it doesn't mess with all the spans. Okay. Good question that had to do with the recording messages in the internal voice memories, the DVR. Does it turn off compression and equalization to record those? An older release did not. It was a bug. But if you're on R37 or R36, then that's fixed. You don't have to touch the compression or EQ settings. Every message you record is recorded raw, unprocessed in the DVR memories. When you play them back, that's when the processing is applied. And if you're doing to a remote, the processor settings on the remote are what is applied. So you do want to check your remote EQ. It may be different. I'll take the rich. I wouldn't use flat on the remote. I would peak it like I showed, and then when you play back a message, it's recorded flat on your client. It'll get sent in digital form to the remote. The remote will play that audio message with the equalization setting and compression settings of the remote server. Richard. 2. Nice.
Even when I have the speaker turned off, there's faint stuff coming. It sounds like the speaker in the elevator. It's like little leakage in there. I hear noises and voices coming from that speaker.
Okay, so he's done a nice thing. He's not only using the macro button to toggle the speakers on and off, he's also setting the monitor to 0, which is a good idea. When you turn on the external speaker, that way you don't get feedback on the mic or hear CW. Well, I guess on CW you'd want it on, but for phone or maybe FT8 or something, you don't want to hear it. But he says that he still, even though the speaker is muted, he still hears faint noises coming from the internal speaker. Do you have an external speaker plugged into the back? 2 studio monitors. Wow. Amplified? Okay. Maybe there's a little too much amplification. It doesn't surprise me that some noise inside the K4 would leak into those speakers even when the speakers were muted. So I don't have a fix for that other than, a relay to open that speaker connection or something. It'd probably make a giant pop if we put it back. I wouldn't do it that way. Maybe turn down the gain of those monitor speakers a little bit. I imagine they might not be too well shielded from RFI, and they're just getting, you could try a ferrite on the cable, a mixed 31 ferrite, to see if it's RF type noises that are coming through the speakers. If you really want to mute the internal speaker permanently, just open the top cover and disconnect the cable. A lot of folks have done that to prevent the loud pop that happens when you do a firmware update or turn on the radio. There's this giant pop that comes out of the internal speaker, even if an external speaker is plugged in. The only way to really cure that is to unplug that cable. Yes?
Get access to this presentation when I get back home.
When you get back home, unless you're home tomorrow, I will have a PDF file of this presentation on my QRZ.com page. And it'll be at the top part of the presentation section if you scroll down. My QRZ.com page, N6TV, it'll go right there. Okay, questions? Yes, sorry. Where's the screenshot file saved? Good question. You have to have a USB stick plugged into the front or back of the K4. It is saved in the root directory, and you can, there's a menu setting, you can set a prefix if you want. The default is something like SC and then a timestamp. It does timestamp them with UTC, all right? The internal time clock of the radio is UTC. So you'll get a little confused if you sort your pictures by date. Oh, wow, that was tomorrow. What's this picture doing here? It's because it's putting the timestamp in the file based on UTC. Okay, do we have any more questions? Yes. So the question is, how do you use a KPA 1500 to turn on a remote K4? With my gadget. So where do you plug it in? So there's a couple of gadgets. The K-On is a device if you're not using the accessory port or you've got a simple Y cable and an aux cable or my older Y box. Plug the K-On in, and as soon as the power supply of the rig turns on, the rig will boot itself up. That's what the K-On does. Back at the first slides, I had a link to how to remote power on-off methods. There's many ways to remotely power on a K4. One method is simply to have a WISE type switch or a switch you can control by Wi-Fi or by Apple app or Amazon Alexa or something. Turn on this light switch. What's that do? That turns on AC power to your DC power supply of the K4. The K-On's plugged into the K4. As soon as that DC power supply goes on, the rig turns on. Now, when you want to turn the rig off, don't just cut the power. Send a PS0 command if you're remote. If you're remote, you program it in a macro button on the remote client. RS1, which means send it to their server, semicolon, PS0, semicolon. That means power that rig off clean, wait about 8 seconds or so, then you can disconnect the power from the remote K4 using your web app to control the AC power strip. That's one way to turn on the K4 remotely. Unlike the K4, the KPA 1500 does support wake on LAN. So if you have a PC in the shack, that PC can run the KPA 1500 remote software, turn on the KPA 1500. And the KPA 1500 has a tune jack on the back that's a key. It's like a straight key that it can close to produce a carrier for non-Elecraft radios. We're probably not using it with Elecraft radios. You can pulse that jack to ground and it will turn on the K4 if that other end of that cable is connected to pin 8 of the accessory plug, which you can get to easily with my Y box, which breaks out the accessory plug to 4 RCA connectors. So you can actually, just turning on the KPA 1500, in most cases, there's a short 2 millisecond ground pulse on the tune jack, and all of a sudden the K4 turns on, assuming its power supply is on. So that's another way to turn on the K4 is just turn on the 1500. If you have a way to do that now with the KPA 1500 remote software, which is free, but not available on Mac, that is a way to do it. Now, the KPA 1500 utility is available for Mac, right? And it can also turn on the KPA 1500, and you can tell the KPA 1500 to toggle the tune to ground with a pulse. And that's described in more detail in that document. So that's 2 ways to power it on. And the other way is, build your own Raspberry Pi and a relay and pulse the pin to ground, all of those methods. But simplest way is to just get a $25 power outlet that you control from the internet and turn on the power supply to the K4 and it'll turn on. Okay, yes? AF record, yes. Yeah, the AF record and AF play functions built into the K4 don't work very well, frankly. It's a set of bugs that they haven't really prioritized to address yet. I'm not even sure they're fully aware of all the issues with it because they didn't fully test it. I did try to log most of those as a field tester that I could, but they're so focused on getting zero out and HD module and all that other stuff that they're just not looking at it. My recommendation if you want to do a lot of recording is get a free program like Audacity. It hooks right up to the K4 USB audio codec and get the level just right. And you can record for hours if you want to. And you can jump right to anything you want on your PC screen. And a Mac, I think, what's the equivalent of a Mac software for recording audio? Somebody help me out here. Nobody? Any Mac users here? Can't think of one. Well, I'm sure it has GarageBand or whatever, one of those programs that can record audio from a sound card. And that would be the one I would recommend. Logging programs like N1MM and WinTest and DXlog.net, contest loggers, they have a way of recording every QSO you make. And that's really handy too. Okay. Oh, green shirt. Oops. No, he's saying that the status window, he set it to maybe ID and day and time or something. He's saying the status window doesn't always stay that way, that if he restarts the K4, it goes away and it goes back to the default display. I have never seen that. How long does it take to power up your K4 when you just hit the power button? If it's more than 25 to 30 seconds, your clock battery may be bad, and that's generally might have something to do with it. But the status area, once you change it to what you want it to be, now there's some exceptions like, well, if you do all param, that's a screen that fills the whole screen, and of course that's going to go away. But if you were just trying to display, like I did there, time/TX, just the time and the TX info, it should not go back to the default display. Now, when you transmit, the display can change, and then when you untransmit it, it'll go back to something else, depending on what you picked. But I don't think I don't think anybody else has reported that. So be very careful to observe what you see. It always goes to the default of the date and time. It shouldn't do that. So maybe you're just not tapping the button and then terminating the menu to save it or something. What's the other weird thing going on? Yes. Right. Is it showing the CW code window like all blank or just a blank spot at the bottom of the screen or shows the decode window? Well, remember there's two decode windows. He's saying that he goes to sideband mode and the text decode window is still visible. I think you have to check very carefully in that window as to whether it's for VFO-A or VFO-B, because there's two text decode windows. And if you happen to tap sub-RX text decode, and then you move your VFO-A to sideband, well, the sub-RX is still on, and it's going to still have decode on. And it'll have a green color indicating this is the sub-RX text decode. So if you tap text decode again and it's just off, it should go away, but it should not, it should automatically go away when you go to sideband. But as soon as you go to a band with CW, it's going to turn it back on. It should turn it off and on automatically. These are weird symptoms I do not see. Again, I encourage you to join the Zoom call on every Sunday at 20 Zulu if you can, and have a camera, or better yet, a video capture card so we can see exactly what's on your screen, and then we can see what's wrong. A lot of people, they don't read the scheme real carefully and realize, oh, it's the BVFO text decode that I have on, and it's still in CW mode, and that's why I still have it. So that'd probably be the most likely explanation I can think of. Also, you have to check the lower right corner of the display to see if you're looking at VFO-B or Pan-B instead of Pan-A. Sometimes you're in CW mode, your VFO says I'm in sideband, but your display is set for Pan-B, which is still in CW mode, even if the subreceiver's off. So, you know, subreceiver off. Yeah, I think you'll still get the text decode window there. Does it still scroll when you're in span mode? Is it trying to decode, or is it just kind of frozen with the text that was there? Yeah, turning the radio off and back on. There's a much faster way to do a warm boot of a K4 than turning the radio off and on. You tap function, back up, like you're going to take a backup, and then exit. I'm not going to take a backup. That restarts the display software and everything else. It also disconnects any external programs that are connected by Ethernet. But that's my recommendation, is instead of powering the radio off and on, if you really want to reset the display, tap function, hold down backup, and then there's an exit button, exit the backup. It restarts the software, and that should probably go away. But I don't think it should persist across power when you go to sideband mode unless something is wrong. Could be a bug there. If I can see what you're doing, I can try to replicate it. If I can replicate it, I can get Elecraft to fix it. Yes, sir. So. All right. So as some folks may know, the KLPA4, the low power amplifier, the 10-watt amplifier in the K4, has been prone to some failures. And some of them in the early models were blamed on the fact that the heatsink wasn't securely bonded to the low power amplifier. People were running 10 watts key down in FT8 mode a lot, you know, getting it real hot. The fans don't really cool the low power amplifier. So they came out with this mod that put some lock washers underneath those screw heads to hold down the KLPA4 to the heatsink a little more firmly. If you've never had a problem, like I have two early K4s, I've never had a problem with them. I'm pretty sure they don't have any lock washers. If it ain't broke, don't fix it. But it is a pretty easy thing to do to install those little lock washers. As far as the service bulletin goes, they don't have any official service bulletins anywhere on their website for the K4 that I'm aware of. But in the K4groups.io, there was a post by the Elecraft Tech, WE6R, or others who have actually taken a picture and showed you where those screws are. And in the case of Elecraft, they have little screws that have a captive lock washer instead of a separate one that can fly off and end up in the bowels of your radio. You don't want to risk that. So I would leave it alone if it's working fine. And how many have here, just show of hands, had to send their K4 back to Elecraft just to have the KLPA4 fixed? One. Just one. Poor Hank. Oh, two. Well, I thought it was more common than that, because that's where you get a skewed view of the world by watching the forum, because all you see on the forum is stuff that's not working, stuff that broke. Everybody, something broke, they want to complain on the forum right away. They want instant fix. Yeah. So Thomas, NY4i is saying that when you upgrade, they add the HD module, like they've already, when you add the subreceiver, the KRX4, you're upgrading a K4 to a non-D to a K4D. When you do that, they also recommend you put in the lock washers. They made pretty strong recommendation to do it. I think they kind of overdid it on that. I don't think it'll do any harm, but I'm not convinced it fixes all the problems with the KLPA4 either. Don't set your fan speed to off. Leave the fan going. We could use a fan in here. I apologize for the heat. They told me the air conditioner is the best they can do today over here. It's cooler in the other room. Go ahead. Yeah, we should have asked Eric that question. The question is, can you update a K4 that has no internet connection using a USB stick? No, we can't do it. I think the factory can do it. They have a way to do it. It probably involves getting into BIOS settings of the PC and doing all the stuff they don't want users to do. The manual says, oh, you can update by USB stick. It might even be an option in the function update menu to update by USB stick. They never implemented that, and I think it's way down their list. Having the K4 connected to the internet isn't too hard if you've got Ethernet in the shack. It's obviously easy. Yeah, no way to update the K4 without an internet connection of some kind. Now, if you have a PC and a cell phone hotspot, and the PC can talk to the internet by that cell phone hotspot, and you got an Ethernet port on your PC, and you turn on Windows Internet Connection Sharing and plug a USB Ethernet cable between the K4 and your PC. Now, your K4, turn it on, it'll get an IP address from Windows Internet Connection Sharing, and it can download and update firmware. And the firmware updates aren't that big. Yeah. Implementation in progress, which means not happening yet. Okay, K4SV, are you in the room? Back there, come on up. He has figured out, unfortunately he doesn't have any slides, but he has figured out how to enable Starlink to work for remoting to a remote server that's on Starlink, right? Is that right, Dave? Dave, K4SV, take it away. About 15 minutes.
Okay, sounds good. Okay, so my layout is I live in North Carolina, and I live in Wyoming, and I live in Nashville. And I can be in any one of those places at any time. And I'm an avid DXer, and so I built a remote station in my North Carolina house. I built it in North Carolina and my Wyoming house, and I operate it from Nashville when I'm there using a K4. So how is this done? Wyoming, I have no internet service except for Starlink, which is excellent. Starlink, if you don't know by now, it's a dish that you buy that provides internet connected to satellites. I also live in the county here in North Carolina, and we have no internet worth a darn, so I also installed Starlink. I built 2 remote stations identical because I have my buddies who use the stations, and I wanted to make it very simple to use. But how do you connect up a network of all this? So here's how it goes. Starlink does not offer any kind of port steering like what you would normally have on your terrestrial or home connection. All it does is a wholesale transport of data from wherever port 80 to your device, web pages, stuff like that. So in order to make this work, we needed to install a virtual private network, which means that it is essentially a subnet of a location that is carried over Starlink. And then you have all of those types of features and functionalities. You have port steering and whatever else you would on a normal internet subnet. So we use a product called MikroTik. It's a reasonably priced router. You can put it in this VPN mode. We have W0JD, who's our IT guy that set this up. Located in Kansas City, we are on a fiber loop of, I don't know, multiple gigabits, so we have super high connectivity. So we have the ability to be on network. So for example, the VPN is hooked to the Wyoming site and the North Carolina site, and I can go on my subnet through the router in Kansas City back to Wyoming on an internal IP address. But for those of us who want to connect to our network outside of the internal network, we also have a fixed IP that you can connect from your cell phone or wherever, and it goes to Kansas City and then goes through the MikroTik routers via Starlink and pops out on the subnet in Wyoming and also in North Carolina. And it works very well. There are, of course, with any kind of satellite system, there are small dropouts, but moreover, the connection's pretty darn solid. You bring it up and make contact. So there's a couple things. Some of you that do digital only does not require another K4 as the control station. I can use a standard internet connection right on my cell phone and bring up I use a real VNC for the computer that controls the antennas and rotors and all that stuff. But I can also fire up WSJT or any digital program in Wyoming and operate it as if I'm there in Wyoming. So it gives you that ability too.
May I ask a question?
Yes.
So this MikroTik router is a piece of hardware you install at both the server site and the client site?
That is correct.
And you plug the Ethernet cable of the K4 into this MikroTik box?
Correct.
At both ends?
That's it.
And it automatically connects. How do you get audio for WSJT through the Ethernet connection?
Well, see, that's
Because there's no USB audio codec.
That's the key. So we've tried the ability to hook the local computer to the K4, say in North Carolina, and go over the subnet to the Wyoming station. But due to the delays in the Ethernet, sometimes the WSJT is not as solid as it could be. And so that's why we rely on the remote computer to run WSJT. Then the audio is solid at that point.
So you're not running WSJT on a client PC, you're running it on the PC at the server site to get the audio?
Yeah, it's actually the one located in Wyoming, talks to the K4 locally.
Mm-hmm.
And then I have another computer in North Carolina which also talks to it.
Okay.
So I could bring it up on my phone right now and we could use either one of those stations.
Tom, go ahead.
Sir.
So you're essentially using Kansas City as a hub for all the VPN from Wyoming, North Carolina, and next.
Yeah, and
once you do that, it looks like they're on the same network.
exactly. Yeah, it's pretty simple all in all.
That server is supplied by TIC, you pay a fee for that. How much do these boxes cost and what's the service cost?
Good question. How much do the boxes cost? They're just about $200 each. And it's a reasonable price for what we get. You can spend more for higher cost routers, but the MikroTik does a very good job for us. Pretty good,
That
reasonable.
includes the free server access?
I'm sorry?
The $200, the one-time fee, includes the
Yes, of
lifetime
course.
server
It's-
access?
It's a 19-inch rack. It looks just like a normal Ethernet hub.
No, I was
or an
asking-
Ethernet switch.
You talked about connecting to a server. The MikroTik box takes care of that. You don't get a separate fee every month from MikroTik? Okay.
Not at all. It's, you buy it from Amazon and install it once you program it.
So you had a question?
QRO. QRO.
So there's a 300 millisecond delay because of the latency in the connection. And
Right, so if you were to remotely control the K4 in Wyoming using your local PC over the K4, over the network, it's about 300 milliseconds.
300 milliseconds? Okay. So that would mess up a little bit of the WSGT timing.
Yeah, it's way better performance if you use the PC in Wyoming. Sir? Yeah, so the Real VNC is now a commercial remote, it's like a Team Viewer, okay? And I bring up the PC that's in Wyoming, and I have several apps connected to the PC. I've got my antenna switch, I got the rotor, I've got the amplifier control, and I've also got my green heron everywhere for switching all of the antenna stuff.
But if you really wanted to physically disconnect the coax for lightning,
I have a grounding position on the antenna
so you're
switch.
grounding the coax, but
Yes, and I
not-
have
not
commercial.
physically disconnecting it.
Commercial lightning protection on everything. Yeah. Sir? No, it costs you money. No, I'm just kidding. No, I'll be happy to share it with you. We have some more time.
How do they reach you?
Sorry?
How do they reach you to get a copy of your?
K4SV@QRZ.com. You can just send me an email. That would be the best.
QRZ.com email forward?
No. My email address is available on QRZ.com.
Right.
Right. Yes, sir.
Kansas City. And they really would just need the microtech behind the Starlink. And in your case in Wyoming, to connect back to wherever they want to talk to it and
Yeah, so since the internet connects everywhere, right, you just need a place to put the central microtick where it has a static IP. Could be your house. If you have a static IP, it certainly could, because then it goes to the internet through the tunnel, right, on VPN to the other microtick, and you're all good. Oh, sir, go ahead. Yep. Yep.
but the question is, with Starlink, you're not getting the static IP address at all.
You don't need it because the VPN provides you a custom connection. Right. So, for example, when you hook a computer to that router in Wyoming, it pulls an IP on the private network that we have. And then, of course, when you do port 80 or anything else, you go out to the internet and out of the Kansas City area. Yeah, if you just want one, it's not hard to do that. Any other questions? All right, good deal. If you do, my email is davek4sv@yahoo.com. Send me an email. Thanks.
Thank you. Thank you, Dave. All right, anybody who's participated in the Aircraft K4 Zoom call, let's get over on this wall and let's get a picture for K8NU. Thank you.
Something has to have a static IP somewhere.
Recognize you with that.
How do you do it?
Going to stick your USB for a later thing, something like you guys talking about. Are you going to upload a presentation here for later?
For next.
Oh, okay, good.
I'm in the antenna form. Do we know if the right protocol is I should stick mine on the desktop too?
Not now. It's just before your presentation.
Okay.
I mean, well, you could do it now. You can. You're saying transfer it over?
Yeah.
Yeah. Go for it. We have time.
Just to keep something back.
You want to be here, Robert? Robert, you really need to. You're really going to want to be here. He. Only those who really want to be here.
Oh. Put those clouds here.
Hopefully.
Have a nice trip out.
My layover was a little long, but other than that, it was good.
Where did you live?
Chicago. Chicago Midway. So it wasn't that bad.
The weather didn't interfere. It's notorious for that. I took the red-eye direct one in last night.
You just got here last night?
Yeah, at hotel number 1, 2. Wow. Well, it's only with a 3-hour difference. The 3-hour difference.
Okay. They're here. Yep. I was telling Robert, only the people who are really interested in this game, even
Howdy.
The next speaker?
Yes.
Hey,
Kellen?
hey, well, this is wrong.
Oh, okay. Are you, you're gonna be the introducer or
Not
whatever?
really. They just let you go.
Okay.
Soon as it starts, because you started, what, 12:15? 12:15, you started.
12:15, yeah.
Now, you're destined to go to 150, or you think it'll,
Right.
now, at about 147, I'll do this before you get back there.
Oh,
I'll be back there.
and it shouldn't be hard because there's two of us speaking. We're each probably gonna do 20 to 30 minutes, and then we're gonna have it's time like
Questions.
participation or questions or
Yeah,
whatever. So
a lot of questions.
it makes it easier. We won't be like trying to finish up our slide deck, and it's time to.
Oh, okay. Okay, and then, if you see me moving back there, I'm doing counting, so don't mind me.
Gotcha.
I'm not looking at anything. Oh, and air conditioning? They know it's not working, but the problem is there's no air being sucked in here.
It's very warm in here.
I know, they know about it.
Yeah, it's not the first time. I know it's always a challenge in new things.
I don't remember being this, I was in these rooms last year. I think they were working okay. And we had about 100 people, 95 people in that last meeting, so it's a lot of people warming the place up.
Greetings, sir. How are you?
Nice to see you again. So, the picture tomorrow, it's at 1 or 1:30, because you and Red have at different times. And
I know.
Keep it up to date.
I think since Charlie put one, I think we're gonna go to one. But we didn't, obviously, we did not communicate well with each other. Yeah. Okay, so here it comes from, actually, so we can confirm it, but I think.
See you. How you doing?
See you. All right.
Thank you.
When I can hear you.
Boy, I tell you, fan conditioning so bad. We were like, we're gonna have to finish this out. And so, you know, like one of us was like down the side of the gate. We just couldn't get anything.
So,
Some of those things.
here's the question. My memory of us solar cycle is like, you know, I was making easy contact. And I'm like thinking this is so bad, but then I'm thinking, okay, really, is it really so bad, or am I just, you know, how over time you remember the good and you don't remember the bad days? I mean, obviously, if there's a big flare or something, it's can cause. But it does seem to be like the cycle activity with sunspots isn't matching up to where I think propagation should be. Is it just me or?
No.
The cycle was doing, in my home, the cycle much better than predicted. And then suddenly I mean, the SSI went down one third. And, but worse, the A and K, and that's where the trouble comes in. If those are quiet, even when nobody has SSI, still let you get somewhere. So it seems to me like the cycle is like, it woke up one day, the last few weeks, and said, wait, I'm supposed to okay, get on it. But I'm hoping that'll get back. Really, that trip, there were some genuinely struggled to get any, and we would trade them.
So it's interesting, being in the coast of Carolina, you know, I'm always looking at mountains in North Carolina, and it changes from day to day. So time 20 where your gains up to 30 to 40 goes, oh.
That's the other thing is like which band is going to be short and which is going to be long. And like, I shouldn't be working in California on 20 meters. You know,
You shouldn't be. I should.
You should be, yeah. Exactly.
And a lot of times
But you
I
probably
walk
don't do it at all.
Well, you know, the money band for me this time with my buds back home, ended up being south, ended up being 40 meters. Usually it's been 30, no, 30, 40 usually ends up being better than 30. And then there was time they didn't give me the 30 running long. Like, it was like everything was flipped upside down. Right? Yeah. Right. And I was on for 2 weeks.
Did you get the?
Yes, 1 o'clock.
1 o'clock. I mean, they just, I mean, even when I got.
We should talk after this event sometime. Well, we should get a couple of something. Anyways, thank you.
talk to me about anything. So hopefully, I don't know. This works.
Hey guys, everybody ready to get it going here? Speak up. All right, so I'm sorry it's so hot in here. Obviously, we don't have anything to do with that. So I just hope that everybody does okay with the heat. We've got some fun stuff to talk about, and hopefully at the end we're going to involve and get some group audience participation and discussion, and we'll open it up for that. But the first thing is we're going to do a kind of a two-level approach here. Charlie, NJ7V, I'm sure you all know him very well from either chasing him or maybe you've activated with him. Certainly you've probably seen him on YouTube, and great guy, and he's going to give a talk, and then after his talk, I will give a talk. And the theme of our thing was SOTA to the max, friendships, sunspots, and pileups. And so Charlie is going to begin with some talk about the friendships in SOTA. I know you're all very familiar with SOTA on that level, and he's got some exciting stuff to share with you. I think we're being live streamed. Is that true? Does anybody know? Yes. Okay. So Charlie's an expert on YouTube. He's used to being in front of the camera. I'm not, but I'll do my best to keep smiling and make this fun for you guys. But I'm not going to talk anymore. Charlie, you take it away, and thanks for bringing your story to it.
Yeah, thank you. Thank you. Okay, so let me first of all get this out of the way. You probably know Adam, K6ARK, ARA, and 6ARA, and you may know Joshua, and for SF, I think, or something like that. I can't remember exactly, but they are in Hertz building. It's a smaller building with they have booths there selling all their wares, so go visit them. And then most importantly, tomorrow at 1 o'clock between buildings 2 and 3 is the SOTA meetup we have here every year. And so if you want to just have an opportunity outside of today and this presentation to rub shoulders with people who enjoy SOTA and ask questions, that would be the place to go. We usually get a group picture there. So you're all invited to come and do that. That's 1 o'clock between 2 and 3, building 2 and 3 tomorrow. Okay, so I walked around the room a little bit and tried to talk to a few folks and introduce myself, and I knew some of you, and some of you I kind of had met once or twice, but not too much. And I asked a couple of you what you were hoping to get out of the presentation today. And some of you was like, I'm just here to enjoy, and some of you, I have some specific questions that I hope to get answered. And so we'll try to cover all that. We'll try to cover some of the rules, and we'll try to cover some of the specific questions, and also we'll try to keep it entertaining. So today I'm going to talk a little bit about how much I enjoy doing Summits on the Air with friends. And I have a specific friend that I'm going to talk about today, but there are multiple people that I have done Summits on the Air activations with, and I truly enjoy the company. And Brad, for example, my good friend Brad, is one of those that I recently have just been doing some activations with. He's great. Let me see if I can advance this. Yeah. So first of all, just kind of a high-level overview of Summits on the Air, some things that I find interesting today, and that is that SOTA and POTA and other field ops have really grown a lot in the ham radio community over the last, well, SOTA actually started about 20 years ago now, but and then, you know, Parks on the Air is more recent in 2018. But there's been a lot of growth, and with that growth there's been a lot of development into new technologies, the different radios and antennas, and we're really living, in my opinion, in a golden age of portable QRP operations. So I'm excited about that. One of the things is that I wanted to mention is that SOTA was founded March of 2002, so that's quite a while ago, more than 20 years ago, by John Linford. And I just wanted to make sure, even though I don't even know if he lives still or not, but I just wanted to recognize him because of how important this program is, G3WGV. And 210 active associations now to date around the world. Started in Europe, in Great Britain. The SOTA community currently has 34,781 participants, and about 7,000 of those are in the United States. And we pale in comparison to how fast and how the POTA community has grown and how many POTA, Parks on the Air, participants there are. There's 500,000 participants since 2018, so they've grown a lot, but that's okay. You know, I think most of us in here probably do Parks on the Air as well from time to time. It's all portable ops is great. Okay, so I've learned over many years of participating in Summits on the Air that everybody kind of walks their own path. Everybody has a different path to their enjoyment in Summits on the Air. I'm gonna see if I can pull this mic off here. So one thing that, well, there's just some contrasts here that I wanted to point out. So for example, you know, some people like the mountaineering, the really tough, hard hikes, Sierra Nevadas, for example. Adam loves those, K6ARK. And then there's the drive-ups, and I love those. You know, you just drive a little bit, you get on top, and you just hop out of the vehicle, make sure you're not using the vehicle, and you're good to go. And everything in between. So there's also solo hikes and solo activations, and then there's, you know, group activations. There's the routine where you have all your gear the same every time, and you have the same peaks you do every time. But then there's those who like to mix it up, try a different antenna every time, try a different peak, and all this stuff. There's the commercial gear that we all like, but then there's the homebrew stuff and making our own antennas and kits. And then there's also the social aspect that people get out of it, you know, hiking with people and the interaction. But then there's also the competition, or the self-competition, I should say, the points and the gratitude of achieving things in Summits on the Air. So again, it's very broad, and everybody has a different approach, and that's what I love about Summits on the Air. So another little aspect of Summits on the Air and personal growth is, I think, this doesn't necessarily follow in exact order, but a lot of times when we first start thinking about Summits on the Air, we're thinking about, how do I do this? What radio do I use? What antenna do I use? And it's a lot of questions and trying to get everything ready. And then you kind of get into it, and it's like you're going and you're figuring out the gear. And then when you reach about 800 points, then it's like, I'm going to go and do 5 summits every day until I'm done. It's maybe not that much, but you get excited about getting that goat. Then on the other hand of that, you've got a lot of people who are in the shack who really like to chase and enjoy that as well. Some other things, some people start with sideband. Some people already know Morse code. And some people will say, oh, everybody's on Morse code. Let me try it. Some people try it and say, no, this isn't for me, and they stay with sideband. Love it, that's okay. And then other people take that CW journey and incorporate that into their Summits on the Air experience. There's evolving gear. There's people who just like to do it for pile-ups. And so as you participate and as your journey goes on, you find different things that you enjoy about Summits on the Air, kind of a microcosm of the same way things are in ham radio. You know, if we don't always just do VHF and ham radio, we branch out and do other things. And so eventually, a lot of us will give back to the community. And I know a lot of us here have done that. Paula, for example, she does all kinds of wonderful things for her people in her community and outside the community. It's just a great community that we have here with the SOTA folks. And I love the meetups. I love the campouts. And we've really grown in our opportunities to have social interaction with each other. So thank you for that. So the last thing is give me bigger adventures. I have that on the list last because that's kind of the thing I've been focusing my SOTA journey on of late. It's, you know, the points, not so much anymore. I like the social aspect, and I also like finding some challenges, ways to challenge myself beyond just getting the points. And so today I wanted to talk to you about a couple of trips that I had in the Navajo Nation, and share those experiences with you a little bit. So a few interesting facts about the Navajo Nation. It is it's the largest reservation in the United States. It's 27,000 square miles of land, and it's located mostly in Arizona, but also a lot in New Mexico and a little in Utah. And it's self-governing. It's a self-governing nation, and they have their own laws, and some of them are very interesting. Total population, about 400,000 since 2021. And one of the things why this is a challenge is why I have had this as a challenge is because if you're not a member of the Navajo Nation and you want to activate a summit there, you have to have a valid permit from the Navajo Nation, or you have to have a guide or friend take you on the activations. And you know, some people have activated outside that, and we're okay. I mean, it's, you know, some people forgot the rules or whatever, didn't know, no big deal. But that's if you want to do it right, that's the way you do it. And so there's a few people, like I said, activated it on the reservation, but there's very few summits in the reservation, the Navajo Nation, that have been activated. There's a few. And so I'm like, this is a great place maybe for me to do some first-time activations. I have a great friend who lives up there who has kind of been my guide, and I've went on activations with and actually introduced him. So here's a little map of where I'm talking. So if you look at the map here on the right, that's where Arizona is, for those of you who are really challenged with the United States. And then the map on the left is the property, or the boundaries, I should say, of the Navajo Nation. It doesn't touch Colorado, or it doesn't go into Colorado, you can see. And you can see how it kind of really extends to the right into New Mexico quite a bit. The governing council is actually in New Mexico, and even though the largest portion of the area is in Arizona. And then there's this little piece in the middle that's kind of like a little island, and that is the Hopi Reservation, which is a completely different governing body and completely different tribe than the Navajos. So here's Herb and myself. We were doing an activation. Herb, N7HG. Some of you may know him from another area, but I introduced Herb to Summits on the Air. I heard that he was interested in doing Summits on the Air, and so this was kind of a win-win. I thought, I'll introduce him to Summits on the Air, and he can take me to the summits that have never been done. And it worked out good. Just a little bit about Herb. His father was a code talker, and so his involvement in ham radio has been, once his father passed away, he thought, how am I going to honor my dad, who was a Navajo code talker, with his service? And he thought about it quite a bit, and then he realized, what I can do is I can do a special event call sign and do some special events that recognize the code talkers through ham radio. And so even though the code talkers didn't use ham radio, they used code, but a different kind of code than CW. So the Navajo Code Talker special event call is N7C. Every September, Herb goes to the Navajo Nation in Window Rock, the capital, and he does a special event for, I think he does about a week, where he uses that special call sign, and he does it at it's one of the few places that actually celebrates still the Navajo Code Talkers. They have a Navajo Code Talkers Day at Window Rock, and there's a big monument there that recognizes the code talkers, and he sets up his station there, and he operates. And I also use that same call sign on Summits on the Air and do some summits also, and then I'll send those logs to him, and he'll send out the QSL cards and the recognition that people get for participating. He also does in Arizona and in New Mexico, he'll go to Hamfest, and he has these really beautiful displays that describe how the code talkers, what they did, how they participated in World War II, and have pictures of his dad and how his dad participated. And so I think that's great. And then he also does presentations, and he'll do them online too. So if you are somebody who's a part of a club and you are interested in maybe learning more about the Navajo code talkers, then you can invite him to be a presenter for you. Okay, so I was interested in doing some never-before activated summits. And so here's the three listed that I wanted to do: Roof Butte, Matthews Peak, and Yale Point. And it turns out that Matthews Peak was already done, but that's all right. It's a drive-up, so, I mean, why not do it, right? So the first arrow here on the left is where he lives, where Herb lives. It's called Lukachukai. And I was driving there, and I drove through Chinle, which is a very small town with one Walmart and a couple of fast food places, and that's about it. And I headed towards his place, and I didn't pass many things on the way. And I finally got to Lukachukai, and there was one store. It was a post office / convenience / grocery store, and that was it. And then the rest were just a few little houses, and so he lives in a very small, very rural area. And so I called him and I said, I'm on my way. I'm going to come to visit. And he said, okay, well, you can stay on the couch. And I'm like, that's great. He lives in a trailer. And I said, okay, I'll be there around 5 p.m. And this was 3 days before. And he goes, okay, sounds great. So then I arrived at 5 p.m. and nobody was around. And so I said, hey, Herb, where are you? And he goes, oh, I'm in New Mexico right now. You'll have to wait a couple hours. So I sat in my car and waited for him for a couple hours, and it got dark, and then he finally pulled in, and I said to him, it was kind of a little weird out here in the middle of nowhere. There's a lot of shadows and stuff like that, you know, behind I saw something behind my truck, and he goes, oh, those are the skinwalkers. And I'm like, oh. So anyway, that was interesting. So the next day we went and we did this drive up Roof Butte. And you can see in Arizona, Arizona has some beautiful areas. We have pines and we have some high mountains, but we also have low desert and very ugly territory. Maybe in your opinion, maybe not. I love the desert. But this is Herb and I on top of Roof Butte, and that picture there is the Chuska and the Tanicha mountain ranges. And when you're looking south from Roof Butte, you'll see this is what you look at and what you see. And when you look from Roof Butte, when you look to the east, you see a thing called Shiprock. And it's really interesting. It's just it's a sacred little monument, and it's in New Mexico, actually. We're on a peak in Arizona, and we look and we can see Shiprock in New Mexico. It's pretty interesting. And then here we are activating. Herb is, since it's a drive up, we were able to put all out a chair and have a good time. But let me just do this video here real quick. I don't know if you'll get the audio or not. Maybe not, but it doesn't matter. I just wanted to kind of show you what it looks like there in the back a little bit. It's a beautiful mountain up there. All right. There's some radio towers up there, but that's all right. Oops. What do we do? Am I gonna have to? What if we do this? Recently opened PowerPoint, and oh my gosh. All right, let me advance. I don't know how that happened. Here we go, we'll do this. Yeah. All right, nearly there. Okay. So when we went up to Roof Butte, we activated that, had a great time. We actually used VHF and were able to make a contact with somebody in Durango, Colorado, and somebody in New Mexico, and somebody in Flagstaff, Arizona. It was great, on 2 meters. It was a really fun activity. Then we left and we went to what was gonna be our first never before activated summit, Matthews Peak. And what we did was we traveled south from Roof Butte along a dirt road to what we thought was Matthews Peak. And along the way, there were some really interesting things. And Herb talked to me about this, about how when he was young, his family used to live in Chinle, a bigger town than he's in, and they had sheep and other livestock, and his grandmother and his mom and his family would take the livestock up to this area in those mountains in the summer, and he spent summers up there living, and then in the winter they would take them back down. But he said that he lived in hogans, and that there was no running water, it was just a camp. And that's how we lived each summer. And you can see here on the upper right, this is kind of a well-built hogan. There's a lot of these up in that area and also in all parts of the Navajo Nation. It's just a octagon-looking, one-room building, and sometimes they'll have like gas stoves. Are you okay? Okay. It was a cheap chair. All right, so I'll draw attention this way so he doesn't. Anyway, so over here you can see another hogan in the middle. and then the fence that they make out of these little twigs and stuff like that. And this one on the right bottom is just kind of some of the valleys that we drove through. Very beautiful. And he said they were full of livestock and sheep and stuff. So it was interesting. This is kind of a look at the drive. On the right is the 40-minute, 10-mile drive, which is actually turned into about instead of a 40-minute drive, it was closer to an hour and a half drive to get there. And on the left, you can see the blue line is the line that we should have taken. And the red line is the line that we did take to drive to the top of Matthews. And in that square there in the black, that's the peak that Herb said was the top of Matthews Peak. And he said, and I said, "You're sure that's Matthews Peak?" Before we left, and he said, "Yeah, this is Matthews Peak because there's a radio tower up there. We maintain it, and that's where it is." And so we drove there. We got to the base. I don't know if you can tell by the profile there, but it was very steep. There was hardly a road, and it was very, very, very rocky. I was nervous to take my little Xterra up there. But we got to the base, and he said, "Yeah, this is it, this is it." And I said, "Okay, well, I don't know if I should make it." And he goes, "Let's just go for it." And what I thought he meant was just gun it and get over these big rocks. What he meant to say was, "Let's just hop out of the truck and go hike it." So I gunned it, and we went up to the top, and I made it. My poor Xterra made it up there. It was okay. Got to the top, and I pulled out my phone, and I'm like, "Okay, I don't see a pin." And I know what you guys, some of you may not know what I mean by I don't see a pin, but on the right of this slide here, when you open up SOTLess and you want to see where you're at in relation to where you should be, there's a red arrow there on the upper right, and there's a little button there it's pointing to. If you push that button and you have SOTLess open, it'll zoom right into where you're at based on GPS. And so I did that, and there was no pin, which meant that I was not in the activation zone or anywhere near it. And so lesson learned, and one of the first lessons that I wanted to share with you guys today, and that is, if you're going to do a SOTA summit, make sure you know where the eligible activation zone is and get there and not someplace else that you think is there. We figured it out though, and let me go back one slide, 2 slides. Let me see here if I go back. So there's the green line you can barely make out probably. We didn't know actually that there was a drive up, that Matthews Peak was a drive up. We thought it was a hike. First we thought it was a drive up, and then we realized we were at the wrong place. And then we thought, okay, we need to get over there, and we didn't have any beta on where over there was, so we just kind of drove that way as far as we could, got out of the truck, and then just hiked to the Matthews Peak. And when we got there to the top, we saw the road, and I'm like, oh, this is a drive up. But that's okay. So anyway, let me advance this back now again, the other way. I'm not a skilled PowerPoint professional, as you know, it looks like. Okay, so this is the activating Matthews Peak. It was the first activation. On all the activations I did with Herb, I made sure that he was allowed to be the first one to activate. I know, when you do joint activations, I thought that when you do joint activation, you should let the other person go, and that person, whoever goes first, is the one who gets credit for the first activation. As it turns out, it must be a change in the database. If you activate at the same time, you get dual credit. But I still let him go first. But he had a great time. He operated sideband. I operated Morse code. And this is just kind of a look. This middle picture here is that if you can see the bump, you probably can't see it very well, but that's where my truck was when we on that ledge there when we went to the wrong peak. All right, let's see here. Okay, second summit I did out there was called Yale Point. And so I said, "Do you know where Yale Point is?" And he said, "Yes." And I said, "How do you know?" He says, "Oh, there's all kinds of antennas up there." And I said, "Okay." And this was a long drive. So the arrow on the right is where Lukachukai is, and the arrow on the left is where Yale Point is. And I think it was at least a 2.5, 3 hour drive to get to those radio towers. And you can see on the left, there's a little map there, and there's a red X, and then there's a green pin. And which one do you think we went to? We went to the red X, where all the radio towers are. You can kind of see it written down there, radio towers. And when we arrived there, I realized there was no pin. So again, so this is what it kind of looked like. This picture in the middle is not where we were hiking. I couldn't find a picture of where we were hiking, but it's very similar, and it is a section of Yale Point. But what we had to do on Yale Point is we had to drive back down to the bottom of this mountain, and then from there we had to figure out how to get over to Yale Point, which actually, there's a road on the map, but there isn't one that you can see when you're actually there, physically there. And so I'm like, I don't know what we're gonna do. And he's like, well, just gun it, just go through there. And I'm like, okay. So since Herb says so, I went through this little pasture area, which I probably shouldn't have done, but he said it was okay. And we found the road. And so then we took this horrible road kind of up through this canyon, and we stopped. And this wall here that you see is kind of what we were facing on both sides. It was just this canyon. And so we kind of looked at the contour map, and we thought we could get up at a certain way, and we were lucky that we were able to, because we didn't do a lot of research, obviously, because that's not where we thought we were going. Second lesson is, okay, first lesson, don't do it twice. Don't go to the wrong summit twice. The second lesson is, if you find that you're not in the place you should be, if you can safely make an alternative plan and get there, then do it. If you can't, then don't. And so we thought, we're just going to take it a little at a time. We did find a place that was a little rocky and a little precarious, but we found a chute, so to speak, that we could climb up into, and then we got on top of this flat plateau, and we hiked for probably for a mile to the end to where the activation zone was. And so we did it. That was the second never before activated summit. There's Herb again doing sideband, and then I followed on CW, had a good time. All right, so let's move this to the next slide. Okay, I went out there again a few months later, and because I wanted to get some more never activated summits. And again, you can see this map. It was a map I showed you before where it's kind of the Navajo Nation boundaries. You can see the arrow there that's pointing kind of to the south of that boundary line. That's where I went the second time. The first time was up more towards Four Corners. This time it was down south. And this time I didn't spend the night. It was a day trip. It was I think it was around 3.5, 4-hour drive for me to that point where those two summits are, and about 3 hours for him to come down to where I was at. We met halfway, kind of, and we picked these two summits, 5 buttes and then a numbered peak. And there was a challenge with these two, a different challenge. It wasn't the pin this time. If you can look at that, so let's look at the one on the right first. If you can see on the right, there's basically a wall all the way around this mesa, okay? And if you look at the aerial view, you can see that it's really interesting and would be very challenging to get up there. But something that I learned from Brian and a few others, Brian's here with me, maybe some JT, is that if you look at the aerial maps and you zoom in on the aerial maps, sometimes you can find paths where people have been, especially in the desert. It's not so easy out east here because you got trees and stuff like that. You still can sometimes, but out west, there's no trees, so you can zoom in and you can kind of see trails sometimes. And so we did that, and we found a path that we thought we could take. And so, and also a road that we could take almost to that face part. So drive kind of up to there. Our plan was to drive up and then to hop out and see what it was like. And we said, if not, backup plan, we'll go to a different peak and try again. If not, we'll go to a third peak. So we had a backup plan this time, but we were lucky. We hiked up and we were able to find the crevice. And this is Herb right here, kind of on the right, kind of going up that chute that we found. And it was actually a well-maintained trail, not a well-maintained trail, but it was a trail that other people had obviously had got on top with. And so once we got on top, then it looked like we were just in a field. It was probably the size of this whole fairground, but it was just flat. And you wouldn't even know you were on a mesa. And I think that the whole mesa was the activation zone. But I told Herb we should go to the pin just because that's what SOTA people do. Not all the time, but anyway, so we did. We went there. There was no trees up on top at all, nothing to tie down to. So we ended up tying down to, on the right, you can see, there's just some brush there. And I just stuck my antenna in there, and we did the best we could. But we made the contacts, same thing, he was on sideband. You can see here on the bottom left, I'm doing Morse code, sitting down with my big sun hat and my sleeved shirt, which I always wear in the sun because I hate wearing sunblock, so that's what I do. All right, let's see, we're getting there. All right, peak 6315. That one was pretty much the same thing. The only thing that was interesting in this one that I hadn't seen before was this sweat lodge. And we drove up and we pretty much followed the path that we thought we were going to get to, got to the top. But on the way we passed, it wasn't this one, but it was almost identical to this one, a sweat lodge. And Herb talked to me a little bit about the Navajo's traditions and what they do with the sweat lodge. And I can't remember everything that he talked about, but basically 2 or 3 people get in the sweat lodge. They get it really hot, and sometimes it's ceremonial, and sometimes it's for physical health. But they don't do it as much as they used to, but it's part of their ceremonies. And it was fascinating because this is obviously a sweat lodge that had been used a long time ago, and he verified that. So that was cool. So same thing. We found a kind of a route to get to the top, get through that wall, and had a good activation. Same thing. It's a little bit more hilly on this one, but still quite flat. Right. Okay, so that's it. We're going to hold the questions unless you want me to answer some. Okay, let's. I could take some questions and then we'll turn the time over to Keith. Yeah, go ahead, Paula. Yeah, I'm glad you brought that up because I want to talk a little about that real quick. So yes, Herb, yes, thank you for that. She was asking, she said that Herb was probably less experienced than I, but he was the one in Navajo Nation, so I was probably relying on him for finding the directions and stuff like that. And really what was happening was I was his Elmer in this case. He had never done a Summits on the Air activation. So I was not trying to do it myself. I was trying to let him plan it, and so I gave him the tools, and I said, okay, here's SOTLess, the website. Here's, go zoom in on the peak, and then, look at the aerial, and I tried to give him the tools, and he said, yeah, I got it, and so I trusted that. But
usually what I'll do is I go off by myself, and I don't go quite this far, although I would do it if I was close enough. I will actually create my own map. I use a tool called SOTA. There's other tools. Create a PDF that will show you just where you are. And even when I see roads and they involve a person, I'm not sure if it's there or not, I'll create them like a sequence map where I'm driving. I literally see where I am. So in case that Charlie described, I would have seen, oh wait, I'm going this way. I mean, it's really easy to say in hindsight, but that's a tool I use all the time in my plan, particularly where I know I'm kind of going off the road, off the roads that may, as Charlie pointed out, on the map only. And that's why I asked him about flying from purpose. I figured, yeah, if I was going to Navajo Nation, I figured, I'm not doing that. This guy knows where all of it is. I wouldn't have done that.
Yep. Thank you, Paula. And I know maybe the stream didn't hear what she said, but what we'll do from now on is if there's comments, maybe we'll have you come up and get the mic, just so we make sure that we can hear. But thank you, Paula. Any other questions before we? The question is, what am I running for equipment these days? As of late, I am using the new CFT1 transceiver that KM4 CTF has developed. It's a 4-band, was it 40, 20, 40, 30, 20, 17, and 15, a 5-band transceiver. So I use that radio. I built the kit, and then I still use the old link dipole that I make and power it with a bioenno. And every time I go out, I have a different key. So you know that if you watch my YouTube channel, and so does that answer it? Okay, cool. Yeah. What was the name of the mapping tool that Paula asked about? It's CalTopo. CalTopo.com. Okay. I'll take one more question, then there'll be more time after. We'll get Keith in here to get his presentation, and we'll leave plenty of time after for but is there another question? Okay, Keith.
Okay, thanks, Charlie. That's awesome, and hopefully that inspires you a little too, because one of the cool things about ham radio is how many different things you can do. Charlie's been a SOTA activator for a long time. He's like almost, are you 5-time mountain goat now? Okay, so I mean, he's been on a lot of summits, and I'm sure he would tell you it's never the same. You go to this summit and that summit, it's always a unique experience. But something like what he's done is very, even takes that uniqueness to a whole new level. Living in Arizona myself, I know I've gone to summits that I thought were open on Native American land and been told by them you're not allowed to go there. And so it makes it a challenge that he figured out a way to overcome that challenge by involving a true friend of his, and that what an experience! You're going to have a lifetime of memories, I'm sure, from that. So my presentation is going to be a little different. If I can find it here. Okay. Okay, so what I'm going to do is I'm going to take the more of the sunspots and the pileups aspect of summits on the air, and to kind of give a framework to that, I just want to tell you, if you're interested in SOTA, now is like a fantastic time to participate in SOTA, and there's going to be memories that you can build right now that 5 years from now you're going to be going, oh man, I wish it was like that still. And so I'm partly here just to try to motivate you, which is kind of funny coming from myself, who is right now in a mode of other things in life dominating my time, but I am so motivated to get on summits, and it won't be long, and I will be back to where I was, I think. But the more the merrier, in my opinion, the more you can get up there. And the funny thing about ham radio is it's continuous, but there's certain seasons where it's better than others, and particularly in the 11-year solar cycle. So we're in cycle 25. Back, I believe, in the 1600s, Galileo took a telescope lens and held it over a fire, got it smoky, and looked at the sun. Terribly unsafe thing to do, by the way. It'll make you go blind, but he didn't know, and he discovered spots on the surface of the sun. That was a very bad thing at that time to announce to the world, because the sun was supposed to be perfect, and to claim that there was spots on the surface of the sun was not maybe not a great political move on his part. But you can look at the sun. This is a picture I took of the sun just last week, and it was very cloudy in Flagstaff, and so you're not seeing the sun spinning there, even though it kind of looks like that. What you're actually seeing is clouds passing in front of the sun. And if you're very eagle-eyed, you may actually pick out a sunspot in that video. But the reason I'm showing you this is the sun is active and dynamic, and right now we are at the peak of solar cycle 25. So here's a graph from NASA. And it shows where we are in the cycle. The cycle, if you don't know already, is about 11 years approximately. And what that means is at the peak of the cycle, the sun has certain types of activity that it does not have at the minimum. And that manifests itself in the number of sunspots that appear on the surface of the sun. So if Galileo had looked at the sun when it was at solar minimum, maybe he wouldn't have even seen any spots, and he would have said, oh, the sun is perfect, just like they've been teaching us all this time. he probably, I don't know this for a fact, but he probably looked at it during solar maximum or something like that. Right now, we're at the top of that graph. It may not be real readable in the back, but and what's going to happen going forward isn't known precisely, of course, but it's pretty predictable that, say, a year from today, we're going to be starting to be on that downward curve. The number of sunspots will become less. And if you've been a ham for more than a solar cycle, you know that when the solar cycle is at the peak, that's usually when HF propagation is going to be best. And when we're at the minimum, HF can be challenging. And I'm defining best and challenging really kind of based on distance. You can always make contacts on HF. And that's, so I don't want to discourage you like, oh, you better go do summits now because 5 years from now, there's not going to be any activity. There always is activity. You just need to learn where to look for that activity and what to expect from it. When we're at the peak, basically the ionosphere becomes better at reflecting signals to take you longer distances. And I'm really generalizing there. I don't want this to be a talk about the sun, specifically, but there's actually predictions now coming out that people are saying maybe we're going to start seeing an era with even stronger cycles going forward. So what we're at today as a peak, maybe 11 years from now, the peak might be even better. To bring it more current, this picture here is from, today's the 16th, I think, right? So 2 days ago in the morning, the sun released the largest solar flare of this current calendar year. In the science terminology, it was a X2.7 class. And so I just told you that during the solar maximum, propagation is better. But ironically, when the sun gets too crazy and it gets too excited, it can actually create havoc and basically wipe out communications. And in fact, that is what happened 2 days ago. Depending on where you were, I don't know if was anybody in here on a summit 2 days ago? Okay. And was it terrible propagation? Unbelievably awful, Brad says. Okay, well now you know why. See that bright spot over there is an eruption from the surface of the sun. The eruption went out who knows how far, how many millions of miles, basically much larger than the size of the Earth. And as it's throwing off all this crazy high energy material, some of it sometimes reaches our planet. And sometimes that can do wonderful, beautiful things like create aurora that you can see up in the sky. You see these flickering, colors. We don't see it down in Arizona hardly ever, but I used to live in upstate New York, and sometimes out there I would see it frequently. And those aurora themselves can give you some propagation tools as well. I'm not going to go into all that, but generally speaking, some of the seasoned SOTA operators are going to be telling you propagation these days isn't that good. And I know from my own radio experience, there's days I turn on the radio and I'm like, wow, it's like quiet or noisy quiet. Not, in other words, there's no signals from other operators, or I should be able to hear Paula up in Wisconsin, and instead I can only hear her in California. And why is that? Well, there's a lot to learn. But again, I want to back that up to right now, we are at solar maximum, and I want to encourage all of you, take advantage of that as much as you can. Enjoy that propagation. Maybe now is the time to use certain bands that 5 years from now you're going to be using certain other bands. So for example, here's a screenshot from the SOTA Watch, the spotting tool that is available to us all on the web. And if you're a newbie to SOTA, you definitely want to learn how to use SOTA Watch. It lists all the active stations at least that are either have spotted themselves or are picked up by somebody else spotting. And what I want to point out here, and I've circled in green, was Robert, Whiskey 6 India Whiskey November, was on a peak in the North Sierras, and his comment in his spot was 6 meters is open, and he was using 50.313 megahertz. He was that's a FT8 channel, not channel, but a frequency that's common for FT8, and so he was encouraging, and there's a couple other spots from him as well. 6 meters is open. And I was getting emails from club members saying, wow, 6 meters is really hopping. We're working all the way to Canada today. Why was 6 meters hopping? Well, because we're at solar maximum. You will not see these kind of openings very often at solar minimum. Again, you know, it's like fishing. Maybe some days you're going to catch fish when you don't expect to, but in general, if you learn the patterns, so my point here is the upper bands right now might be your bands of choice. If you know me, you know that I'm a super fan of 10 meters. I always, when I'm activating, unless I'm really short on time, I will always try 10 meters, even, doesn't matter. Solar minimum, there was times that I'd work Gary and Martha in Kansas when there wasn't a single spot on the surface of the sun. I can't explain what was happening. Maybe it's sporadic, maybe it's something else, but it wasn't regular. But if you were running 10 meters last fall, bands were wide open. So right now is a great time to use those upper bands. And then when the bands aren't so good, maybe you're going to want to go back in the lower bands, or maybe you want to go into VHF or UHF. It's all part of that experience, enjoying, trying different things, and like Charlie says, you know, find your adventure that you want to have. So given that, you might consider, this is more on the tips, does your radio that you're using have multi-band capability? Is that important to you? Maybe it's not. Maybe you want to be a 40-meter expert all the way, and that's all you really care about. And that's totally fine. And there's people that pretty much focus on one single band. But just realize that the money band, you know, today may not be the same as the money band tomorrow, and that may not be the same. So you have to decide, do I want variety? Do I want... right now, currently, I'm saying the upper bands are a nice place to try. Well, this is a picture of the KH1, the Elecraft KH1. That's a popular QRP transceiver, handheld. It's phenomenal. I'm stunned every time I use it. That's my own KH1 I acquired, and I use it when I travel. It's what I brought here to Dayton in case I find time this trip to get out to a summit. But the KH1 doesn't go over 15 meters. So if I want to try 12 meters or 10 meters, I'm out of luck. To me, that's a disappointing feature. It's a trade-off they're making to keep that rig so tiny and portable. And by the way, I have to include a picture of my doggie every time I do a talk. So that's Snowball enjoying the summit and saying, why are you taking so long? I want to go get a treat. Okay, so I'm not going to fill up, I could fill up this screen 100 times over with all the rigs that are available. I just want to, these are a couple of the more high-end portable rigs. There's the ICOM 705 and the brand new Yaesu FTX1. Those rigs are kind of do it all. You can do HF, you can do 6 meters, you can do 2 meters, 70 centimeters. You can spend a lot of money on any of these three rigs. Are going to cost you plenty of money, but they provide opportunities to experiment with different bands and do different things. So consider when you're going out to activate, what is it you want to achieve, and is the radio I'm bringing capable? And it may very well be that you want to bring, you know, a tiny, tiny rig that maybe you're a trail runner and you want to carry a lightweight portable rig, or maybe you're just trying to understand the concepts of constructing your own kit and you're building a 1 or 2 band radio that you built yourself, which is a completely other super exciting. And I'm sure people in here have, many of you have probably done that. Okay, before I go to the next slide, can I just ask if somebody wouldn't mind taking a few pictures? That's one thing I always forget, and when I reach that point where my memory is not so good, I'd love to be able to look back and see some pictures. Okay, so we talked about the radio. What about your antenna? And you know, the antenna is a big part of SOTA operating. So the picture you see there is a picture of myself in front of a disc cone antenna. That disc cone antenna obviously isn't going to be something I can carry in a backpack. In fact, that disc cone antenna is located in Green Valley, Arizona at the Titan Missile Museum. It was built by the Air Force, and it's now available if you visit southern Arizona. In fact, it's if you're into parks on the air, it's a POTA site, I think. Is that right, Charlie? I'm pretty sure it's a POTA site because local clubs go down there sometimes. You can plug your radio into that disc cone. The reason I'm showing it, that disc cone will cover any frequency on HF. The point here is you have to figure out, first of all, do you want multi-band? Second of all, are you going to be using a tuner? There's all kinds of little factors involved. And so I think, Charlie, you mentioned a linked dipole that you like to use. And linked dipoles are awesome. I've built one and used it. And you know, then you can build a linked dipole and you don't need an antenna tuner at all. That can save you some money. It can save you some weight in your pack. But you do need to link it when you change bands. So you're going to have to stop if you see like so-and-so, you know, I see NJ7V's on a Summit, and then I want to work from Summit to Summit, but he's on a different band than me. If I'm on a linked dipole, I got to stop, reconnect it, and start up again. So there's trade-offs. There's always trade-offs. A vertical, you know, a lot of people now are using verticals. There's more and more coming out on the market from all kinds of different manufacturers. Elecraft's got a new one. Radioddity is selling one. Those are great. Again, you don't necessarily have to have a tuner as long as you can tune it correctly, but you got to spend the time to find that right tuning. Terminated folded dipole is something I'm experimenting with currently, and again, this going, but and there's others. There's plenty. This isn't an exhaustive list, but if you are willing to carry an antenna tuner or your rig has one built in, then you open up a new level in a different way. Maybe your efficiency might not be so good. But if you're running an NFED, you're probably going to want to tune it. If you're running random wire, like maybe a Pactenna, you go and buy George's here with Pactenna, and those are cool little portable antennas. If you want to do multi-band, you're probably going to be needing to have a tuner. Again, a vertical that's just a standard length. And my favorite antenna on Summits is an off-center fed dipole, and the OCF generally will cover quite a few bands without any kind of tuner, and if you add a tuner, then you can do really well with that. The reason I like that OCF dipole, though, is it's not a matter of thinking that's the best antenna to get my signal out at all. Probably the best antenna that I've ever taken to a summit was actually a buddy pole, and I carried that at the beginning of my SOTA adventures, carried that around, and it was huge. It was this big bag, but I got to tell you, you can essentially tune your dipole to precisely as you want it to be tuned, and you can turn it so you got a little directionality, and it really works well. It's just a lot to carry. And so the OCF, I can change bands in a heartbeat. It takes 0 time to change my bands. So if I see Charlie's on a summit, I want to work from summit to summit, click that band and I'm there, and I don't have to go through any tuning process. And that's my own personal preference. One of the cool things about SOTA is you can test and play with whatever you want. There was a operator in Japan who was quite active a while back, and I haven't seen him as much anymore, but at one point he built a very portable 2-element vertical beam. And that it sounds odd because we're not used to thinking of beams as being vertical, but he published an article about it in QRP magazine, and so I emailed him and I said, hey, that looks really cool. And here, he said, oh, we don't get that magazine here in Japan. I didn't even know they published my article. So I put the magazine in an envelope and mailed it to him. And complete surprise to me, he mailed me one of his antennas. And I went and played with that on the summit, and it really was actually pretty cool. So messing around and trying different things, even though I have my favorite, it doesn't mean I'm only going to use that antenna. And again, I encourage you, where we're at right now in the solar cycle and everything, play around, see what you come up with. It's always fun. It doesn't have to be the best to have fun with it. So because the bands are doing well, generally speaking, there's going to be better DX opportunities. We're seeing more and more DXpeditions than we saw a few years back. But I wanted to point out, let's see. This was a post on the SOTA reflector only a few days back. It's from Bob Whitty, K0NR, and he was just announcing that he and his wife are going to American Samoa, and that's Kilo Hotel 8. Bob is a super active activator and long time, but he mostly does VHF, and mostly from summits in Colorado. And I'm assuming Bob's not in the audience. Bob, are you in the audience by any chance? Okay. But I want to alert you to this because this is coming up. He says from May 27th to June 9th, they're going to be there. And one of the things that fascinates me about this is he says he checked it out. There are SOTA qualifying summits, but there was no association yet. So he contacted somebody, and lo and behold, he's now the section manager or association manager for KH8, and he's planning on doing something. I think that would be pretty awesome to work Bob on a Kilo Hotel 8 summit. And American Samoa isn't the most rare DX, but it's still DX. And on the flip side, if you personally go anywhere, why not take a radio? And you're here at Dayton, bring a radio and go activate Campbell Hill, which is super easy. Or I've forgotten the name of it, but the one in that's across the street from the Taco Bell. Somebody help me out. Okay. Yeah, there are summits here. This has been my adventure of late. Is I find like the best times I can find time to go activate are when I'm traveling with my wife, and we did an adventure back in December, and I drove from Arizona up to Victoria, British Columbia, and along the way made stops in Utah and Idaho and Washington and Oregon and California, and I just did a bunch of really short activations. It doesn't matter how many points they are. I know some of you, Paula, you travel a lot, and you do these, great activation adventures. And yeah, ask Paula about our her Grand Canyon trip. But she visited me in Flagstaff, and And that was the one day it snowed, and literally, I'm not exaggerating, the snow was to our waists and post-holing up the hill, and that was a lot of fun. So if you go to American Samoa or if you go to Bouvet Island, okay, now if you're a DXer, you know Bouvet is like kind of the famous, this is crazy hard, top of the honor roll type DXCC country. Well, it turns out they somehow found an association manager for Bouvet, and there is a summit on Bouvet, and the question is, will anybody actually climb to the top of the glacier while they're there? That's questionable, but it's been talked about, and there is a summit there wouldn't that be pretty awesome, not only to get that credit, but to get it as a SOTA credit on top of that? When you are activating on a summit, there's no reason you can't chase DX. You don't have to be only working other SOTA chasers. You know, so when I activate, a lot of times I will pull up the DX cluster at the end of the activation and kind of see, is there anything on here that I really want to work? Because guess what? When you're on a summit, your signal is better than when you're down in the city. And so it's not unusual to be able to work a DX, maybe a DXpedition or somebody out there a little easier than you might otherwise be able to. Okay, I'm nearing the end of my talk, but I want to encourage you as a chaser to take every chance you can to chase people. And in my own personal life, that has involved using my mobile station, because I live in an HOA that doesn't allow antennas, and very, very restricted. My attic antenna just doesn't really perform. So if I've chased you while you're activating, it's almost a certainty I was mobile. I also do way too much driving, and this is a way I can still engage in my hobby. Mobiling isn't new. This is an article from 1922, I think it was. A guy with says radio on the ranch, and he's got some kind of a setup on his horse. I don't know if that was a joke back then or if it's reality, but this is my station. Actually, I have a different car now, but I still have the same antenna. It's a Tar Heel screwdriver, and obviously I didn't take this picture on Facebook one day. All of a sudden, I get a notification, somebody tagged me. Somebody else posted this picture. What is this crazy car driving down the street? And so I don't really care. If it looks crazy, so what? I'm having a lot of fun with it, and that's all that matters to me. But there are so many options to set up a mobile station. You know, you can go out in the Hamfest and find plenty of radios. My own personal rig in the vehicle is a Yaesu FT891. It's inexpensive compared to other HF options. So if I get broken into, which I never have, but it would be less of a loss maybe. And it has a CW filter, so that's all I really need. And the screwdriver tunes up and down, and I can work pretty much any band from 80 to 10 on that setup. Okay, so kind of a couple last things to wrap it up. There's lots of new gear out there. Again, experiment. Here's another old-time thing. This gentleman figured out a way to hook his corncob pipe to his radio set. I don't necessarily recommend that, but be creative and then share your ideas with others. So the last thing I want to do, you know, because now obviously if there's a solar flare and they get a blackout, this doesn't matter, but there's other times when you might get on 10 meters and you're like, wow, an hour later I still haven't stopped working the stations, a pile up. And so I just want to give some kind of tips. Most of you probably don't need this advice, but I'll give it anyway. I think the number one thing as a chaser is be polite. Realize like you're not the only person trying to work them, and sometimes you hear people's tempers going. And I hate to see SOTA devolve into what you see sometimes on DXpeditions, where you get the people whistling and yelling up and, you know, the band police, and the behavior sometimes gets a little ridiculous and it slows everybody down. And when you're an activator, you know you don't want to be slowed down because your battery is going to die eventually. It might be cold, you might have bears behind you or whatever. So you want to get the job done and work as many as you can. So one thing as a chaser you might do, let's say Kent is working on 14.062 megahertz. Well, maybe I want to tune to 14.0621 and send my call out, because that's going to make my tone sound slightly different than all of the people that are on 062. Maybe his brain will pick that out because it's different. It's just it's a technique. It's not my technique. I mean, everybody, all the serious DXers and people know that already, but it works. I'm going to probably get myself in trouble, but use higher power if you need to. If you're hearing somebody one by one, you know, 119 or something, maybe they're going to hear you 119, so maybe you need to bump it up to 100 watts. Obviously, good antennas, keep your antenna maintained. I'm having a problem in my mobile right now that I know is the coax, and during the snow season in Flagstaff, I must have got some water in the coax, so it's time for me to do a little maintenance and fix the coax. The snow season in Flagstaff, by the way, ended like 2 weeks ago, so it hasn't been that long, but I can tell there's something I need to fix, and that'll make things work better. And then, you know, don't throw out your call sign 5 times in a row. It's just not necessary. And then as an activator, you know, I said plan to spend more time on a single band. And what I mean by that is maybe when bands aren't so good, you can spend 5 minutes, and if nobody's getting back to you, you're going to move to another band. But if there's a pileup going on, you don't want to like work for 3 minutes and then say I'm going to change bands. So maybe, you know, maybe be willing to spend a little longer on a certain band. Obviously, if you're activating with other people, a lot of times you make an agreement like every 15 minutes we're going to change or something. There could be reasons. Always, you know, try to bring enough battery power. And this is, if you've ever known, there's times when I run out of battery power. It happens more than I want. So it's a problem that you need to be aware of and make sure you're showing up with the right power to get you through an activation. And when there's a pileup going, you're going to need more battery power than when it's not. Again, tuning slightly off frequency, but as an activator, you don't need to, you know, you don't need to tune to 14.0621. What you can do is tune to 14.062 and then use your receiver incremental, listen a little bit off. Learn the propagation patterns. You'll find that when there are pileups going, the best activators will keep them short, keep your exchange short. If you're 599, you don't really need to say 599 twice. That doesn't mean don't be friendly, though. Yeah, at the same time, we want to balance it. Like, this isn't a contest, and you know, if you see somebody you know, go ahead. It's fine to say their name or whatever. Some spotting programs truncate your frequency. This is, I use SOTA Goat, and I've noticed it truncates it. So if somebody's on 14.0605, my app might tell me it's 14.060. So as a chaser, I try to remember that and tune a little bit up and down if I don't hear somebody that I think I should hear. But as an activator, it might influence your choice of frequency because you potentially are going to have people miss you who don't know to check up and down. So I just want you to be aware of that. And if anybody has a solution for that, let me know. Obviously, you can't. If you go to SOTA Watch, you're going to see the exact frequency. Also, RBN oftentimes spots the wrong frequency by, you know, a kilohertz or something. And then, you know, just because your dial, and this is especially true if you're running like, say, a QMX or a kit-built radio, just because your dial says I'm on 7.033 doesn't mean that you're actually transmitting on 7.033. And if you have fancy equipment, you can test that and calibrate it, but most of us don't ever do that. And so it's not a bad idea sometimes if you feel like I'm calling and nobody's hearing me or everybody seems off frequency, try to understand where your radio really actually is transmitting. And that can help you as well, again, as getting cleaner signals on those pileups. Okay, so that's pretty much the end of my part of the slideshow here. And we still have the room for another 25 minutes or so. So I think the plan was Charlie and I are going to kind of just try to get some input from you guys as audience members. We can, do these reach very far?
We want to make sure, make sure you come up if you have a question or a comment, because we want to make sure that the stream gets that. So yeah.
I'm Kent, K9EZ. I'm one of the admins for the SOTA's Facebook page. I'd really encourage you all to join that if you can. There's a lot of great resources of people from all over the world that post their summits and their activations and radios and tips and the like. The other, of course, it closes just when I come up here. I've also put together a map of drive-up summits. So if you want to just check it out, if you're new or something like that, or if you just, for me, I did it because if I go to an area, I typically, that I'm visiting on business or something, I don't have a lot of time to do a major hike, but I can do a drive up and knock one out. So the URL for the SOTA drive up summits is tinyurl.com/SOTA drive up summits. Summit, not plural, summit. And that'll send you into Google Maps, and you will see all the different summits we've been able to identify as a drive-up. If you click on the little marker, it'll give you more information such as points, latitude and longitude, any other tips that you may need for that summit. And if you know of a summit that is not on there, please find me in QRZ, find my email address, and drop it into me so I can add it to the list. And thank you guys for doing this. Really appreciate it. tinyurl.com/SOTA drive up summit. That's all one word. Okay, thank you.
Yeah, any other, who's new to Summits on the Air? Like, just trying to learn a few things. If you have a question, we'd like to hear from you. If there's a few things maybe that you want clarification on, and I'll make a deal with you. If you don't want to come up and get the mic, I can repeat your question as long as I can hear it. But do any of the newbies, do any of those who are new to Summits on the Air, do you have a question for us? Okay, the question is, like Parks on the Air has a one-stop shop, what is the one-stop shop for Summits on the Air?
If we're talking about websites, I think the SOTA.org,
Yeah, just do a Google search for SOTA, and it'll bring the main URL. I mean, I don't think we give you the URL because it's so long, but he's going to bring it up here. But it's there. If you go to the main SOTA page, you'll have a menu, and it should be there. It should say shop. We don't have as much stuff as POTA, and it's all over in the UK. So
I don't know if I should do this. Yes, so SOTA.org.uk. The UK is because Summits on the Air got it started in the United Kingdom. This is just absolutely full of information, but it also has links, for example, right here in a little bit to the left, SOTA Watch, that's the spotting app that I mentioned. The database is where you can upload your logs or see other people's logs. By the way, if you're Parks on the Air, and correct me if I'm wrong because I haven't recently engaged, but in Parks on the Air, if an activator uploads their log, then you as a hunter get credit. In Summits on the Air, it's completely one-sided. So if you want chaser points, you have to upload your chaser log. If you want activator points, you upload your activator log. And of course, you can go and match them up to make sure you didn't misunderstand something, but they don't limit your points based on what somebody else is doing. It's all, each person has their own. And then, yeah, there's mapping. The other one I'll add is SOTL.AS. And the, whoops, what happened?
So did he show this shop? Where did he go to the shop then? Did he answer your question? Okay. Well, he's doing that. Any other new SOTA activators? Do you have a question? Okay. So if I understand the correct question is, do we do VHF, UHF in addition to HF contacts? Is that what it was? Okay, I'll answer that one. So when Summits on the Air was first created, over 20 years ago, it was only VHF, UHF, and to this day, most of us will do VHF, UHF in addition to HF. Most of us try to cover as much territory as possible, so we'll do VHF so we can get our local people, 40 so we can get those a little further out, and then 30, and then, so forth, so, yeah. Okay.
I might just add to that, that you will find that certain areas are very, very active on VHF and UHF. For example, if you go to Seattle, you're pretty much guaranteed to find people. If you come visit me in Flagstaff, you're probably not, you're going to be lucky if you log one contact on VHF, just because it's not part of that community. In Phoenix, you probably can easily find, as long as you know the frequency that you guys like to use in the Phoenix area. So it's very localized on whether it's going to work or not.
And let me just add another thing here real quick. And the other comment I would have is that unlike Parks on the Air, Summits on the Air, VHF is a very effective way to communicate and to make contacts. And you can really go a long distance. I have a 1296 radio, which is microwave, and I've gone 300 miles with that. And I've done a VHF contact from Arizona into San Diego. So, that's something you can't do with Parks on the Air. Is that what you're going to do? Yeah. Okay, we'll take one more new person question, and then we'll get some of your others, if there is another. Okay, yeah, go ahead. If your question is long, then come up to the mic. If it's short and I can repeat it, then just stay there. Come on. Yeah, come on up.
I'm somewhat confused about, what is the area that you can activate in. There's this thing about height, there's things about adjacent summits and such, and that confuses me, and something about the slopes, if there's something to the next summit. That is confusing to me.
Okay. Okay, two questions kind of on the same vein. I'll let Keith choose which one he wants to ask, but the first question is, describe the activation zone, the area where you can get credit for the points, and what that means. And then the second is there a place where you can see where the activation zone is and where it is? Yeah, the boundaries, right? The boundaries? Yeah, okay.
So maybe I'm going to go a little backwards on that. What I do is carry a GPS unit, and because the activation zone in most places is defined as you have to be within 25 meters of the summit. So, or that's approximately 80 feet, let's say. And so if you know the summit is X height, let's say it's 9,080 feet, and it's very hard to reach that top for some reason, or sometimes it's fenced off. Maybe you can't even go there. There's an observatory or radio tower. So they allow this zone, and that zone is based on vertical height, not on width. So there's a summit near the Grand Canyon where the activation zone is like a mile wide. It's crazy. And there's other places where the activation zone is like tiny. But without that GPS, I wouldn't know. Now, also in the SOTA Goat app on your phone, if you trust your phone's GPS enough, it will literally tell you if you're in the activation zone, as long as there's not big dips between you and the summit. That's usually fairly accurate. So there's multiple ways of knowing it, but in terms of looking it up online, if you're familiar with contour maps, and this what we have up here is SOTLess, you can zoom in, or you can pull up a summit, for example, and you can zoom in and get these contour lines so you can kind of picture where it might be. There are people that have written, I don't know, Charlie, do you know, I don't know specifically where to find it, but there's people that have written little apps that will kind of do a flood fill in on that, or even on Google Earth. And Paula, maybe you know.
So I mentioned the app where you can go to a website, caltopo.com. You can actually, when you create what are called geospatial PDFs, those are the real-time, see where you are PDFs. People usually use a phone app. You can use it on your tablet called Avenza, Alpha Victor Echo November Zulu Alpha. So what you can do when you create that map in Caltopo on the website is you can choose a color to shade the exact contours of that AZ. I tend to use light blue because it shows up really well against the topo maps that are the background, because those are usually some shade of green. And all you do is you go in Caltopo to a feature called, you go to add, and then you go to a feature called DEM shading. That's Delta Echo Mike shading. I forget what that really stands for. But you go there, and what you basically do is you say, here's the summit height, here's 80 feet less than that, and here's the color I want. Add this rule, save it, and now your map will show in the color you chose the exact contours of the activation zone. Because the map shows you real time where you are, as long as you have a GPS signal, as you walk, you can see when you enter and how far in you are with the activation zone. The one thing I would caution you about is we talk about 80 feet. We're rounding down. It's, I think 25 meters is just a hair over 82, but if you go 80, you're conservative. In the state of Michigan, and as far as I know, it's the only location in the US that does this, but if you go to the state of Michigan, your activation zone is defined by 40 vertical feet, not 80. Why? Don't know. They don't do that in Wisconsin, and the Wisconsin summits are pretty much the same height as a lot of the ones in Michigan, but it's a cautionary note to be sure to check the association rules if you're not sure, to make sure that you are defining the AZ correctly. Sure, sure. Yeah.
Okay, so the question, so thank you, Paula. Then there was a comment that was, can Paula put that information up and show how it's done? And then there was another comment that N7KOM, that's yeah, Tim in Pacific Northwest. He has already done it, and it's up there. So somewhere, I don't know where. Do you know where? On his YouTube channel, probably. Yes. Okay, and then so the short answer then is that no, there isn't a place you can easily go and just bring up a map that shows where all the they are. You got to do a little work. Okay, who was? Yeah.
Yeah, and I apologize. I'm a little hard of hearing, so.
David, at 6 a.m., did you click on the open box there?
Oh, yeah. Did they add that?
Yeah, it's
Down
there.
at the activation zone estimated.
Yep.
All right, at 6 ARA.
There you go.
Give you, now, it's not perfect, but it'll give you an estimation.
So what he's doing is he went into the drop down of a specific summit and selected what was it called?
Okay, thank you for, so it's running right now. Yes, thank you for pointing that out. So in SOTLS there, the activation zone estimator, and I don't know if it's going to time out, but it does a little, it has to go through some calculations, and now it pulls it up, and yes, that could be quite useful. So
Google Earth has an ability to do this also, but it's not always accurate. There was one summit in North Georgia that I'm told Google Earth will tell you the parking lot is in the AV. It is actually not.
Yeah. Bottom line is you've got to do your research a little bit and just don't go unless you're sure. Brad? Brad?
If you have an iPhone, the solution, if you have an iPhone, I can't explain why Android doesn't have it, is SOTA Goat. It's free. It's free. SOTA Goat. Here's the display. Brian and I use this all the time. I use it on every summit. It tells you your current elevation. It tells you how many feet you have to get higher to give you in the activation zone. It tells you vertical or horizontally the distance. It works without the internet because GPS can work without the internet. And then it lights up and says within activation zone. And it says on the top the summit and what the summit name is so that you have all of the SOTA designations. And if you swipe it from right to left, you can do a spot. It's awesome. So what do? I do a screenshot when I'm in every single activation area. And you've got proof that you're in the activation area. And right, like Keith said, it might be off by a couple feet. So just get a little bit closer because it, tells you if you're like 20 feet away. SOTA Goat, and it's free. Unbelievable. You don't think it's free? Is it? Oh, it might be $3, but it's cheap.
Thank you, Brad. What was I going to say now? I was going to add something very important. So important, I forgot.
For Pete, the two-element vertical beam, you remember that was a direct reflector. So better yet, the fault sign of the guy, so we can look up for some information on the two-element vertical beam.
He's asking about the two-element vertical beam.
Any information online?
Is it where can you find information on it?
It was published in QRP Quarterly probably around 2019. And so I'm sure there's an archive that we could find it, and I can go look that up and try to find it. Yeah, it was it's using really, thin gauge wire, very lightweight, not a lot to it. It was surprising and really creative design, and it worked well. I'll try to find it, and maybe this may be a good time to mention 1 o'clock tomorrow, and I foolishly put 1:30 on the SOTA reflector, so it is 1 o'clock, and I will correct that on the reflector. But if you're going to be there tomorrow, I'll bring you some more info on that.
A hand antenna is what they think it's called.
On the mobile rig you're talking about? Oh, it's not a commercial product. It was. Okay, so it is in the archive. Okay.
Okay, so any other questions? We're about done here, or questions or comments. So let me just add one thing about the zone. So just, you know, you have to do a little bit of work. Just the thing is it's on your honor. So, I mean, do the best you can and then go activate it, and it'll be fine. I mean, nobody's going to take your points away. Just go do it, and then if you find you made a mistake, that's okay. Just go on to the next one. It's not a big deal. We're on your honor. Yeah, come on up.
Hello, 1, 2. My name is Dave, NN5K. I live in New Mexico. I'm from Northwest Arizona. I'm a SOTA goat, like many people. But one thing I wanted to bring up is how much some of my thing is to go to very difficult peaks. Most of my peaks are unactivated, and I try to get there first. It's just my thing. It's what I like to do. To me, it's about the hike more than the points, and I do really rough stuff. For example, in Northwest Arizona, the county I grew up in, there's more peaks for SOTA in the database than there is in the whole state of New Mexico. And I've done a bunch of those, even though I don't live there. I live in New Mexico. But I've had several times where the few chasers that happened to work me really gave me the points on some very difficult peaks. So I really appreciate the chasers. And if you are a chaser and you have chased a lot of people, SOTA is about getting those people to work you. Otherwise, you don't get the credit for doing a 14-hour assault on a peak in nasty weather, having to run from lightning, all of those crazy things that I like to do. But I've gotten some feedback before that I'm too fast on CW from people and what I tried to give out to the community is I will get there, but if there's a pile up, I'm going to work all those faster people as fast as I can and be patient. When I get down to the end of the pile up, I'll slow down for you. Not everybody will do that, but a lot of those regular people that chase me, they're my priority, because if you go look in the database and you're a real active activator, it gives you the statistics of who your top chasers are. And on one event in a peak in Arizona, I was doing it in August, 110 plus degrees, and I did 4 or 5 peaks that day. I walked out to a really nasty peak, through a bunch of cactus, and to bring up the point about the solar thing, from one peak, an hour and a half later, go to another peak, CME. So I get up to the SOTA peak and I'm sending CQ and there's nothing. And one of my best chasers stayed with me from Phoenix, and I was on 40 meters and I was up near Kingman, Arizona. And all he sent to me was CME, and I could barely hear it. And I'm like, oh no, I don't want to come up here again and not get the points. But I stayed with it just on 40 meters, knowing what happened on the band. I could hear that it happened, and 4 people did. It took a long time to work me, and I just wanted to thank all the chasers that put up with those situations. Thank you.
Okay, thanks, everybody. We'll see you tomorrow, 1 o'clock, between buildings 2 and 3. Thank you. Let me look you in the eye.
Yeah, I couldn't figure out the math.
Well, that's great.
Happening now?
Yeah. I think so. Yeah. We have a few minutes. Go ahead.
I'm not gonna kill this one. So that's all. Is it broadcast this?
I don't. I have not seen. Speaking.
So if I have to do it, I'll do this. Otherwise, if I try to change the speakers, it doesn't, it only has those two. So the playback devices only. So it says there's a black magic device. I don't see it. Yeah, all we have is HDMI. So I'm gonna keep it like that though. Right. It's not very big to keep it all white.
if I see somebody that looks like their ID, Hamvention, I'll try. You never know. No, no, no. All set? Yep, there's a PowerPoint and an ODPO. Okay, great. So I don't even need my computer. You're gonna learn it. I think so. All right, that should work fine. All right. Converted it and I played it back fine. It worked fine on my computer. Good.
Good afternoon, everybody, and welcome to the Dayton Hamvention Antenna Forum. And happy Friday afternoon. I know it's a little warm in here. We're doing our best to get you cooled down. You can find previous Antenna Forum publications, the slide decks for about the last 20 years at k3lr.com. Just click on Dayton Presentations. And I'm always looking for future presentations. Just send me an email, k3lr@k3lr.com, and I would love to hear what you'd like to see next year. We have 4 great presentations today. They are each about 45 minutes in length. And the presentations are from W5ZN, K2TR, W8WWV, and WX6SWW. And so I think you're going to find it to be an entertaining and enriching 3 hours. Our first talk today is comparison of vertical arrays for low band receiving. Please welcome Joel Harrison, W5ZN.
Thank you very much, Tim. Good afternoon to everyone, and thanks for being here this afternoon. As Tim said, I'm going to be speaking about comparison of short vertical arrays for low band receiving. I have about 40 to 45 slides, so I'll be moving through those as efficiently as possible. Let me see if I can get there we go. So I would encourage you to go to my website and download, if you haven't already, a rather extensive paper I have on this topic that this presentation is based on. And what we want to try to cover today is just a little bit about low band propagation, because there's no way you can start comparing antennas until you understand propagation on the band that you're dealing with. I'm going to tell you a little bit about my experience with vertical arrays. Then we're going to talk about the differences in vertical arrays and an approach to comparing low band receive antennas. A little bit about what test equipment that I used and the calibration, then the data collection and the results. So geographical differences, it matters when you're comparing antennas. So if I'm sitting here trying to compare an antenna to someone that lives over 1,000 miles away on the East Coast to where I live in Arkansas, you're not going to have an accurate comparison. And even sometimes the exact same antenna is going to perform different in 2 locations. Frank, W3LPL, and I both have one of these vertical arrays that I'm talking about, and they're pretty much identical. And the geographical differences really, there's difference in the performance. So closer to home, within about 450-mile radius of where I live, I have 3 stations that I like to compare signals to. One of them is my good friend Dave, W0FLS up in Iowa. My other buddy Dave down in Texas, W5UN. And then Larry, K5RK, who's also down in South Texas. And the propagation differences that we see on 160 meters a lot of times is significant. Now, even closer to home where I live, I have 3 good friends of mine, K5UR, WD5R, and K5EJ. They're both about 20-25 miles from where I live. And sometimes when we're listening to signals on 160 meters, what we see in differences between signal to noise ratios and signal strength is just sometimes really eye-opening. So 160 meter propagation is really beyond the scope of what we're going to talk about today, but you need to understand it. So I want to encourage you to read all of the information that Carl, K9LA, and Frank, W3LPL, have published on propagation. There's a link here to Carl's website, which is in the presentation, and Frank's information is kind of like Santa Claus. It's out there everywhere, all right? So several years ago, when I really became serious about 160 meters, I started experimenting with beverages and loops, and these all worked well, but I sort of have this, I don't know, it's an obsessive addiction, I guess you would call it, that I want to be able to hear better. So back in about 2008, my good friend Bob McGuire, N4HY, told me about this vertical array that he had done a lot of extensive research on and was interested in putting it on the air. So I said, hey, I'm going to build one. So I did. And its performance really exceeded what I had seen on beverages and loops. And then after I had this array out for a couple of years, Lee, K7TJR, with high Z antennas, was producing this high Z-8 array. And a few people had those and really had some good results. So I was like, gotta get one, gotta try it, gotta have it. So I did, and I installed it and was very pleased with those results. We're not too long after that, John, W1FZ, came out with this 9 vertical array. And of course, again, being having an obsessive addiction. I'm like, I gotta have one, gotta get it. So I actually wound up with 3 of these vertical arrays that I was trying. Now, there's differences in these vertical arrays, and it's very, very important that they be understood. And here's a good example. A few years ago at the top band dinner in Dayton, I'm seated at a table, and a ham said, hey, I'm putting up one of these 8 circle arrays. And I said, great, which one? He said, the one with 9 verticals. So I'm like, something's wrong with that math. So we're going to discuss today what are the 3 most popular vertical arrays that are put in a circle so that you can achieve 8 receive directions from those. So the first one we're going to talk about is referred to as a broadside in-fire array, or a BSEF array. Now it uses 8 verticals in a 350-foot diameter circle. That's pretty large. But for any one direction, you are only using 4 of those verticals, simply because it is a pair of in-fire verticals. So as you switch around to the 8 directions, you're switching which set of 4 that you're using. Now this is a low impedance system. The input to each of those verticals is 75 ohms. There's no amplifier or anything else that's really required at the base of the vertical, with the exception of a little matching to match the vertical to a very beam width of about 58 degrees. And it has a front to back from the modeling data of about, I don't know, about 25 dB. This is the easy neck pattern here. So then the high Z array that I talked about that K7TJR designed is an 8 vertical array in a circle. It's a 200-foot diameter circle for 160 meters. And the difference in this design is, number one, it's a high impedance system, so it actually has a little high impedance amplifier at the base of each of the vertical elements. But it uses all 8 elements. Regardless of the direction that you're interested in, all 8 elements are active. They're just phased differently, as shown here on the left. This has a very, very excellent pattern. It has the same about 58 degree 3 dB beam width, but has a very excellent front to back of about, I don't know, about 25 to 30 dB. So then we have the YCCC9, the one that John designed. And again, this uses 9 verticals, but there are 8 verticals in a circle. The circle diameter is about 120 feet. But then you have 1 vertical that is in the center. And the reason is, for any one direction, you're using 3 of the verticals in one specific direction. All right? So as you switch around, the center vertical is always active, and then you're just selecting which of the other 2 as you go around the azimuth that you're using. This has a much broader beam width, about 75 degrees for the 3D beam width, which is understood, right? Because it's an in-fire array, basically. It's not a broadside array. But it has about, because there's 3 verticals in line, you can get some really impressive front-to-back rejection from this, sometimes 25 to 30 dB. All right, so we have to talk a little bit about the beverage antenna. Now, everyone has heard of the beverage antenna. It's been around forever. It was introduced back in about 1921, and it rightfully has become the standard that we compare all low-band antenna receive antennas to. There have been a lot of books that have been published on it. Vic Misick published the Beverage Antenna Handbook several years ago, back in about 1977. Unfortunately, and that had a lot of really great information in it. It was the first real publication that had some good information for radio amateurs. But that's no longer in publication, but a lot of the information that was contained in the Beverage Handbook has been captured in low-band DXing and has been expanded upon. So that has now, low-band DXing by John DeVolder has become the really go-to source for beverage antenna work. But there's another reference that is very, very important to note here. And it's some work by Greg Orty, W8WWV, and Greg's sitting right over here, and he's going to be presenting here a little bit later. Greg has done an extensive amount of work on beverages in recording simulation and modeling and simulation data, and some on-the-air performance for beverages of different lengths, different designs, different heights. And I have the link here on the screen for his website. But one of the things that I really, really like about Greg's work is he has quite a profound statement that says, for me, the beverage represents a yardstick which can be used to compare the performance of other received antennas. That is so very true. And actually, in my work that I have performed in every comparison that I make, I have 580-foot beverages that I use, single wire beverages, and I include those in all of my comparative results. All right, so this is my test range that I have in Arkansas. Now, I'm very fortunate that I have 30 acres, so I've got a lot of room that I can use to put antennas out in various locations. All right, you can see up in the upper right part of the screen, you know, I have the YCCC 9 antenna that's located about 500 feet northeast of the shack. The high Z8 is setting out there to the right. It's about 850 feet out to the center of that array. And then the broadside end-fire array is south, and it's about 800 feet or so south of the shack. Now, I try to keep these separated from my transmit antenna. I have a big gain transmit antenna. It's a 5-element parasitic array that K3LR has popularized, and it's setting over there on the far left of the screen is where that sets. Then I have the 4 beverages that are laid out northeast, southeast, west, and northwest that you can see on the screen. So this is how I lay everything out, where they are, and how I arrange things for my test. So the parameters that I have used for my comparison is the first thing I did was I compared modeling and simulation results. And then I collected empirical data because I wanted real on-the-air data to see how that compares to the modeling and simulation. And then documented any differences that we might see from that data. And then actually analyze that and say, well, really on day-to-day operation, is there anything that I can really tell a difference in these? So here's the test equipment that I used for these tests. I had 2 K3 transceivers. I had 2 LP PAN software IQ PAN adapters, and 2 NAP3 PAN adapter displays running on 2 separate computers. This allowed me to look at 2 separate antennas at exactly the same time and record the signal data. Now, also in order to do this, I have a K9AY RAS8 antenna switch, and this has 2 outputs on it, and it allows me to use 2 receivers at the same time, and I can switch real quick between those 2, or actually put 2 antennas, you know, on each radio at the same time. You have to calibrate this test equipment as well. You can't just throw things out there and assume everything is working all right. What I use for calibration, and you know, you need one of these. I don't have any commercial connection with Elecraft, but if you don't have a Elecraft XG3 signal source, you need to buy one because they're invaluable, all right? So you want to calibrate the equipment to make sure any known variable is removed from the system, or at least that you document it, all right? And so prior to the start of each of the measurements, I would inject a -73 dBm signal, all right, into the cable, my signal cable at the far end where the receive antenna was, and to verify the loss in the cable and my calibration that I have in the system. So these arrays, you know, you get out to the center of the array and it's about 800 feet out there. I'm using RG11 for my signal cable. That's 75 ohm cable. That's the impedance that I'm using for my receive antennas. RG11, I'm sure everyone's familiar with it. That's really the 75 ohm version of RG8, all right? So on 1.825 megahertz, through that 800 feet of cable, I measure 2 dB of loss. That's fine, that's very acceptable, and I verify that daily. So when I come into the shack, prior to the radios, I have those 2 outputs on the RAS8, right? So that's going to give me some other attenuation. I have 2.5 dB of loss that I've measured there. So when I actually get to the radio, to the PAN adapter, my minus 73 dBm signal that was injected far out at the antenna is actually, shows 4 dB of loss, how about 4.5? It's minus 77.5 dB on the pen adapter screen. And I verify this anytime before I start taking measurements, all right? And then starting to proceed. So, there's a number of things that you need to record when you're doing signal comparisons, okay? And you need to document this data in 8 directions or however many directions maybe you want to compare your antennas in. I'm comparing in 8 directions. I'm going to record the noise floor level in each of the 8 directions. I'm going to record the forward peak of the signal. I'm going to record front to back data and front to side data. Now, for these measurements, all right, you don't even think about doing this with an S meter on your radio. You're not going to get accurate results, all right? So I was able to use these pen adapter displays that I have. I could calibrate those in 1 dB to 1 dB resolution, all right? And I could really measure some accurate results. All of my measurements were recorded in CW mode with a 400 hertz bandwidth. So I recorded data on 160 meters over a 10-year period with all of these arrays. And I recorded about 100 DX stations to collect this data. Now, a few of these 100 stations were the same, but they were, the signal information that I recorded was from a different part of the day, a different part of the solar cycle, or a different time of the year. So I felt like that was a good comparison to make over time. And also, a lot of these DX stations that I was recording were really too weak to be able to acquire any meaningful front-to-back ratio, or front-to-back rejection or front-to-side rejection. So in order to collect data for that, I used about 30 stations in the United States to do that. Now, that's doing so with the understanding that I'm going to have, you know, different arrival angles or different conditions from stations that are local within the country. But regardless, the results from those stations are very accurate. So when you start recording your noise floor for each array, you have to take into consideration whether it's an active or a passive system. And any preamplifiers that you place in the system will affect the noise floor of the array. And so I did this in each of the 8 directions for each of the arrays. Quite often, really nearly daily, I would record the noise floor and make sure nothing had changed. If something had changed, I obviously need to track it down and see what's going on. So for the 2 8 vertical arrays, the high Z and the BSEF, the noise floor in the shack through my long cable and through the switch averaged around a minus 120 dBm. That's pretty good. That gives me sufficient gain from the array and gives me a good baseline to record signals. All right. Now, the output of the YCCC9 is low, so I do have a preamp on the output of it, which is recommended in the design. But for that, through its 500 feet of feed line, I have a minus 125 dBm noise floor. Now, of course, that's 5 dB less than the other arrays, but I'm recording signals based on the noise floor, and this is very adequate for comparative measurements. The 4 beverages that I have a very good signal from those in noise floor without any amplification, and I have a minus 125 dBm noise floor there. So I will just mention that, you know, I've spent a lot of time working with my local electric utility, and I'm fortunate enough to have an electric utility that'll work with me to try to get rid of line noise. And I've been very successful with that. What's out of my control and will be out of your control are noise sources from consumer devices from neighbors' houses. You can control what's in your house, but it's very difficult to control what's coming from a neighboring house. And in my paper, I talk about a particularly egregious situation that I dealt with for a few years to the east from a neighbor's house. So, the forward peak signal amplitude that I'm recording for this is very simple. The peak signal in the direct path to the originating station. Now, that could vary a little bit. There were a few times where the peak signal was not from the direct path. It was from a skewed path or along the gray line. So whatever signal provided, whatever path provided the best signal, that's what we used. And of course, we're recording the signal level in dBm, reference to the noise floor. So with my minus 120 dBm noise floor, if I had a signal, or if I had like a minus 120 dBm signal and the noise floor was minus 125 dBm, that signal was recorded as 5 dB above the noise floor. This is just a quick list of some of the stations that I recorded data from. They were all over the world, from ASH 3V8SF in Tunisia, all the way to Eddy XV1X in Vietnam. And there was just, like I say, almost 100 stations that I recorded data from. So let's take a look at some of the results that I had. The forward peak results revealed that the high Z-8 array, and remember that's our array that is a high impedance system, uses all 8 antennas verticals, all right? It provided a 1 to 2 dB increase over the broadside end-fire array on some signals, because there were other times I could be looking at a signal and recording data and it would be just the opposite. Or if I was sitting there looking at some signals over time, that could change. If it started out being stronger on the high Z-8, after a while, the signal may be stronger on the broadside end-fire array. The forward peak signals received from the YCCC9 were consistently 2 to 3 dB lower than any of the 8 vertical arrays. And just by comparison, again, we're using that 580-foot beverage as our benchmark beverage that we can kind of use for the comparison. So on the 580-foot beverage antennas, those signals were consistently about 3 dB lower than the BSEF or the high Z 8 vertical array. And it was equivalent to sometimes just a little bit lower than the YCCC9. Now, one interesting point that I did record as well, and I don't know why, I don't have any explanation for this, but there were times when a signal would fade down into the noise, but it would come back up out of the noise sooner on the vertical arrays than it would on the beverage. And it really had nothing to do specifically with signal, with the signal level, because sometimes the signal level would come back out of the noise at a high enough level it should have been there on the beverages. So I charted out a simple line graph here just to show some of the comparisons of the signals. Now, the top 2 signals up at the top, the high peaks, are from the 2 8 vertical arrays. And you can see that they were close to each other over the entire test. There were times when they would move back and forth. And then the lower 2 lines, the YCCC9 and the beverages. So very equivalent here of those. All right, so let's talk about some front to back and front to side comparisons. Again, the high Z-8 had a solid 25 to 30 dB front to back repeatedly when we were comparing multiple signals. The BSEF array had a front to back on the signals that we measured 20 to 25 dB. Now, the YCCC has a very impressive front to back of 25 to 30 dB that's equivalent and right in line with the high Z. But we expected that because, right, there's 3 elements. It's a end-fire array with 3 elements. So you would expect a much larger front to back than you would on the broadside end-fire array. But again, you didn't have much front to side rejection because you have a broader forward pattern. The 580-foot beverages that I was using, I could get around 20 dB front to back and a front to side that was sort of equivalent with the YCCC9. So once I had all of this data that I had collected off the air, I started trying to compare that to modeling data. And again, if you've read anything about receive antennas, you've heard the phrase RDF, receive directivity factor, all right? And that's really become the standard for evaluating low-band antennas, and it basically takes the forward gain at any one desired location and takeoff angle, and it compares it to the average gain over the rest of the hemisphere around the antenna. Some of the early work to develop this was done by Bill Hoinstein, K0HA, and in the paper that I have, there's a lot of links that you can go back to the top band reflector and look at some of the early work that he did. So when you start looking at RDF, you know, most noise sources are going to have a direct azimuth location, but they can also be present over a wide range of surrounding areas, and you're not going to get maximum rejection off the side or the back unless it's right in the null. So that's when looking at RDF really becomes very important. So you also need to consider when you're looking at front to back and front to side data, you know, the arrival angle of the desired signal, of any undesired signals, the characteristics of noise that you have, and then, you know, any inefficiency in the construction of your array is going to come into play as well. So we took all of this data and applied it to three-dimensional plots from 4 NEC. So these are the 4 plots here. If you look in the upper left, this is the plot for the 580-foot beverages. Actually, this is for a 600-foot beverage, and it's right in line. Front to back showed it to be about 20 dB and have a 3 dB forward bandwidth of about 75 degrees. And that's right in line with what we confirmed with the online data. Now, I have RDF numbers here, and the RDF numbers that you see are what the modeling and simulation data presented. And I have a note here that I confirmed these, and how I confirmed them was actually based on comparative signal analysis over the 8 directions, all right? There's no way you're going to be able to very, very accurately do that. However, you can take the data you have recorded, and you can look at that and say, yes, my data matches what the modeling and simulation data should show. So if you go over to the upper right, this is the YCCC9. And you can see that it doesn't really have those large lobes like the beverage shows. And front to back of about 20 dB from the modeling data. We actually saw better than that with the on-air tests. And then a 3 dB beam width of 75 degrees and an RDF of 12.1. So before I get to the BSEF, because that takes a little bit of explaining, I want to go down to the lower right where we have the high Z-8. And you can look at all 4 of these patterns, and it's quite obvious that the high Z-8 has the smallest, cleanest pattern of any of these. And the modeling data suggests a 30 dB front to back ratio, 3 dB beam width of about 50 degrees, and an RDF of almost 13.5 dB. And that is clearly what we show with the empirical data that we collected. It's a very, very nice array. So let's look at the lower left. When I saw this 3D model, I was like, what the hell's going on here? This looks really bad, all right? And it really didn't seem to jive with what we were seeing from the on-the-air data. So this really threw me for a loop, and I had to do a lot of really researching to try to understand it. And I came up with an explanation, okay? And what I concluded was, if you look at the easy neck elevation plot just to the right, you have a very high lobe that's up there at about, I don't know, 60 degrees maybe. And then it sort of rolls off, and then you have another one closer to the lower part of the ground. I believe when you're doing the 3D modeling of this, that it shows the result of that higher lobe at about 60 degrees protruding off the back. And that's why you get sort of a distorted, if you will, pattern off the back. But even so, with that, And even though it shows a front to back of 21 dB, you know, we saw on most of the signals better than that. But again, that's going to depend on where that signal is arriving off the back of the antenna. 3 dB beam width is very good, about 50 degrees. And the RDF that we could confirm by comparative results was about 12.5 dB. So, when I was doing all of this work, I had some people ask me, well, what about DX contest performance? How does it work? Well, I did not collect data during a contest, and there's a very, very important reason. My focus during a contest is to make cues and get multipliers and not sit there and document signal strength. But I can tell you that each one of these arrays has outstanding performance in contest. Now, Frank has, as I mentioned, Frank has one of these broadside in-fire arrays, and they work very, very well. But there's one thing you need to pay particular attention to when you're using an array like this in a contest. If you have areas such as Europe and South America and a big part of the United States that happen to fall in darkness at the same time, you're not going to hear weak signals, or sometimes maybe a moderately strong signal off the back of that antenna. Right, Frank? Frank's shaking his head, and we talked about this, and you're going to miss them. So you kind of need to be aware of that when you're in a contest, all right? Frequency stolen, that's right. All of a sudden you turn, look a different direction, and there's some guy calling CQ, right? Well, I go, what the hell? All right, so let's talk about our summary here, right? Phased receiving arrays, phased receiving arrays of short verticals do provide superior performance over low noise receiving and other low noise receiving antennas for 160 meters, including beverages and loops, all right? But you need to understand, the receiving antenna that's going to be right for your location is going to depend on a lot of factors. How much room you have, obviously, all right? And what's surrounding and what you can do. So you have to take that under consideration. But the empirical results from the HiZ8160 that's in a 200-foot diameter, all right, consistently was the top performing antenna that I've recorded data from, all right? It produces the best overall pattern, that's sharp and clean. And if I'm just using one receive antenna, that's the antenna that I use. Now, the broadside in-fire array, and again, it's in a 350-foot diameter circle, so it takes up a large area. It's a very, very close second to the HiZ-8. The forward signal levels are really comparable, but you suffer a little bit in front to back and front to side, okay? But regardless of that, this is an extremely top-performing antenna. Now, the YCCC9 in a 120-foot diameter circle, really, this provides some really amazing results. You know, even though we could really get some very deep nulls compared, that was in line and similar with the HiZ-8, you know, the forward signal levels aren't quite as strong, but if you look at the space that's required for this antenna, you know, it is quite, it's just an amazing type antenna. And here's another thing about it. If you construct it with the correct delay lines that are identified in the construction, design and construction, you can also use this on 80 meters and 40 meters with outstanding performance. And you only need 120 feet in one line. So if you have only one direction that you want to focus in and you don't have a lot of room, let's say toward Europe, and you have 120 feet, this antenna will perform the same as a 580-foot long beverage and only take up 20% of the required space. And this is a phenomenal performer on 80 meters. It really is. Excellent on 160, phenomenal on 80. All right, so just some final thoughts here. The array that's best suited for your location, you're going to have to assess that and, you know, the area that's required, what challenges you have. But on 160 meters, and again, I'm pretty fortunate to have a lot of room. If I'm trying to work a DX station and it's marginal conditions, I use the high Z-8 and the broadside in-fire array in diversity receive. And I have to tell you, that is an absolute amazing result. So, the tests here that I performed, they're simple tests, but they're accurate, okay? And I know we've had a lot of technological advances since I started recording this data in software and hardware components in recent years, and there's a lot of new things that you could use to record signal levels and so forth. And a lot of those are being evaluated right now by industry professionals and radio amateurs. So what I'm hoping is that going forward, that we can build on this work. And, you know, I also hope that maybe it will inspire some of you folks to get out here and try to do some evaluations as well. And again, please download the paper. It goes into a lot more detail, and it has more information in there that I could really put into a presentation here. So if you haven't done that, I would encourage you to do it. And that's all I have, Tim. Thank you very much. You can take that. All right. Thank you.
Our next topic is wideband wire antennas by Fred Lass, K2TR. Hello, Fred.
Thank you, Tim. You know, it's interesting to be up here, and thank you very much, Tim, for inviting me today. It's an honor to be here. This is the second time I presented at an antenna forum at the Dayton Hamvention, now the Xena Hamvention, and the last time was 50 years ago. Thank you. So a little story, it's how I learned about SWR. Started when I was taking my novice courses and took some of the, took an excursion to a ham who was a contester in the RTTY business. This was in 1964. And I think I'm going to turn this up just a little bit if I can. There we go. So the guy who's teaching me the theory basically says, okay, when you have an impedance bump in a transmission line, some of the signal gets transmitted back to the transmitter. And oh, by the way, it excites the output circuit and that turns it back down and goes up to the antenna anyway, but a little bit more of it is lost, in other words. I said, okay, that makes sense. And then we went to the field trip to the guy that made his own kilowatts and was a broadcast engineer. And he said, don't ever use a barrel in your RG8 because if you do, all the signal that is reflected back is totally lost. So I said to myself, okay, this is interesting. I have a guy whose theory makes sense and I have a guy who's got experience and the two of them don't agree. So this is going to be interesting. So I thought of it myself and I said, okay, which one is right? Well, obviously, the guy that said it in theory is correct, and the guy who's experienced didn't actually make any measurements. He just thought it was the case. And later on, I had some other experiences about SWR. My first job out of RPI was I worked for Sylvania, and Sylvania was building radios that went into the helicopters, and they had a problem with their UHF module because the UHF module would suffer transistor failures in high SWR. So, why is that? And, I was helping to work on the
the test procedures for it. I wasn't the design engineer. The design engineer was Gil Bulkey, W2EUP, who's been dead for years now. But many of you people, anybody that's been familiar with 2-meter FM knows that he was the guy that built the first frequency synthesizer. And these radios were fantastic. They were the size of the Collins control panel, and it was the entire radio. And the solid state, 220 to 400 megahertz, 10 watts of AM. It had 5 transistors in parallel. The collectors were actually connected together in a pentagon. The problem was that when the people in Vietnam would hose off all of the crud from their helicopters, they would cause water to get in the antenna. The SWR would go up, and the instantaneous voltage on the collectors would go so high that the transistors would fail. Does that sound familiar to what's happening today in the ham radio world with solid state amplifiers? It's exactly the same thing that's happening. So there's something I was working on then, and the solution back then was the same as the solution now. Put a hot carrier diode on the collector, measure the instantaneous voltage, and if it goes to anything higher than twice the collector voltage, your transistor will fail, and you must eliminate the drive to that as quickly as you possibly can. My next experience with SWR is that when I got into the TV business, I was primarily a studio person. And at one point, my boss, who was taking care of the transmitter, says, we have a nitrogen leak on the antenna. I'm going to get the antenna crew to come in, and I'm going to have them fix the nitrogen leak. Okay, no problem. I want you to come up there. Okay, I can do that. So the guy fixed the nitrogen leak, and he put the antenna back together and turned the power back on in the TV transmitter, and the SWR is 1.3 to 1. And the TV didn't like that. Why not? Because that signal comes down back into the transmitter. Just like I learned from my guy in the novice, the signal goes back up to the antenna. There's only one thing wrong. In a TV, time matters. And there was a transmitted ghost because the signal that was transmitted back to the antenna arrived later. And the tower climbing, the rigger that did the repair says, I put it together exactly the way I took it apart. It's not my problem. He's going to leave. And of course, my boss knows that this isn't right, and it's time to fix it. So the rigger says, I'm leaving. So he takes his rigging off the tower, and he drops his 40-pound block that he's got his cable on, and he dents the feed line. And he happens to dent the feed line in exactly the right spot at exactly the right amount to cause the SWR to go down to 1.05 to 1. And he said, no, the problem wasn't there. Problem wasn't on the antenna. Problem was down here. Of course, if you look at the picture monitor, there's still a ghost there. But the ghost, which used to be about an inch to the right, is now 7/8 of an inch to the right, because now that reflection is going back from the dent, not from the output of the transmitter. So all of a sudden, SWR is an interesting thing that you have to deal with. TV signals always want to see a 1.4 to 1 SWR or lower if you can. So with all of this information in the background, let's look just a little bit at how to match a dipole. I had my graph up there before. Everybody knows that graph. You've probably seen it in the handbook when you were 12 years old, didn't know what it meant. But it basically means that your antenna height changes the impedance of your antenna. And if it's very close to the ground, it's 50 ohms, mostly because all of it goes into the ground. It's ground losses. The whole concept of an NVIS antenna, it has great SWR, but it has a lousy radiation pattern. And what you want to do is you want to get your antenna up to the point where there is no ground losses, and that occurs at roughly 1/3 of a wavelength. But 1/3 of a wavelength is only like 23 feet on 40 meters, and most people know that 23 feet is too low to the ground to be effective on 40 meters. So you have to put it higher. But as soon as you put it higher than that, it's no longer a 50 ohm antenna. And a lot of people say, well, just cut it to as close as you can and use it like that. Well, that's what everybody did for the last, 20 years or so. But you don't have to do that anymore. You can match that very easily by off-center feeding the antenna. So instead of feeding the antenna at the center point, which is maybe at that point maybe 60 or 70 ohms, what you do is you feed it maybe only at around 35% off, but now the impedance isn't 50 anymore, it's about closer to 100. So what you do is you say, oh, I can transform 100 ohms back to 50 ohms using 75 ohm coax. And everybody knows that a quarter wavelength of coax is transforms from 50 ohms to 100 ohms. Well, it doesn't really. It transforms from 112 to 50 because we're doing it backwards. About 112.5, but you can use EasyNet to tell you exactly where to connect that antenna. And this is something I've done effectively for field day antennas. And a lot of people told me, well, you know, as soon as you off-center feed a dipole like that, you're going to need a big balun because you're going to have an offset pattern, and the pattern's going to screw up. Well, I put it in EasyNet, and the pattern's off by maybe 1/10 to 2/10 of a dB in terms of how much rejection you get. And I built this antenna, a coax, used that at field day, fed it with RG6, nice cheap coax, good low loss stuff, nice and light. And it should have a balun on it. I did it without a balun. Doesn't cause any problems without a balun. Works very well, made a lot of contacts. And if you do want to use a balun, I want to encourage you to use a Guanella balun. And I want to start off by saying this, is that there's a lot of controversy in baluns, and I'm going to tell you what my opinion is that a lot of people call them chokes. A choke implies that it's an inductance, and it could be, but it's better if it's not. A Guanella balun is specifically designed to equalize the currents in a balanced line. So you run the balanced line around the toroid, and if there's more current in one than the other, it creates a magnetic field in the toroid that then enhances the signal in the other one to equal the one that was stronger to start with. So it becomes inherently balanced. Or you can think of it as a transformer where it's pushing current from the stronger signal into the weaker side until they're exactly the same. And that is how a Guanella balun works. And that's the difference between a current balun and a voltage balun. And it's interesting because there are people who make these things and they think they're making a Guanella balun, but sometimes they're not. So as soon as you take coax and you wrap it around a toroid, have you made a balun? Absolutely not. You've made an inductor because the field from the center conductor is never ever seen by the toroid. So then if that's what you want to do, that's fine and dandy. W1JR, Joe Reiser tells you how to fix that. You wind the coax one direction for some turns, and then you wind it the opposite some more. Now all of a sudden the current on the outside is nulling itself, and the current on the inside just keeps going as if there's no toroid in the circuit. So when it's time to start working on this antenna, and you want to know exactly where to use it, don't just automatically assume that you want to put it at the 112 ohm point and assume that it's going to work. You can actually model it. And what you do is you use the transmission line formulas in EasyNet to do the hyperbolic trigonometry functions for you. Anybody remember those formulas? You know, I learned them in high school, said, what am I going to use with these things? And well, all of a sudden I'm in transmission line theory, and there they are. And a lot of people try to make it easy by using Smith charts. That just, to me, it just makes it harder. And I got to understand two things that don't make any sense. But I'm just joking. I have done the math once or twice and said, well, with EasyNet, I don't have to. The way I do it in EasyNet is I will, put my dipole up, and then enter another dipole, maybe a foot off the ground, one segment long, as short as it will let me put it for the diameter wire that I have. And then I set the input of a transmission line to be the feed point of the antenna, have the transmission line end in this short piece of coax that I put, not coax, I mean the short line near the base of the tower, and then connect the feed point to that short piece, let it calculate it, and it tells me exactly what comes out. And if it doesn't end up with exactly what I want, then I can move the feed point one way or another until it works perfectly. And I do that for field day antennas, and it works real well. So we're going to start with looking at a 40-meter antenna because you can understand some of the concepts looking at a 40-meter antenna, and then we're going to transfer some of that knowledge to 80 because 80 is the real challenge that we need to deal with. So this is where our starting point is, a 40-meter dipole, 23 feet. You match it at the center of the band, and it's less than 2 to 1 across the band. And, do you want to operate at 2 to 1? Well, I find that if I have an amplifier that doesn't have a tuner in it that follows my frequency, or if I want to switch between antennas, you know, I want it as close to 1-to-1 as I possibly can. So, and I'm often making this kind of an antenna for field day, and the people in field day don't know how to tune the antenna on rigs that they haven't normally used. And if you tune it up for the sideband portion, it's wrong for CW and vice versa. So this is not an adequate solution to me, but it does tell you what our starting point is. And this is what it looks like if you offset feed it. All of a sudden, what have I got? I've got 1.3-to-1 at the bottom of the CW band, 1.5-to-1 at the top of the band. Is it because I offset fed it? No, it just happens to have a better SWR curve when it's higher off the ground. Now let's take this a step farther. The bandwidth of a dipole is limited by the diameter of the wire used. And if you go back years and years and years and years in the handbook, they talk about cage antennas. They show these wires and big spreaders. I'm a TV guy. What do they do for UHF TV receive antennas? They use a bow tie. Well, if you analyze a bow tie and easy neck, you'll find out that if you make a bow tie and you make every single whisker of a bow tie exactly the same length, and you spread them a certain distance apart, you can get a nice little pattern. And the easy neck says the best distance between the two wires of a 40-meter bow tie is 5 feet. Those wires end up being shorter by about 5 feet, roughly. And the following design, I used it at HQ9X last year in CQ Worldwide Phone. And again, here we're dealing with an antenna which is 1.3-to-1 all the way up to about 7.29. It's a really, really, really nice way to get a low SWR in 40 meters relatively simply. And everybody says a delta loop is a nice broadband antenna. Well, it's about the same as the bow tie. And if you happen to want a slightly lower angle, nothing wrong with a delta loop, but it's not a magic antenna when it comes to SWR improvement. Now, there's another thing that happens when you stack antennas is that the SWR curve gets better as you start putting antennas together. So this is basically two separate dipoles from one supporting tower. They're about 60 foot high in the center, and they're slightly fed off center, and it's got some matching transformers in it. But you get some gain, and this gain can be helpful, maybe only a dB to a dB and a half gain. And if you take this pattern, you say, okay, we call this in the TV business, they call that a peanut pattern. Kind of looks like a peanut. And you say, okay, I want that area where no power is going, I want one of it to be, I want it to go into none of it, because I don't want to put any power in none of it. Put the other direction aimed at the Bermuda Triangle. I don't want to waste any power in the Bermuda Triangle. Now all of a sudden you're a dB and a half stronger than anybody else on the band who hasn't done this. So, and your SWR curve is now down to 1.2-to-1 across the band, just because two antennas added together always gets better. Now W7ZZ came up with an interesting way to feed an antenna. You know, OWA Yankees have a first director that's very, very close to the driven element, and it gives you a very, very nice SWR curve. The problem is that on 40 meters, and the impedance of the antenna is too high to start with, and you can't make it lower with an OWA wire, you can only make it higher. So you make it higher by, you put your wire on there and you say, okay, now I can use that same 75 ohm transformer trick, but now I can feed the antenna in the center with 75 ohm coax, 3/4 of a wavelength, 1/4 of a wavelength, depending on how it is. And now all of a sudden you have this curve, which is 1.1-to-1 up to about 70. Very, very, very nice curve. Now I'm going to dig into a very interesting thing. The people that worked on radar in World War II knew how to make a broadband dipole. And they were not necessarily electrical engineers. They were physics majors. And they were using RF energy at microwave frequencies in order to run their cyclotrons and linear accelerators. Well, these mathematicians knew how to do things in math, and they knew the formulas for transmission lines. And they used that knowledge to say, okay, what if we took a half a wavelength of coax? It's a lower impedance than the antenna. And at the low end of the band, it's less than a half a wavelength long, and at the high end of the band, it's more than a half a wavelength long. And oh, by the way that the transmission line theory works, it counteracts the reactance of the antenna in the exact opposite way the antenna is. So when you put that half a wavelength of coax in there, it has to be a lower impedance than the antenna you're feeding. And then you have to bring it back up to 50 ohms. And this is what a dipole looks like if it's fed at the 37.5% point with a half a wavelength of 21.4 ohms. Why 21.4 ohms? Well, it happens to be one piece of RG8 and two pieces of RG6 put in parallel. Now you got to bring it back to 50 ohms with a quarter wavelength of 75 ohm coax. And in order to do this in EasyNet, using EasyNet to do all of the complicated calculations for you, you just now have to set it up with multiple points where you're connecting the coax together and multiple pieces of coax. And now you've got an SWR curve that is about 1.05 to 1 on every frequency on 40 meters that you're likely to operate. And it only reaches above 1.1 to 1 at the top end of the band. Now we're going to deal with the 80-meter problem. This is what an 80-meter dipole looks like on an SWR curve with it at the height where the feed impedance is 50 ohms. And you can see that it's 5 to 1 SWR. Totally unacceptable. So now we're going to use that same radar match concept. In this case, we're using we're doing a little bit of an off-center feed. We're using a 25 ohm coax, which is two 50s in parallel. And then we're going to match it up to 50 ohms using 1/4 wavelength to 75 ohms. And now all of a sudden, instead of having a deep notch in the middle, we have a slight rise in the middle, and we have our dips down on either side. And on the frequencies that you'd like to operate on, it's never higher than about 1.75 to 1. And this is something that I came up with a couple of weeks ago when I was trying to decide, okay, I need a field day antenna that'll work on both phone and CW, and I don't know whether I want to put up a phone or CW antenna. And I said, wait a minute, I can make it be both. So here's a phone and CW antenna for field day. And it's just using regular off-the-shelf coax without anything special. So I said, okay, how much better could we get? Well, I took the concept for W7ZZ design, put an adjacent wire next to it, and then I used the radar match and using just a half a wavelength of 50 ohm cable. You got to come down from the antenna anyway, and then the transformation, and all of a sudden now I've got an antenna which is less than 1.3 to 1 everywhere in between phone and CW on 80 meters and 75 meters simultaneously. Would you actually build this? When I show this to people, they typically say to me, well, how do you keep them spread apart? So I don't know, I've never built it. But what I would do is that I would go to the hardware store and I would buy a piece of 1/2-inch PEX and cut it and make it like ladder line with 3-foot spacers. And you probably need one in the middle and one at each end and hang it, and voila, you can end up with something like this on field day, which would be very, very helpful in field day. So then I said, okay, let's try the same techniques on a vertical. And I'll be honest with you, Tim Duffy started with me on this concept. What can we do about improving the bandwidth of a vertical? Because what happens in a 4-square is that you can get losses in a 4-square if the SWR rises. Some people call it waste power, some people call it reject power. That's what we call it in the TV business, is reject power. And in a perfectly balanced system, the reject power ends up in the dummy load. And if you're running a TV transmitter, that's actually a good thing because that's the reflection you want to get rid of. But it is still heat. But on 80 meters, your SWR is high enough where that can hurt your signal strength by maybe almost a dB if you're at the edges of the bands. So I says, what if I took a adjacent wire and put it next to a 1/4 wave vertical? Oh, what do you know? It looks like that. And a 1/4 wave vertical is typically in a mid 30 ohm feed point impedance. And in the process of putting in a wire next to it, it brings it up to a 50 ohm feed impedance. So you can have a tower that's the right height. You put a wire maybe 5-10 feet off to the side of it to exactly the right length. And you don't need a matching section at the bottom anymore to match it from 30 some ohms to 50. It's made the whole antenna be exactly 50 ohms to start with. And then I said, okay, now let's try something else. Because putting a adjacent wire next to a foursquare would actually be rotating the foursquare slightly because the phase centers get off-center because of the spacing between them. So I says, what if we use this radar technique on a vertical? So this is what a vertical would look like if you set it to be 100 ohms at the end of a 75 ohm piece of cable. And in this particular case, instead of using one length of 10 ohm coax, I decided I would set it up as two different impedances that are roughly close to 10 ohms. Now 10 ohm coax doesn't exist, but you can synthesize that if you want, putting various pieces of coax in parallel. But the point is, when you feed a foursquare, they always say that the delay between the hybrid and the foursquare needs to be either 1/4 of a wavelength or 3/4 of a wavelength. And this matches that 3/4 wavelength possibility. So you can get much, much, much better SWR characteristics and much less reject power on a foursquare if this works. I say if this works because I actually haven't tried it yet, but the theory says that it will. And the theory also says that if you just put this in without anything else, the pattern of the antenna will rotate 180 degrees, which you can solve just by swapping your left and right coaxes back and forth, and now all of a sudden it's back to normal. But it should not change the pattern, and it should remove a significant amount of the dump power. And what I need to really test on this is what happens to the mutual coupling in this case, because I have not gone far enough to actually put a hybrid into EasyNet yet and try to model this with EasyNet with a hybrid. It's going to be an interesting process, but that's next on my list. So I can take my concept of using two wires next to each other and move it to an inverted L concept. Call it a double inverted L. Well, here's what it would look like. And I actually put this with radials underneath it so that I get a raised radial so I could see if that raised radials had any effect on it. And in this case, this is a 44-foot high inverted L, and instead of having one wire up and one wire off to one side, it's two wires up and a wire off in each direction, spaced apart. Could be hung up just like a dipole, and you need one spacer at the top and you can feed it at the bottom. This has a feed impedance of 50 ohms. Typically, people who make inverted Ls have a feed impedance of 25 ohm, and they need a transformer in order to match it. This needs no transformer. It's a 50 ohm antenna as it is modeled. So now it's time for winter field day, and the winter field day says, oh, if you operate 160, we'll give you extra points. Well, they didn't this year, but in the past they did. Gave you extra points for every band. And I was searching the internet for an interesting way to do that, and I came across this broadband wire antenna made by a guy named K5GP. And it's basically an offset fed antenna for 160 with a trap in it that makes it resonant on both 75 and 80 simultaneously. And I don't know how he came up with this concept. I got to give him a lot of credit for it. I haven't actually tried to understand all of the mathematics of this antenna, but I've successfully built it. It works extremely well. And it does have an SWR curve that looks like that. A very, very deep notch on 160 down to 1.1 to 1 at about, I set it for about 1850 because I figured I wanted to operate high in the band, because typically winter field day occurs on the same weekend as the CQ 160 contest. So so I figured that the best way for me to operate the CQ 160 contest was to be high in the band, away from all the people that were really down in the DX portion of the band. And this would give me the ability to work some people on 160. And last year in winter field day, I worked 19 people on 160 and gave them all contacts in the 160 contest, while they gave me contacts in some cases. Not everyone gave me the right report, but the ones that did, I counted those. But it was just kind of it's an interesting antenna design, and you can go to the K5GP website and you can find this, how to make this antenna. And this is a 4-to-1 Granella balun. This works extremely well. This particular balun is not made with any of the cores that you normally use for baluns. These are cores designed by Fairlight for EMI suppression. So it's a fat core, and it's taller, and it's smaller in diameter. So what happens is that you have a greater cross-section area in these cores than you have in a standard FT240/43 core. This is 43 material. This happens to be 9 turns of wire on each side. And it's 2 1-to-1 balance with the primaries in parallel and the secondaries in series. So this is a balun that is 100 ohms to 100 ohms. And the theory says that in order to get the best bandwidth on that, the impedance of the twin lead that you're essentially winding around that needs to have a characteristic impedance of about 100 ohms. Well, I didn't actually measure what it was, but it says, I looked at it and says, yeah, it's going to be close enough. It'll be a low frequency. And I put this together and I actually put a compensation capacitor in it. And this works extremely well on 160, 80, 40. I don't use it on 40. If I was going to use it on higher frequencies, I wouldn't use 9 turns. 9 turns is more than necessary. And this happens to be just silver-plated Teflon wire. This is number 20 gauge wire. And this works extremely well. How much power can this handle? Well, keep in mind, in a manila balun, the amount of current or the amount of flux in the core that causes the heating depends on how mismatched your antenna is and how much field you're getting off the antenna. Well, we're intentionally offset feeding this antenna, so it's going to have some coupling into the feed line. So I don't know how much this is going to handle power-wise, but I will tell you that it will handle as much as 3 or 4 FT240 cores because of the characteristics of these cores. And these cores are actually cheaper than the typical FT240 because it uses less material and gets more cross-section area. So now we take the double L that I showed you for 80 meters, and we built it for 160, and this is what it looks like. Under 1.4 to 1, all the way up to about 1.94, and then it goes sky high. So you can't operate the top, 40, 50 kilohertz of the band, but this is a very easy antenna to put up. I forgot what height this is, but this is, no more than 90-foot high antenna. Now I'm going to couple of things together. And this is an interesting antenna that I just kind of dreamed up almost for just as an example of what you can do with easy neck and antenna designs. In this particular case, it's an 80-meter antenna. It's got an adjacent wire to it, a la W7ZZ. It's fed with a quarter wavelength of 75 ohm cable, so it brings the impedance down to 50 just the way it's supposed to. And then off the center of that, I have a 40-meter antenna, which is brought down to 50 ohms by turning it into an inverted V. And it's made broadband because it's a bow tie. So that has a feed impedance of 50 ohms because you've decreased the impedance by bringing it into a V shape. And then the next thing you do is that because it's fed with a quarter wavelength of coax on 80 meters, now it's all of a sudden a half a wavelength of coax. And now it repeats the 50 ohms at the antenna to 50 ohms at the feed point. So now it's a transformer on 80 and just a regular impedance repeater on 40. Something you could put up permanently if you wanted to, something you could use on field day. And this is what the SWR curve of that looks like if you put it on a single graph where you can see the double tuned circuit for 80, 75, and a double notch on 40 as well. Now I'm going to talk about end-fed half waves. They're very popular these days. I've used them on field day. We have some people that are that love them. They're tricky because I built one the way that you're supposed to, and I put a good balun in it. I know it was a Guanella balun, and we still had RF in the shack. I had audio interference from the CW station getting into my CQ loop on my audio link between my computer and my K3. I tried grounding the computer to the K3. It didn't help. Put ferrite on the audio wire between the K3, and it didn't help. You know, of course, that the K3 has transformer inputs, so there was no need for me to put transformers on the outside. Cars were running on generators. We're not connected to the building ground system at all. So I said, what if I just took the antenna patch panel that we had and put it on the third wire of an unused AC plug, and that solved the problem. So the trick is, if you ever use an end-fed half wave, make sure it's grounded to your house ground, and the problem goes away. And this is a Yagi, and you're probably thinking to yourself, wait a minute, I thought this was wire antennas. It is a wire antenna. I did this to operate VHF contests at W2SZ, and I wanted an antenna with very high front-to-back ratio. And if you look at all of the various antennas that you might buy, all of them are designed for maximum gain. None of them are designed for high front-to-back ratio. So I said, okay, I've got to roll my own here. So I said, okay, how am I going to do this? Well, I started out with some aluminum. I found out that it was heavy and expensive. And I needed to build a number of these to do what I wanted to do, because my plan was to have 2 stations 800 feet apart where I could operate sideband and FT8 simultaneously. So this particular antenna created some interesting dilemmas for EasyNet, because now you're not dealing with bare wire, you're dealing with wire which is a combination of fiberglass and nylon and PVC insulation over the wire. So you can't predict what the length of the wire is, you can't predict what the dielectric constant of the combination is. And when you start stacking these antennas, 2 other things happen that really makes you chase your tail. So I had fun doing this because I designed it, I built it, I measured the front-to-back ratio. And from the front-to-back ratio, which was calculated, and the front-to-back ratio that I actually got, I could say, okay, there's a problem here. How do I solve what this problem is? Well, I had to go back and actually calculate what the dielectric constant was by putting in different numbers for the dielectric constant until the front-to-back ratio of the predicted antenna was exactly what I had measured. Once I knew that the combination dielectric factor was 3.45, then I could continue my design with the antenna. Then I said, okay, what happens if I stack it? Well, 2 things happened. The front-to-back ratio goes to hell, and the maximum front-to-back ratio moves down about 700 kilohertz, down to 49.5 roughly. So now I have to redesign the antenna with shorter wires. I recut it again. And I've got to figure out how far apart to stack it. Well, experimentally, I tried different stacking distances, and the front-to-back ratio became correct when it was stacked exactly a half a wavelength apart. It happens to be 118 inches. And this is what the pattern looks like. I have a 40 dB front-to-back ratio off the entire back of the antenna, and there are notches in 2 places that are down to 55 dB front-to-back ratio. And if you're looking to try to do 2 things simultaneously within 800 feet apart, you could actually get lucky enough to turn them in such a way that the notch of one could be in the notch of another. I don't know how effective that is. I haven't tried it. I haven't needed to. The math of this says, okay, don't use the front-to-back ratio. Use rear to isotropic. Well, rear to isotropic of this is about 25 dB. So if you put 2 of these 800 feet apart, the path loss is more than 50 dB. You get 25 dB rejection front to isotropic, or rear to isotropic on one, another 20. That's over 100 dB of isolation. And now you can operate FT8 and sideband almost simultaneously. And I hope that I've inspired you with some tricks. Learn what I have done with EasyNet and tricks of using EasyNet to derive things that perhaps nobody else has tried before. And I can say is I hope this has been helpful to you in understanding how I use EasyNet. Thank you very much. Oh, nice. Greg, and you can fire it up.
So you don't want to leave now. Getting all choked up here. No, we still have 2 excellent papers to go here this afternoon, and we want to make sure that you get the most out of this. These presentations will all be loaded on the k3lr.com website in about a week or so you can get the slide decks there. So if you want to get that information, it's available there. What's that? Video? I'm not sure. That's Hamvention, so I'm not sure. They're trying real hard back there, so let's see. We have 2 presentations to go, all choked up, feedline choking without suffocating. Please welcome back Greg Gordy, W8WWV.
Thanks, Tim. I'm going to try to get through this, and I'm sure I will. But some of those designs in the last presentation have my mind spinning, right? When I see low SWR on 160, and then I'm up on 80, boom. So we'll see, we'll go through this. All right, choking without suffocating. Hope this is big enough here. All right, what is the choking problem? What problems do chokes solve? And how does resonance fit into the choke problem? I think it fits in quite a lot. What's the impedance necessary in a common mode RF choke to drive current through it so low that the conductor being choked no longer causes a problem? And I would call that a successful choke. So how much choking is enough? That's really what I'm getting at. And are there any other solutions or tools beyond a choke? And I think the answer is yes. Now, what I'm really not going to get into here is the construction and the materials of RF chokes. A lot of people do that. A lot of companies do that. They sell all sorts of products, and that's a great topic. And because everybody else is doing it, that's not what I'm doing. There are some references at the end, a lot, I hope. We'll have some examples, too, conclusions, references. Okay, I hope we can all agree that an amateur radio station should have at least one antenna. In addition to the antenna, there could be feed lines, control wires, towers, gutters, downspouts, flagpoles, metal guidelines, power lines, and lots of other metal. And one of the things I like to keep in mind is that although we have all those titles and names for it, Mother Nature doesn't care, right? She's under no obligation to respect those different names and functions. So anything can act as an RF carrier, that is in an antenna, especially if it's a resonant size. And if current's flowing in something, even a receive antenna, some power will be radiated, even in a receive antenna. That's true. When RF flows where it's not wanted, of course, that opens the door to additional station problems, including antenna pattern distortion, reduced antenna performance, RFI, TVI, hot microphones, noise pickup, etc. So I think generically the term that we're using nowadays to block or reduce that unwanted RF current is choking, although I think it's really a broader solution. Okay, the importance of resonance. Remember this demo from your school days? Audio sympathetic vibrations, and you had 2 similar tuning forks, and you would whap one and the other one would vibrate. And of course, the same notion of coupling exists with RF circuits as well, antennas. You can either drive it directly by hitting it, a little bit like feeding it, or it can be a parasitic element picking up current through coupling through another excited conductor. And resonance, of course, peaks the current. Now, regardless of how the current gets there, it'll be radiated except for the loss in the conductor. Now, one thing I wanted to mention here, just in case people aren't that familiar with it, is below in the right corner is an easy neck model of a, 6-element Yagi. And I just wanted to point out that the line that looks like the boom, that's the x-axis. So don't think of that as the boom. Then you have the 6 elements that are part of the Yagi. And then that pink line, which is the one I want to just mention, is that shows the current amplitude on that particular wire, on that particular element. And when it's very far away from the element, the current's highest. And when it gets close to the element, it's lowest, all right? Now, another thing that also I thought I would bring up here is we're right in the middle of the 100th year anniversary of the invention or discovery, whichever you want to pick, of the Yagi. And I mean, the Yagi is just such an incredible antenna. It's just hard to believe almost. And from doing some simple internet searching, I'm sure everybody's heard of the internet, it turns out that the work began in 1924. A paper was published in December of 25, and there was a Japanese patent in 26. And a little description here, of course, the antenna system using a driven element with closely coupled parasitics, usually a reflector and one or more directors for shortwave work, was first described by S. Yuda, a lecturer at Tohoku Imperial University in Japan. And then, of course, he combined with Professor Yagi, and apparently Yagi was the more proficient in English, and therefore he got the English exposure. But of course, I think everybody knows we should call all these things a Yagi-Yuta antenna, but we leave off poor Yuta, and he really deserves it. Interestingly enough, RCA ended up with the United States patent in 1932. So my comment to Tim, wherever the heck Tim went to, oh, there he is, for next year, for a topic for this whole thing, you could do like the centennial celebration of the Yagi. But that's just my 2 cents worth. Okay, the importance of resonance, what makes the conductor resonant? Its length allows it to carry peak available current at the resonant frequency. If it's being excited, this usually implies 0 ohms of feed point reactance, or the voltage and current are in phase. To me, there are 2 rules of resonance, and these are sort of burned in my mind. An electrical quarter wavelength is resonant when there's a high impedance or an open on one end, and a low impedance, that is like a ground, on the other. Current flows into the low impedance. So think of like a grounded quarter wavelength vertical. It's very resonant. A half wave element, twice as long, is resonant when there's high impedance on both ends. And of course, when you think about it, that's just like taking 2 quarter wavelengths and butting them up. And in some sense, this guy gets a ground from this guy, and this guy gets a ground from that guy. So it's maximum current in the middle and lowest current at the ends. Okay, and of course, anti-resonance means we're going to reverse or break those rules. So we want to float quarter wavelength or ground a half wavelength to reduce the current. And of course, these rules repeat every half wavelength. I'm not going to really, keep that in mind, although I'm working down at the quarter wavelength level and half wavelength. Okay, and of course, a quarter wavelength conductor open at one end, it's a low impedance at the other. And many people have used this as an artificial ground. And I think MFJ and other folks have a product called an artificial ground. And you really lay out a wire, and the ground is effectively a cheapy tuner, so you can change the resonant length of it. And that will give you a low impedance. Of course, the problem is it'll radiate too, right? Because it's just a single wire. But for certain circumstances, that may be preferable than wherever else the current's going. Okay, now, ground, of course, is more than just the earth ground. Obviously, ground rods are earth ground, and some grounds are broadband, others are more resonant. So in this example, there's a frequency-independent ground antenna model, and you see the pink line showing a lot of current in it. The frequency-dependent one, there's a vertical with 8 radial wires, and if you added up the magnitude of all those 8 wires, it would equal the vertical itself, because it's sort of the other half of the antenna. And then there's popular diagrams, I ripped this off from the AHRL, showing the normal current and voltage distribution on a half-wave dipole. And I guess I'm going to make the claim that serious problems that require attention and choking usually require resonance to get in there, so the current gets peaked up, and then that's what leads to really noticing it. Okay, so as an example here, let's go with the 40-meter vertical. You get a better handle on this resonance thing. The characteristics, I had number 12 wire, it's resonant at 7.1 megahertz, 33.66 feet tall. The feed point impedance, 36.76 minus J, 0.000, I'm going to call that 0. 0.55 dBi gain. And notice it has no front to back or front to side, it's omnidirectional, right? And if you put 1,500 watts into that, it's 6.4 amps at the feed point. And of course, the maximum current is at the base. So this, of course, is what we expect. And I'm showing the omnidirectional pattern with no front to back or front to side. If we add a second identical grounded parasitic vertical, quarter wavelength away, and then let's look and see what happens. Now, of course, in some senses, this is the worst case. We have the same polarization. They're broadside, they're close. And the parasitic must be grounded, of course. We're keeping it grounded to make it resonant. Okay, so if we look at the characteristic of the impedance, the 36.76 minus J0 went to 30.87 plus J16. So the impedance of our single-driven vertical has shifted a decent bit. The maximum gain, interestingly enough, went way up, but that's because we made a 2-element array. right? We didn't set out to do that, but that's what we created. The front to back went up to 5.92 dB from 0, and the current now, actually in the main vertical, went up a little bit, and it's almost the same in the parasitic. So and the comment I wanted to make here is, if you're ever working on an antenna and you think you really know what you're doing, and you've got like some model data or other information, and you find that the impedance is way off from what you're thinking, then consider whether there's some other metal in your environment that you're coupling into. Okay, so how important is the length of the parasitic? Because in the first case, they were the identical length. So in this case, what I did was I took the second vertical and changed its length from 15 feet to 45 feet in half-foot increments and wrote down the maximum current, okay? And as one might expect, when we get near resonance, around that 33.5 feet, the current peaks, right? But notice if we go about 6 feet each side of resonance, the current drops by 80%. And of course, on 40 meters, that's about 6 feet. But on 10 meters, that's only 1.5 feet, right? So not much difference causes a big change in current in that parasitic antenna sitting out there. Okay, so now we ask the important question, can we choke the parasitic vertical so that it becomes invisible and we go back to our original single vertical, which is really all we wanted? And we're going to make it anti-resonant by floating it at the base, because I said before, that's what makes it anti-resonant. And of course, this is the same thing as adding an extremely high impedance choke at the base, since that's what an open circuit is, a high impedance. Okay, so then in the upper picture in the middle, notice that now we don't see any current on the parasitic number 2, and that's probably good. And the impedance for with the parasitic now is 36.26 ohms versus 37 with one single antenna. And then the reactance is 0.21 ohms. And note the maximum gain has gone from 0.55 dBi to 0.75, front to back, 0 dB to 0.32. So what I'm saying is for most all of us with our equipment, we can't tell the difference, right? The parasitic is effectively gone, and we have a single vertical by just lifting off the ground the parasitic. Now, if you go in there and you jack up the current gain, the zoom on the current in EasyNet, that's what the bottom picture in the middle is, that first driven wire, notice how the line goes way, 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 way out because it's magnified. But what it does show is that there is a little bit of current flowing on the parasitic, but because there's a high impedance on both ends, it's going to have that typical dipole sort of shape. And then the front back is here, it's very low, so it's almost omnidirectional. Okay, so floating the parasitic is the same as putting a high impedance at the base. So high impedance is on both ends of a 1/4 wavelength element. It's anti-resonant. We can get into more details here. What the thing you have to really keep in mind is if you're ever building a vertical array with more than one vertical, it's an array, you want to be in the 1/4 wavelength. Be sure you're floating all the unused verticals when you're measuring the self-impedance or whatever antenna you're considering. Because if the other ones are grounded, they're going to be coupled in and shift the impedance, and you'll drive yourself completely nuts. Okay, what about half-wave conductors? Do you really ground or low impedance a half-wavelength element to make it anti-resonant? So in this case, in the picture on the right, the parasitic is now twice as tall, a half wavelength, as the driven one. And you notice there is pretty considerable current running on wire number 2. Now we could use that as a vertical by itself, right? That's called voltage feeding or high impedance feeding, whatever you want to think about it. But here, because wire number 2 is floating at the bottom, it's conducting a lot of current. Then for the second picture at the bottom, I grounded it, okay? And now notice that there's really no current floating into it. So the key point here is that not only are chokes, a high impedance, useful in breaking up resonance, but so is ground, or a low impedance, right? So now there's sort of two things in our toolkit. Now, of course, you don't want to try to get too smart here, right? You might come along and say, well, Greg, if a little is good, more's got to be better. So what I'm going to do is I'm going to go put a choke in the middle of that half-wave element. So I want all the current to go to zero. But notice what would happen if you would do that. It would be grounded, a half wavelength long, and then a high impedance, right? So now it's particularly resonant and conductive. So again, you got to, keep straight with the rules. All right, and of course, these are not really new ideas. I ripped this off of the 2000 handbook. I'm sure it goes back much further. But before Philly strand and fiberglass skylines, the idea was you could add insulating guys along the way to break up resonances. And here we find, if we look at 7 megahertz, and I'm sure this is hard to find, but it says don't make your guy length between insulators between about 58 and 72 feet. And that's because it's around half a wavelength on 40 meters, which would make it highly resonant. So, really there's not much new here. Okay, instead of using opens, what about resistance and reactance? So what I did here was I examined the range of resistance and reactance values placed in the middle of that parasitic vertical. And I'll do resistance first. And of course, we're going to check for the efficacy of our choke by seeing how close, again, we get to an omnidirectional pattern. That's what our goal is. We want to get rid of the parasitic vertical. But we're going to also keep an eye on the power dissipated in the choke. All right, so here's a picture of that. 50% of the way up the parasitic vertical, it's grounded still, is where we're going to put this resistive choke. Now, you could also put it at base 2, but we've already sort of done that with the open. Okay, and later on slides I'm not going to cover, I varied the impedance, the resistance of that choke from 0 to about 15,000 ohms, and I'm going to pull data from that just because that's all we need to look at. Okay, so here's the graph showing the power dissipated in the resistor and the front to back ratio. Now the power is the green line, which when we get out to about 60 ohms of choking, that little resistor with 1,500 watts in the main antenna is taking about 200 watts. Okay, so that obviously is a big problem. And the front to back, of course, is still very high. But then as the resistance continues, notice that it's starting to drop, as is the front to back. And it turns, now for this range, it's 500 to 5,000 ohms. Both the front to back and the power are going way down. And in fact, I just sort of empirically, all by myself, said, about 3,000 ohms of resistance is the point of diminishing return. Okay? And I continue this on with other graphs to 15,000 ohms, but they're just a little bit flatter. So what's the performance of putting that 3,000 ohm resistor in the middle of the parasitic vertical halfway up? Well, notice the impedance, 36.76 was one vertical, 36.3 plus J, 0.25 ohms is with the choke. That's pretty darn invisible. The gain, 0.55 dBi, 0.6. The front to back is still 0.04 dB. Nobody's going to measure that, right? So effectively, by putting that 3,000 ohm resistor halfway up the parasitic grounded vertical, we've choked it off, if you will, and gone back to our one vertical, which was the goal. Okay, so of course, this is 3,000 ohms at the frequency of interest. It's better than floating the base. Resistance clearly makes an effective choke. The danger in low values of resistance is you dissipate way too much power. But you've really got to be down, under 100 ohms or something if you want to make this into a space heater. And of course, this is kind of a worst case. The old power formula, and normally, P equals I squared R, we all know that. So you think, gee, more resistance should be more power. And while that's true for constant current, don't forget in this case that as the resistance goes up, the act of choking is causing the current to go down and the current squared, right? So we end up with less power with higher resistance. Now here's a slide that I think, if there's something important in what I'm about to say, this may be it. Over on the left, we have our green 1/4 wavelength 40 meter vertical. And of course, that's 0.25 wavelengths on 40 meters. It's also going to be, of course, 3/4 a wavelength on 15 meters, right? We know that too, and very close to resonant. But what did we do? We came and we put that 3,000 ohm choke in the middle of the green parasitic vertical over on the right. So now 40 meters is choked, right? Hooray, we've done it. But at the same time, let's look at the bigger picture, right? Assuming that choke is still choking at 10 meters, what we have in the upper half of that is a half a wavelength of 10-meter length with an open circuit, a high impedance on both ends. That's resonant, okay? And likewise, below the choke, we have a quarter wavelength of grounded 20-meter metal, which is resonant, okay? So yes, we fixed a 40-meter and probably 15-meter problem, but if at all 10-meter and 20-meter are on the picture here, that might open up a new problem. And that's why I think, to me, chokes always have the property, they can help you and they can hurt you. Boy, this guy here. You know, it turns out at the end of the day, no matter how high you make that choking impedance, it's hard to make the current in it go to zero. And that's largely because once you choke it, you end up effectively with two collinear verticals, each with a current profile on it, with a plus and minus voltage right at the choke. And no matter what the resistance is, it's going to conduct some current. But, you know, that's more of a fine point here. Okay, reactance. Well, then I did the same set of measurements and tests for reactance, inductance, and capacitance. And again, measured or varied them from 0 to 15,000 ohms of reactance. I'm assuming infinite Q, there's no resistance. Negative reactance, of course, is capacitive. Positive reactance is inductive. And of course, we all know from just general ham radio stuff that a little bit of inductance makes an element electrically longer, right? We're loading it. And a small amount of capacitive reactance makes it electrically shorter. So here, this set of results, and notice along the x-axis, the resistance is 0 to 200 ohms. We, depending upon whether we're using an inductor or a capacitor, we've either put the pattern in one direction or we've reversed direction, right? And that's what's going on here. When you make it a capacitor and adding in the reactance, the front to back goes down to 0 until it switches the other direction. Okay, so obviously, values up to 200 ohms aren't doing a darn thing to choke this, right? They're just making it into a different two-element array. But I continued to measure out to 15,000 ohms. And once again, and I think this is just, you know, accident. I don't think there's anything special about this. Around 3,000 ohms, I said, you know, this is getting mighty flat. So let's just call that an important number. And of course, if we look at the colors here, the front to back are the bottom two lines, and they're getting very close to around 0.2, 0.3 dB. And then the higher two lines are the gain, which we know should be 0.55 dB, right? That's one vertical, and they're between 0.6 and 0.8. Okay, so again, I'm making the claim, 3,000 ohms of pure reactance, we've made the parasitic quite invisible. So reactance to me makes an effective choke. Now, the issue though is with low reactance values, you're simply nudging the resonant frequency as opposed to creating what in my mind is a large mismatch the current finds hard to cross, right? We're reflecting off of that mismatch, impedance mismatch. Now, there are some people who go on talking about you really want your choke to be almost pure resistance. And don't get me wrong, that's a great goal. But I don't know how you make a pure resistance that broadband too. And so the reactance, the problem again, like with resistance, is low impedance values. Because then you're not really choking, you're just nudging the length a little bit. But nonetheless, to me, if you get up 3,000 ohms or more, whether it's resistance, reactance, or both, you're largely solving practically the problem. Okay. Chokes at feed points. This is the often cited example. I ripped this picture. Oops, geez, Manish. Don't lean on this, whatever you do. I ripped this off of Palomar Engineers, but the similar graphic is everywhere. A coaxial cable is actually 3 wires. And if I freak you out saying that, then you've not been a ham long enough. There's the inside of the outside of the inner conductor is one conductor. The inside of the outer conductor, or the shield or the braid, is number 2. And the outside of the outer conductor is conductor number 3. And due to skin effect, the two faces of that braid or shield are actually different. And number 1 and 2 go together and they're equal magnitude in opposite direction. That's the transmission line differential currents. And they largely cancel and don't radiate. 3 is the common mode current, and that's what we're trying to choke, right? That's where the antenna currents are. And so the picture on the right on the top shows that. And then on the bottom is pretty much how everybody models that, which is to say we have a dipole, we have a source in the middle driving it, and then to model the choke, if you will, or not the choke, but the transmission line, we simply drop a wire down, because this is the third wire, right? So we're not modeling the transmission line at all. We're just modeling the outside of the coax cable. Now, for me, I oftentimes think, boy, when did this choke stuff start to show up? And I think of stuff like in the late 70s, early 80s, Walt Maxwell, WTU, Roy Llewellyn, W7EL, Joe Reiser. They had articles talking about chokes and we want to use them in our antennas. But one of my favorite books is one going back to 1945, Transmission Lines, Antennas and Waveguides, published by 3 guys from Harvard, of all crazy places, in 1945 again. And then they talk about the presence of antennas or other circuits may cause currents to flow on the outside surface of the outer conductor of a coaxial line, which may be quite independent of the transmission line current that flows on the inside surface. So again, and I'm sure people knew about this before 1945, but this is just kind of the earliest reference I know. Now, given what we've already known about high and low impedances on different sides of like quarter or half wavelength, that then explains how things like that sleeve balun works, right? You put a metal sleeve around the coax, a quarter wavelength down, you short it to the coax, but it's open at the top. And given what I said before, that puts a high impedance at the top, and now current only wants to flow in the 2 dipole arms. It's really blocked from going down the coax, or it's choked. Okay, installing a common mode current choke at an unbalanced or balanced feed point is standard practice these days, right? I mean, has anybody ever just hook up a dipole and run the wires and pull it up? It's probably the lightest thing to do, but I think everybody's into putting chokes at their feed points of things like dipoles or Yagis. And in that role, it's performing the balun function. And I think it's a very good idea, so don't stop. The idea is to discourage current flow from flowing back down the outside of the transmission line as if it were part of the antenna. And of course, this kind of is a two-way street, right? Current that might be wanting to get into the dipole from the transmission line is discouraged as well. And all the rules of resonance apply to that current because the choke's creating a high impedance point similar to an open. And of course, common mode current does radiate. Now, if there's going to be a problem with heat and chokes, and some chokes do melt, it's probably going to be a case in which it's a feed point choke with high power, QRO, and substantial antenna and transmission line imbalance. And in that case, the transmission line is the preferred antenna, right? When your antenna prefers the transmission line to the wire, you're going the wrong way. Okay, here's a little quick example. So imagine somebody puts up a 20-meter dipole at 33 feet, and there's a multiband vertical in the yard a short distance away. I made it 45 feet. The dipole has a feed point choke of Z equals 3,000 plus 3,000 ohms, right? So that's resistance and reactance. I picked 3,000 ohms just because it's what I was using before. Now, to me, it's also good practice that the dipole coax is grounded through a surge and lightning protector down at the ground, right? Word Silver N0AX has a great book out, Grounding and Bonding for the Radio Amateur. I'm sure it's available all over the place. It's really a good book, and I'm sure grounding everything that's going to come into the shack for surge and lightning protection. Good stuff. Okay, and of course, the issue is that if that coaxial transmission line picks up energy from the vertical, it's going to re-radiate it. And now that it's close to the house, in my little cheesy example, That, of course, can cause problems inside the house because we're dragging the antenna closer and closer to the house. Okay, so what have we created here with this? And admittedly, I picked this, the example to highlight it. But the coaxial line is 33.5 feet long. That's what our quarter wavelength on 40 meters was. We put a choke at the top because everybody told us, put a choke in your dipole. You got to do it. So we did it. At the bottom, we grounded it because everybody said, ground it so that lightning doesn't come into the house and blow it up. I do have a black spot on a carpet in my house where lightning came in once and it went through the floor. And I don't know where it was going, but it was a bad idea. It scared the hell out of me. Okay, but what have we created here? We've created a 40-meter vertical with an open and a ground on the other side, maximally resonant, right? We weren't intending to do that, but that's what we did. Okay, now can we add a choke at the ground to get rid of that resonance? Yes. But here's where I would then say, well, what's the order of the choke and the ground? What order are we going to put them in, right? Seems to me that for our 40-meter example, we want the choke first and then ground it so that the 33 feet of coax has a high impedance on both sides, which is anti-resonant. If we go the other way and put the ground first, it's still grounded. Okay, and the choke is after it. Of course, now what's funny is for me personally, I would prefer to put the ground, the surge protector first, thinking I'm going to protect my choke. Because the energy comes down, go to ground, don't hit my little poor choke. The problem is I've rendered it useless because of being able to go to ground. So it's almost like there's no free lunch, right? Of course, now on 20 meters, what's going on? With the choke at the bottom, we have a half wavelength floating on both top and bottom, which is highly resonant. So for 20 meters, we would want the ground first. And, so I guess what I'm saying is, if you're solving a problem where choking is part of it, it's always, well, did I have create a problem someplace else? Now, chokes near stations are sometimes called line isolators. It's a different name, but same purpose. Insert high impedance there. Let's see here. We could talk about the current by grounding it in that, the current in the coaxial vertical, if you will, the fake transmission line, is cut way down. That's what the numbers show here. Now, I've noticed there are some chokes made out there. I know I've done this on some of my homebrew chokes that come with a ground lock, right? So you've got two connectors, and the one someplace is a ground lock. And you're figuring that's connected to this side or that side. And for a long time, I used to think, what the hell is that for? But then I started to realize, no, that could be used as a convenient place to then tap off and ground it. But now, of course, it matters getting into the right direction, right? Okay. Choke anatomy and reality. So what do we build? Well, we wrap a conductor around ferrite, and we would say, hey, I recognize that. It's an inductor. But of course, what we usually get within the HF range we're talking about, it's a parallel resonance circuit where the capacitance comes from the turn-to-turn capacitance of the choke we wound, of the inductor we wound, if you will. Now, parallel resonance all by itself adds lots of resistance, right? Your high resistance at parallel resonance. But in addition, we've wrapped this around ferrite, and that, really goes hard on the resistance as well. That's why we use it. Okay, so number 3 here, the third one down, we've got a lot of resistance. It's pretty broad band, and also some resonance. Now, the thing I want to bring up here for the next couple slides is stray capacitance, right? If in number 4 at the bottom, notice I have a dotted little stray capacitor in there. And, again. That, of course, is just going to be in parallel with the other inherent capacitance, and it's going to change the frequency response of the choke. Is that going to wreck it? Normally not, but it's going to move something. And if you're out there saying, I spent my whole life designing the world's highest choking impedance for 40 meters, you got to be careful that it survives on 40 meters by the time you're done building it. And for example, 5 picofarads at 8 megahertz is 4,000 ohms of capacitive reactance. And that's on the order of what we're talking about here, right? So that stray is enough to really not unbalance, but upset the apple cart. Stray capacitance is sneaky. Now, I think the thing everybody learned early on if you're playing with chokes is you can't put them in a metal enclosure, right? Because that just shorts out the whole thing we're trying to do. You connect one end to the other, the thing wound inside is shorted out. So don't put chokes in metal boxes. Some folks like to put chokes in a metal box, but maybe with an insulated coax connector on one side. Nothing wrong at all with that, but just understand that the box will be acting as added capacitance. And so I would say just make sure you measure this inside the box, not with the choke components on the bench. Now there's a type of choke, the bead ballon, that is oftentimes used in Yagis, right? And this is where you take a couple feet of thinner, thick coax and put beads of ferrite all along their length. And it's a very good way to make a choke as well. But it turns out that if you go and then tape that with a bunch of Scotch 88 right up against your boom for support, that boom is acting as straight capacitance, right? Because the coax shield before the choke is up against the metal, and then it just travels down the boom, and then it goes back to the other side. So again, this is not necessarily, hurtful or wrecks something, but it just changes it, and it's sort of unexpected. There are some commercial solutions to that. DX Engineering has what they call the bead choke standoff kit. So there's a couple of clamps and then some insulator spacers and then some other stuff. And this allows you to sling the bead ballon a couple inches underneath the boom, which helps out with this great capacitance problem. Okay, can a choke impedance ever be too high? To me, not really. But the challenge is, can you hold on to that straight capacitance out there in the field or hold on to the choke impedance without some straight capacitance getting in there and just ruining it a little bit? The higher the choke impedance, of course, the more influential the straight capacitance is, since it's in parallel with the choke. If you've made high choke impedance a goal of your life, give some consideration to how it's mounted and if excessive straight capacitance can sneak in. And again, this doesn't wreck things, but it just changes the response of the choke. Okay, is it impedance or attenuation? Historically, chokes were measured like any other two-terminal device, resistors, inductors, capacitors. And you might use something like a VNA or an antenna analyzer, and the results are measured in units of ohms, right? Resistance, reactance, impedance. In recent times, some folks have been characterizing their chokes in terms of common mode signal attenuation measured in decibels, dB. Now, at first, this sounds like apples and oranges, right? Ohms and dB, they're not the same thing. It turns out that the two different approaches produce the same results, and they can be converted from one to the other. Now, of course, here, seeing as we're talking about making measurements, again, straight capacitance could be part of the test jig. So that's another, not only is how you mount the choke on the antenna potentially a source of straight capacitance, just trying to measure the stupid thing on the bench can sometimes, throw things off a little bit. Okay, so this picture was taken from the VNWA user's manual. And of course, nowadays, inexpensive, high-quality two-port VNAs, like the Nano VNA, I've got two of them, they're out there, they're pretty inexpensive, so this is no longer exotic stuff. The picture on the left is showing the typical reflection measurement, right, like we would do with an antenna analyzer. So the TX port on the VNA goes to the ZX, the thing we're measuring that's then grounded, right? Now, this picture is a little bit too simplistic in that if we open up the box a little bit, what we'll actually see is a reflection bridge, right? We get to the outside world through a reflection bridge, and that's what causes the energy coming back, reflected off the choke in this case, to go back to actually another receiver. There's really two receivers in here. And that's like what an antenna analyzer does, and the results are in ohms. And this, for the people who are into scattering parameters, this would be an S11 or a reflection measurement, okay? Now, the other way we could measure that choke is the picture on the right. In this case, we come out of the transmit port, we go through the choke and into the reception port. Now the results are insertion loss and a phase shift measured in dB and degrees. And this would be, for the scattering parameter crowd, an S21 or transmission measurement. Now it turns out, for the very special case, and I know bad things are going to happen here, of a two-terminal, right? Like a resistor has two terminals, that's one port, passive device. The results of one of these measurements can be converted into the other with a bit of complex math. And the thing that nobody can do, I won't let you leave the room, is if you ever go to somebody and say, I saw this guy Orty at the antenna thing, and he said S11 is the same as S21. Please don't do that. They're in general wildly different, and that's why we have two different measurements, because they're so different in what they do. But for a two-terminal device and some complex math, and it's all in the VNWA manual, by the way, you can do that. Okay, so here I took some chokes that I've wound over time, a block, I think, of probably mixed 43 ferrite, a number of turns of a thin coax, and there's my little test jig for making a transmission measurement through the choke. Now, another thing you get into here is that depending upon the range of the impedance you're measuring, you want to pick different measurement test setups to measure it most accurately. Things like an antenna analyzer with a reflection bridge are really targeted for measurements around 50 ohms. You know, we call it a vector network analyzer. And to me, what question that brings up is, well, what the hell is the network we're measuring? And it turns out that that's something near 50 ohms historically. If you want to measure really low ohms, and I mean both resistance and reactance with accuracy, you've got to use a different test setup. And if you want to measure really high impedances, you need yet another test setup if you want the most accurate results. And if you get through all of this stuff, the three different approaches all put together are called the RFIV method. And there are some expensive devices called not network analyzers, but impedance analyzers that are willing to do all three measurements and then combine the math and give you very accurate results, but they're fairly new and fairly expensive. Now, notice I'm making a transmission measurement here, and of course, I did this for the purposes of these slides, but then after I looked at this, I said, gee, you wonder where my coax cable, which is insulated, goes by that metal box, is that stray capacitance? How much am I adding? And all this stuff can make you nuts sooner or later if you think about it too much. Okay, but here's the result. The top red curve is the attenuation measurement in dB, right? And I have markers here at 1.8, 3.6, 7.2 megahertz, all the main lower HF bands. And so, for example, marker number 1 at 160 meters is minus 34.67 dB. That's how much attenuation the signal had getting through the choke in that transmission setup. 3.6 megahertz, it actually goes up to minus 41.23 dB. We can see the maximum attenuation is kind of up around, 4 megahertz or so, and then it falls off. Now, using the built-in math of the VNWA, I created the bottom blue curve, which is an impedance, right? So, for example, point number 1, 1.8 megahertz, which is 34.67 dB of attenuation, is the same as impedance magnitude of 5,373.46 ohms, okay? And likewise, they go down the whole curve here. And some folks, I see both of these systems being used to document chokes. And don't let one freak you out or the other, because they're really telling the story I don't want to say the same story two different ways. And if you notice the two curves, they're sort of mirrors of each other, right? In one case, loss goes down, and in the other case, impedance goes up, which seems completely reasonable to me. Now, of course, I made the comment before that I was looking for 3,000 ohms of resistance or reactance to say, I've got a good choke. And if we look at this, squinting a little bit, we see that above 20 meters, 14.2 megahertz, we have 3,400 ohms. So that's getting to the low side. The top side, 11,000 ohms, right around 80 meters is great stuff. So I would tend to call this a choke appropriate for under 15 megahertz. If we get up to 10 meters, it's only 1,483 ohms of the impedance magnitude. And, that's getting to be a bit meager if that's where we wanted to use it. One of the things that comes out about this that I keep in my mind is 40 dB of attenuation is pretty darn close to 10,000 ohms. And 30 dB of attenuation is pretty darn close to 3,000. So if some manufacturer or that gives me a curve and I'm looking at dBs, I can kind of convert back and forth. I'm not going for 10 decimal places, but just to get a sense of how it goes. Now, some people here too, I think would look at this and say, this choke offers 41 dB of common mode noise suppression. I don't know that I can agree with that statement. First of all, it's only 41.23 dB at one frequency, right? So I'm not going to take one frequency and just call all of HF gets that same maximum value. That's a bit cheating and hand waving. And it's also true that what we're measuring here is a 50 ohm signal trying to make it through the choke to a 50 ohm receiver. And how does that exactly translate to if we were doing it on a transmission line or another conductor? Are we saying that that noise that we hear is going to drop by 40 dB? I'm not sure I believe that. But, okay, so real HF chokes have a peak impedance at some frequency in the range. Parallel resonance will be there with the maximum R and maximum resistance and reactance is 0. As you might guess, this is oftentimes the impedance advertised with the choke. Again, if I were to say, hey, I got a great choke for you, it's 11,000 ohms. Well, at one frequency again, right? So think about where you want to use it. Usually it turns out, I think that chokes, and again, this is just my opinion, tend to cluster even sort of under 15 megahertz or above it. So like if we go back to this picture, the reason why the curves either dip or peak where they are comes down to the ferrite we used. And I said I wasn't going to talk about this, but I'm a liar. Comes down to the ferrite we used and the number of turns, right? It's that simple. Put more turns, the peak shifts down in frequency. Pick, for example, mix 43 versus mix 31, it shifts up. So a lot of this, especially if you want to get into your own choke business, is experimenting with that, making measurements, and then you might say, this is a great choke for 160, 80, and 40 meters, or this choke is designed for, 20 through 10. Okay, difficult situations. There are some chokes that do fail due to heating of the ferrite. This, I think, is most always in a transmission line with high power and severe imbalance on the antenna so that the preferred current path is down the feed line. This could be an off-center fed dipole or transmission line far from being perpendicular to the antenna. And here's where probably having a higher impedance choke, more than 3,000 ohms, is probably going to be helpful, or go more than one choke in series. Quick comment here on choking switching supplies. In 2006, W1HIS, Chuck Councilman, had a note that's been out there, well, since 2006, that's really good stuff. And he goes into choking wall warts and similar supplies. And now we're trying to keep their noise from us. And the noise is usually worse in the first few megahertz because that's where switching supplies do their magic, and then harmonics to that magic. Wrapping the power cord around some ferrite really is the solution. My only comments are you want to do it close to the power supply and you want to have a decent number of feet. I remember once a long, long time ago, I bought one of those clip-on ferrites from Radio Shack and I thought, well, it's going to solve my problem. And of course you put through, one wire and you clip and you go, well, that's that. Well, maybe for VHF, right? Or some crazy frequency. But in general, for everything we're talking about, it seems like 6 or more terms are necessary to get enough choking impedance down where you care about it. Okay, can you choke a gutter? Okay, let's say you discover that when you point your Yagi at the garage, the rear gutter clearly picks up lots of power, re-radiates it, RFI in the house goes up, and the Yagi SWR rises too. Can you choke a gutter? All right, you probably can't wrap the gutter around ferrite. My guess is you probably can't wrap ferrite around the gutter. But don't forget, something we saw earlier is that length changes can be enough to shove the resonance to some place where it's not getting in your face. So could you ground the gutter in one or more places? Could you add some wire off the sides trying to change the resonant length? Usually current doesn't have to go to 0 to knock down a problem. And then as the age-old adage goes, length matters. conclusions. Okay, so to me, there are three tools for reducing unwanted RF current flow. Chokes, which is a high impedance, ground, a low impedance, and length changes. I think at least 3,000 ohms should be enough for most situations. Now, I tried to find an early Walt Maxwell source, and I think I have all of his writing, but I couldn't find it, where I think he was talking about 10 times the impedance of the line. So that's 10 times 50 ohms is 500 ohms. That's clearly too little. Some sources talk about 1,000 ohms. You can find some too. K9YC, Jim Brown, he's pretty happy with 5,000 ohms. So the point is, you don't want to be too low. That's going to be a problem, whether it's resistance and or reactance. But from what I was doing here, I'm saying 3,000 ohms is pretty darn good. Resonance, I think, what really exacerbates a problem. Feed point chokes, of course, that provide the balance function, I think are a great idea. I would always use those. Grounding near the station is a good idea, if nothing else, to keep the station from blowing up. Chokes are often good, or line isolators at the station, especially if the ground there is of poor quality. I mean, you know, we toss out the term ground like it's, what did we hear as a kid? An infinite sink of 0 ohm impedance. You can't get that, right? It's impossible. I mean, the thing I think about is if we put a ground rod here that really is darn good, and I pull back 7.5 feet of wire or so, on 10 meters, that's high impedance, because that's a quarter wavelength, right? So the low over there, oops, forgot the microphone. The low over there becomes high over here. So if we put that to our radio and say, my radio is grounded on 10 meters. No, it isn't. So it can be tough. And of course, the order of chokes and grounds can matter. A solution for one band could create a problem on another. I've oftentimes thought, should you shift resonances between the two bands is the best way to, look between bands. You can use more than one choke or ground. I think measuring chokes is difficult. And of course, this is of course whimsical. So if you're operating on HF, the easiest thing and the best thing you could do is go put a choke every quarter wavelength or 6, 7, 8 feet on 10 meters down every line. Now everything will be choked. And I think you've made some company very rich with all the chokes you've bought and references. Okay, that's all I have. Thanks for listening. I appreciate it.
How about that for a fire hose? Well, save one of the best for last. We've had 3 really outstanding papers. We got one more to go, so you don't want to leave. I know it's hot, but it was really cold last winter. Just think about that. And if you have ideas for 2026, email me, k3lr@k3lr.com. These slide decks will be available up on my website here in the next week or so. And brings us to our last topic. And we're going to talk about solar, anything solar. The expert, please welcome Tamitha Scobe, WX6 SWW.
Hi, guys. I'd like to come and congratulate and shake every single person's hand in here for weathering this. I mean, you guys are probably drenched by now, right? I've actually had to step out a few times because it's been pretty hot. So thank you so much for hanging in there. I promise this will be worth it because I'm going to kind of shake things up a little bit. Out of curiosity, how many people here were at Contest University? Okay, wonderful. You guys are now going to end up tutoring everybody else because there's going to be a couple things in here that you'll see from there. I also will be able to kind of reinforce some of the stuff you've already seen. But really what this is lessons learned for amateur radio. And it really has a lot to do with the last storm, that big storm, the G5 that we had. You guys are honestly, you're in the perfect place because all of your expertise and your experience will really help the next generation of, believe it or not, precision farmers. And you're about to see, how many people either have a farm, know somebody who has a farm? Anybody yeah? Did anybody groan during the Gannon storm, what we call the Gannon storm, the May 10th storm, 2024? No? Okay. You're going to see a lot of folks that did, and you'll see why. And it's actually a bit more, I think from this point of view, you're going to be the ones that will be nodding, saying, yes, I completely understand why, while the precision agriculture folks are still scratching their heads. Because you guys are on the front lines of space weather. I've said it forever, right? And those of you who know me, it sounds like a broken record, but it's really the truth. So let me see if I can get this full screen. No? Does this go full screen? Do you see? No, you still see the... How do we do this? Hold on. Yeah, but it'd be nicer if it was like an actual full screen here. I've got a moment, so I can probably figure this out. How about this? How's that? A little better. Okay. Yes, I went to college for that. All right. So let's, before I start, by the way, I do want to give special thanks both to K3LR for allowing me up here to talk with you wonderful folks again, and then also to my colleagues, Dr. Terry Griffin, who you'll start knowing a little bit more about, Janelle Shank, who's a GIS expert, as well as a lot of other space physics colleagues of mine for some of the data that you're going to see here. A lot of movies, so it's going to be a lot of eye candy. All right. So just starting off, the space weather stakeholders, right? This is a slide I've shown for quite a few years now. It's coming close to a decade. And amateur radio, right? The emergency responders, you guys are at the top of the list. You're on the front lines of space weather. You sense literally everything the sun does, whether it's a solar storm, right? A CME, or a radio burst, or a solar flare. You guys are hearing it, dealing with it, having to mitigate through it all the time. But you're not the only ones, right? With some of the emerging markets in particular, we've got drones now. So there's a whole emerging market of GPS and GNSS technology, and you're seeing a little bit of precision farming in there. And we'll talk more about that in a minute. But of course, the Aurora community, the tourism community, the space tourism community now, Hotel ISS, that's becoming a big deal. SpaceX, of course, right? Starlink. They were falling out of the sky a few years ago during the big storm in May 2024. They really had a hard time staying in the sky. They fell out a lot faster than they expected to. But of course, we've got the old players, right? The Department of Defense, Homeland Security, the FAA, Department of Energy. And then we have also the news and the weather broadcasters and all those folks who are coming online. But now we have to add yet a new one. And this is what they call the smart agriculture market. And the reason for this is because GNSS-enabled agriculture tools are taking over. And this includes not just planters and harvesters, but drones, right? They do soil management, they do water management, they even do livestock management. It's amazing how much data they uplink and downlink at any one time. Okay. So why do we care? Well, space weather impacts, again, the list is growing. There's not much at all, really, just these little things, right? You guys are at the top, amateur radio. But we have satellite radio and TV, we have satellite internet, the Internet of Things, airline communication, right? FAA really cares a lot. National electric utilities, power grids, I could go on. Emergency or disaster relief, right? Anything that runs on GNSS, drones especially. Precision agriculture, right? That's a new one. Financial markets, precise timing applications, Aurora tourism, space tourism, and now cloud-based services, storage and operation, including AI. That's going to be another big one because of the amount of energy they require. But here's the thing. All of this is interconnected, okay? And this expertise really can be kind of cross-wired. And so I want to kind of give you a sense of a paradigm shift, because when I just pull out just a few of these communities, okay, these are some of the basics, really. Here's amateur radio once again. I'm sure all of you should be at least in this group, right? But how many here also do geocaching? Anybody? Yeah, quite a few. Well, there you go. What about emergency services, right? There we go. So you're already a part of two different types of communities linked by expertise. Well, believe it or not, the Aurora Chase community, the Storm Chase community, it seems pretty easy, photography, right? You're linked to all of them. Aurora photography has aurora propagation, You guys hear it, right? Sometimes even call it picket fencing. We, myself included, because I've looked at Aurora, we call it picket fence. We actually see the picket fences that you guys hear, okay? So it's called the same thing. Of course, Skywarn and spotter networks, that's pretty easy, right? Because a lot of these spotter networks, they require you to have a ham radio ticket in order to even be part of their club. GPS operator, search and rescue, public safety, and certificate of authority operations, of course. And aurora chasing. A lot of aurora chasers anymore are drone photographers. So they're beginning to understand GPS technology. So you're really forming a highly skilled super community connected by expertise. That's the first thing, okay? Your nearest neighbors are likely multiple categories in here. But you're also connected by weather, right? Picket fencing, we just talked about that. Night side signal disruption. For amateur radio and storm chasers, well, radio blackouts and HF signal disruption, they care about that. You've got collision avoidance and loss of satellite lock when you talk about GPS operators and storm chasers, because they share that particular aspect. And signal scintillation, right, which is this twinkle, twinkle, little star. And this affects GPS dramatically. And that also causes drones to drift. So they can't hover, like out of ground hover, and just hover there. So if you're doing any type of reconnaissance, it becomes very, very difficult, especially with photography. And of course, when they all kind of come together, this is where this is where space weather and terrestrial weather collide. So you're not just an amateur radio operator. You're part of an interlinked, huge community. And a lot of these people know the same things, or at least similar things, or they know the same phenomena you do from a different angle. And that can be exploited tremendously to your benefit, as well as to theirs. Okay, so keep this kind of super community in mind, this mindset in mind as we move forward through this talk. Oh, and one other thing. These have gotten really, really good, because now not only do you guys know space weather, but the public knows it too. But it's through a different lens than we would expect, right? These cameras have gotten so incredibly good that they can see aurora when your eye can't. So everybody and their mother and their grandmother's mother and their grandmother's mother's mother, right, has seen aurora. At least they can photograph aurora even if they can't see it with their eyes. And so that makes people nervous, doesn't it? Because they think, uh-oh, what's the sun doing? The sun must be doing something very different, because I've never seen aurora like this before. So the public knows space weather, but thanks to pop culture, right, because they'll run with this, superstorm, big superstorm events, right? Sometimes some of you might know what the Carrington event is. These are the big, massive, massive superstorms. They have taken on an entirely new meaning. This is the lens that pop culture sees, right? Today, we have pet names for it. We have mega flare, kill shot, micronova, power grid destroyer, Armageddon from the sun, God's wrath, black swan. There's a whole host of names. And it's basically any space weather event that spells doomsday for Earth's weakening magnetic field. You might have heard about this. All of our technology, and ultimately all life on Earth. And if you don't believe me, go to YouTube and look up Solar Attack. It's right there. You can actually watch this movie. It's got Louis Gossett Jr. in it. You actually can watch this movie and you can tell what a coronal mass ejection is. They actually call it, this is a coronal mass ejection, guys. Rocks from space, right? Hitting playgrounds and kids and knocking statues apart. I mean, come on, right? But there's a whole generation of people who have never seen anything that the sun, has no idea what the sun can do. Most of you guys remember cycle 22, maybe cycle 21, maybe even cycle 20 and 19. When solar flux and sunspot numbers were easily over 300, 350, and you can get around the world propagation with 5 watts. Remember that? Those days are coming back, okay? But a whole generation of people don't know that. So really quickly, let's talk about the sun, because I want to get you caught up in where we are in the cycle, because this is really important for what's coming, okay? And I'll just do this quickly, so don't worry, it's not a big tutorial. So we have solar flares. That's the first kind, right? This is what I call when the sun screams, because the sun is screaming in electromagnetic energy, light, right? Takes 8 minutes to get to Earth, and it gives you a radio blackout, okay? That's only on the day side. Now, we also have solar storms. These are coronal mass ejections, if I can get this to play. Oh, it didn't, why did it find the media? Okay, well, this one didn't find the movie. That's frightening. Should have. But you can see it. It's that loop of material. And if the movie would have played, it would have played all the way out. And then you get radiation storms. I hope it can find this one. Nope, media can't find that. But it can find that one. I have no idea why. Okay, so radiation storms, if those of you who know what DRAP is, that's a model that gives an indication of whether you have solar flares or big particle storms. And that's what you see in the red here. It's also what blinds coronagraphs. So you're seeing a blizzard. Sorry, I couldn't have it play for you. But it's a blizzard that literally makes stars, these false stars, all over the entire coronagraph. And it does this to lots of other optical instruments as well. In fact, it even does it to astronauts' eyes. So when they're up in space, this is what they see during a big radiation storm. That's kind of frightening, right? But not all of this stuff happens at all times of the solar cycle. Sometimes there certain phenomena dominate, and that is where we come to coronal holes. So you can see this and see it's hardly playing. I hope this doesn't cause a problem for us for the rest of this talk, but you can see that coronal hole, hopefully. That is not the sun dying. It's the solar dynamo is not going out. The sun is not splitting in half. It's not losing its light. It just happens to be cold in that region, so it doesn't emit light. It also lets plasma fly out fast to get away from the sun so it doesn't heat up. So that's why it's dark, okay? But what we get from that is fast solar wind. And when fast solar wind hits the slow solar wind ahead of it, it creates a big bow wave, just like a boat going through a river, right? You plow through it, you get a bow wave, same kind of idea. And that can actually mimic a big solar storm. And these coronal holes, this is what's coming. This is what we're beginning to see. So let's talk about where we are. See if I can get it to move, okay. So where are we now in the solar cycle? Why would we be seeing coronal holes? Well, has anyone paid attention to F10.7 recently? Anybody notice the big drop in F10.7 flux recently? Yeah, propagation is not so good right now, is it? Yeah, well, welcome to the declining phase. So we went from about 160 down to the teens, 115, 116, those of you who recognize it. Yes, that is a signal that we really have gone into the declining phase. So we went up through the ascending phase. We had a very short maximum, strangely enough. We actually are about 6 to 9 months ahead of where we thought we'd be. And now we're beginning the declining phase. You can see us right here, okay? So for those who think that there's gonna be a second peak, a second maximum, no, we're done. So we're gonna be climbing down. And sadly, if the linker predictions are correct, and these guys are the ones that actually indicated, they actually predicted correctly that this was gonna be a larger cycle than cycle 24. So these colleagues of mine are really on it. If they're on it this time too, we have until about mid to late 2027 before the solar flux drops below 100. So get your QSOs in now. QSO, right? Because things are gonna drop pretty quickly. All right, so what does that mean? Well, it means the sun kind of looks like this right now, right? That's a coronal hole, okay? You can actually even see it in the synoptic map. And so the declining phase is a very complicated phase because it's not just about active regions and solar flares anymore. It's now about fast solar wind. What's really happening is that we have a new cycle that's already established itself and the old cycle's fading. So it's kicked the polar coronal holes out of the polar regions and down to equatorial regions, down to where, and that's why we're seeing them, because that's how the sun is shedding them. So the next 1.5 to 2 years, we're gonna be dealing with this, okay? But it gets very, very active, believe it or not. It's the most dynamic, the most complex period of our solar cycle. So what are they? As I've explained before, they're dark areas on the solar surface that can be seen in certain frequencies of extreme ultraviolet and X-ray. Not all of them. So like the red sun, they're not there. You won't see them. But you see them in the bronze sun, as I show a little bit, and even better in the pink sun, okay? They have a lower density and temperature compared with the surrounding corona, and if you can see the magnetic field lines, I know the screen is really small, but if you can see the magnetic field lines coming out of the pink, that's the white lines that streak out. The ones coming out of the dark, they're all just straight lines that go straight out. The ones coming out of the bright loop around. Those are jailing plasma underneath it and not letting it get out. So that's why it's bright. It's because it's had time to heat up. Okay. So the dark areas correspond to plasma that can stream straight out because a magnetic field doesn't jail it, it lets it out. And so that corresponds to regions of open magnetic field, fast solar wind. So when you see them, expect fast solar wind. And like I said, during the declining phase, they come down into the lower latitudes where we live, because we live right in what we call the ecliptic plane, right at the very edge. So why is it interesting? Well, believe it or not, this is when activity peaks. So you thought the solar max was when we got the most activity. Not true. We actually get it now. And if you look at the plot up on the left, or excuse me, on the right top, you'll see sunspot number at the top. Hopefully that is reasonably familiar to you. Cycle 20, cycle 21, 22, 23. But then the two panels below, one says small, one says medium. What we're talking about are storm sizes, so storms at Earth. The black line is coronal mass ejections, big solar storms, the big eruptions, right? The red line, however, are fast wind streams, okay? Notice the black line, if it peaks, it'll peak right on line with the sunspot maximum. So if you'll see those peaks rise just like the panel above it does. But if you look at the red line, that's the fast wind streams. Notice it's offset. It's offset just a little bit. I don't know if I have a laser. Do I have a pointer? I don't think I do. I don't know if you guys can see my arrow, but if you can. So here's, let's say, solar maximum right here, okay? Notice this red line is offset. The peak of it is offset. It's actually in what we call the declining phase. And again, the next cycle, same thing. Next cycle, same thing. So storms that aren't huge are the ones that will peak now. And why does that happen? Well, it's because we've got these persistent coronal holes. Look at this. This is from 2018. This was August. This is September, October, November, twice in November, and December. What is this? This is a coronal hole surviving its far side passage and coming back around. Because every 27 days, that the sun rotates one full solar rotation from Earth. So the same coronal hole is surviving, okay? That means every 27 days, we get a storm, right? Which means basically it's just bad all the time, right? They're not the massive, massive events, but they can be strong. In fact, if you're familiar with KP, right, this panel here shows active conditions. This shows a G2 level storm, so a moderate storm. This is the next month we got a G1, then back to a G2, then back to active, then back to a G1. 6 months in a row, bam, 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 bam. We are just pushing on that swing and making it go higher and higher and higher, okay? This is why we get active condition, or why we get so much activity during the declining phase. The thing is, this solar cycle has outperformed solar cycle 24 by a lot. The fast wind streams are faster. So instead of getting G1 to G2, we're going to get G2 to G3. You get to a G3 storm, you're having problems. Even the farmers are having problems, okay? That's what we're going to be seeing. So let's see if I've already said all this. But the nice thing, one thing I didn't mention, is that during the declining phase, as you're already surmising, space weather becomes a bit more predictable. It's my favorite time. I don't have to be wrong all the time. For those of you who know, weather's terrible, it's awful. Space weather's even worse. So I actually get to be right part of the time because I can actually tell you when these things are coming. And even crazier than that, sometimes you see that one coronal hole, on the opposite side of the sun, there's another one. So now you're not getting storms every 27 days. You're getting storms every 2 weeks. See what I mean? This is why satellite operators hate this period. This is when satellites fail, because you're constantly getting the radiation belts pumped, okay? We're also getting our upper atmosphere pumped. Get ready for some sporadic E, guys. So sporadic E should be a little bit better than it has been, okay? And we're climbing down off of solar max, plus we're going into this declining phase where we're getting lots of particles being shot into the Earth system, and that helps to seed and create sporadic E. Okay, let's see what else is here. So for radio propagation, knowing what kind of fast wind that you're going to get is crucial. And this is what I taught at Contest University. So seek out people at Contest University because they know the physics behind what I was talking about. But for those at Contest University, remember, here's the shortcut once again. If you want to know when you're going to have stormy weather, when, in other words, propagation is going to be bad from a particular coronal hole, from the fast wind of that coronal hole, all you have to remember is SNAP. Spring equinox, look for a negative coronal hole, negative polarity. That will give you storm. In the autumn equinox, look for a positive polarity coronal hole. That will give you storm. Anything outside of that, you're good. And if you want to know what I'm talking about, if you go to the Space Weather Prediction Center and you look at their synoptic charts, they map out these coronal holes, and you will find in them a dash or a plus, meaning a negative or a positive. That's the polarity you pay attention to. Okay? So you can actually tell a priori, just looking at that coronal hole, whether it's going to be southward fielded Earth causing storm periods or northward fielded Earth not causing storm periods, but actually helping radio propagation. So seek out your CTU fellows. They'll show you the details. Okay, so let's now talk about this, okay? Because now we're moving into this active period. I hope I've given you a sense that activity is actually picking up now. And let's talk about the superstorm producer back in May 2024, because there's a lot to learn from it. You guys might remember this. This was old region 3664, but it really wasn't one region. It was actually 3 regions. This is why it was such a monster. It was because it started with region 3664 and 3668. This movie will replay, so you'll see it again. And then there was a 3rd region in the middle. If I can get the thing going. You see this right here? That region merged the 2 together, and Swipsy just dropped the name of 3668 and just called the whole region 3664. But it was 3 regions. This region, or this monster region, fired 10 X-class flares, including the largest of this solar cycle, and caused a G5 level superstorm, which was the largest in 20 years. Okay. By contrast, solar cycle 24 didn't have a single G5. We've already had 2 this cycle. And this is not even that strong a cycle. So let me just run through. You can see here's that monster region on the disk, and you can watch it. We'll watch it fire solar storms. It was getting really nasty right about here. And I'll see if I can capture all the storms. There was 1, there was 2. So you see 1 halo in the coronagraphs, 2 halos. We're not done. There's 3 and 4, 1, 2. We'll go again, I think right in here. This might be 5. There's definitely a big one, 6, that may be 5 or 6 right there. That's another big halo. 7, I think that might be it. Okay, so if I play this way, I have them labeled. There was 1 and 2 right together, 3, 4, 5. Here it goes, 6 and 7. So we had a pancake, a 7 stack, right, of pancake coming at us. This is what caused this huge storm in May. It wasn't just one event, and that's typical with these big, ugly beasts. They don't just fire one thing at you, they just keep firing all the time that they're in Earth view. Okay. Now, what happened during the storm? And the reason why we call it the Gannon storm, by the way, is that one of our very important colleagues, she passed away like just a few days before the storm occurred. So our whole community calls it the Gannon storm. So if you want a lot of scientific information, by the way, or journal articles, you can just type Gannon storm and you will find a whole bunch of stuff that you probably won't find in other periodicals that might, just give you articles and stuff. But yeah, her name was Jen Gannon. She was a wonderful gal and dealt with magnetometers. So here's the interesting thing. This is where it starts hopefully getting your interest up. Anybody here do auroral propagation at all? Anyone from an area that does? Anybody you know anybody who does? Couple? Okay, good. This might intrigue you a bit. So the aurora from the Gannon storm was visually incredibly disruptive. In fact, Chris Wickland put together a Google map, and you can get it from that QR code right there at the bottom. This map has all these pinpoints of places where aurora was seen. And not only does it have that, but it actually, if you click on the pinpoint, you will find the picture. It will pull up the picture. So you can see that aurora. But the thing is, it's not just green, or what we called green streamers or discrete aurora that you see here. It was the whole gamut. There are all different types of aurora. We have things like streamers. We have in the auroral oval. We have all sorts of little features, sure, as you can see some here, right? But we also have pillars. We also have a SAR arc. We also have something called Steve. We also have dunes that live in the sporadic E layer that have mesoscale structures about 45 kilometers apart. All of this stuff affects how auroral propagation occurs. So while photographers were being able to pick the aurora out, and they've even got color-coded, you can see with the pinpricks being slightly different colors, they were picking out where a different aurora was being seen. And the SAR arc, which is more of a diffuse aurora, was at very low latitudes. So the thing is, what does that sound like then? If you're doing aurora propagation, does all aurora sound the same? Or is there some difference? Has anyone ever checked? Has anyone ever thought about doing that? Right? Well, now you have an ability to, because the aurora photographers are everywhere. I mean everywhere, right? I'm one of them now. So you have some ground truth visually, so that while they're looking at some synoptic view, you're piercing it and refracting off that layer. So there's some really not just interesting science, but some interesting information about knowing perhaps what kind of aurora is the most troublesome, what affects the signal the worst, and who might benefit from that? Well, precision farmers, but we'll get to that in a second. Whoop, if I can get this to play. Oh, this isn't going to play now? Okay, good. So this is the live MUF V7 from G7IZU and G7RAU, who have put this out consistently. And this is the auroral propagation that was gone through contacts. There was auroral propagation clear down to Turkey and clear down to Florida during this storm. So anyone who says that they never do auroral propagation because it never comes far enough south, you might get a chance, especially as our sun wakes up and they start sending more storms like this, okay? And for those who aren't familiar, the horizontal wings, so they have one contact and then they have these horizontal wings that show where these conics show where the latitudes at which auroral propagation and auroral scatter is occurring and where propagation would be possible. But again, you can see it goes from very high latitudes to very low latitudes. What kind of aurora were they getting? What kind of aurora were they using to propagate? Guaranteed it wasn't all the same. We know that from the pictures. But these are actual contacts, so it'd be really interesting to know. Because here's where things get crazy, okay? We have GPS, we've known this for years, that GPS signals get scintillated. So the twinkle, twinkle, little star story is true, right? It's beautiful when you see it in the stars in the sky, not so great when it's your HF rig or it's your, right, or it's your GPS signal. Because with geolocation, what happens is that you get indicators that you're all over the place. As a matter of fact, I know aurora chasers who actually use the GPS on their phones and wait for it to go crazy in order to know that they're near aurora if they can't see it in the sky. So they actually use the scintillation as a tool, right? They're doing over the horizon in a sense. It's not much different, right? All right, so here's what happened that night when the Gannon storm first hit, okay? We had John Deere reporting on Friday, May 10th, if you can see this. It says, please be advised that there is a significant solar flare and space weather activity currently affecting GPS and RTK networks. RTK, for those who don't know, is kind of like an augmentation network. It kind of helps when GPS isn't giving them the precise enough numbers, and you can have a base station on your farm in your area, or you can get it from satellites, or you can get it from a network of a whole bunch of base stations all over. So there's different ways of getting RTK, but it's a correction network, okay? So they were having problems with not just GPS, but also their RTK network. It says the severe geomagnetic storm is the worst since 2005 and is forecast to continue throughout the weekend. We found that the best course of action at this time is to shut off RTK and use a grace period for SF2 and SF3. That's the Starfire 2 and 3. Those are the satellite constellations that were also supplying this. They said this will eliminate any of the conflicting corrections that the machine is receiving from the base station due to the geomagnetic storm. And GPS accuracy will likely still be reduced, but we apologize for the inconvenience. Well, shortly thereafter, they had to get another update and said, forget it, never mind. Don't Starfire 2 and 3, they're awful, the whole thing's awful, we just don't know what to do, we can't find a correction. And they said, we strongly advise you to keep an eye on your guest rows. Meaning as you're planting, because this was planting season, make sure you try to steer straight, okay? Now, the sad thing is that during this period, it was like a perfect storm. There had been horrible weather for the 2 weeks or 3 weeks prior to this, and there was this one weekend that was clear skies. And so all of the farmers in the Corn Belt went to go plant their corn because this was the last week that they could get in before their insurance cut them off and they started getting penalties. Okay, so they had to plant this weekend. And this is when the storm hit. So they were already in trouble. But here's the thing. When Deere says keep an eye on your guest rows, they also added this. When you head back into these fields after you've planted, to cultivate, dress, side spray, all this stuff, harvest over the next several months, we expect that the rows that you planted won't be where the autopath lines think they are. So this will only affect the fields that were planted during the times of this reduced accuracy, as they call it. It's most likely going to be difficult, if not impossible, to make autopath work in these fields as the inaccuracy is most inconsistent. So in other words, for the rest of the harvest season, you're going to have trouble because everything's basically lost. You're kind of on your own. And I've learned a ton since then. But let me go back. I'm going to see if is this mic live? Yes. I couldn't, they didn't do the audio, so I'm going to give you audio here. And hopefully you can hear this as he talks. I'm going to try to turn it up as much as possible. Whoop, if it'll play for me. Come on.
I'm planning, going through the field, 10 miles an hour, as I always do. My tractor goes, I go, whoa. I slam the brakes, pull back on the stick, pick up. I'm like, that's not quite right. And then it goes, RTK signal found. I'm like, huh, strange. Try going again, same thing. So I just pick up, drive to the end, shut it all down, restart it. Acted fine. I came back on this pass and did the other half of it from the other side. I'm getting lined up into this one. I'm perfectly lined up, and it said I was 5 inches off. And then it jumped to 20 inches, and then 25 inches. So I start making phone call. There's solar flares from the sun, and it's affecting us. I don't know what hasn't happened to me at this point. I mean, solar flares off the sun, screwing with my RTK. Are we being serious? And there's no way to know when it's going to be over. So.
That's the millennial farmer on TikTok. So this was repeated over and over and over again. I have many more examples of this if you'd like to see it. And it's not just with the May storm. But this is how completely clueless they are, that this could even happen, right? And I feel for them. I really do. But it gets worse. So imagine that happening farm to farm to farm, you know, over large swaths of the continental United States. The news from this hit not just agricultural, you know, rags, but actually ended up going to the New York Times. It became such a big deal. But I just grabbed this one because of I mean, like I said, I got a whole choice of different articles I could have shown. But this one really spoke to me. Because I say geomagnetic storm scrambles tractor navigation systems. I mean, they had stories about tractors literally chasing their tails. But, you know, I mean, it goes over and over. But this is what really got me in this particular article. And I have it circled here. It says, if anything came from this, it's the importance of being proactive in protecting our food system and having a response plan in place to avoid large-scale disruption. Uh-oh. So this was something that got me really, you know, surprised me. So I started working with an economist named Terry Griffin. Now, Dr. Terry Griffin is from Kansas State University. He's been doing agriculture all his life, and he always looks at impacts due to weather and other things, always financial, because he understands how this propagates over the course of a harvest season. And even NASA at this point, Terry Griffin is now part of the Space Weather Action Group. This was a big surprise. It was a huge pivot by NOAA to include Terry onto the SWAG because the SWAG reports to the White House, okay? Because we're trying to understand space weather with new technologies and really get a handle on how space weather affects all of them. So NASA published this just recently, and it's what NASA is learning from the biggest geomagnetic storm in 20 years, okay? Storm consequences, you can read all this stuff in all sorts of places. But Terry says not all farms were affected, but those that were lost on average about $17,000 per farm. 17 grand. This is just from a couple days because it propagates. The problem is they have these combines and harvesters that are meant to have perfect GPS rows, Absolutely perfect. So when they go to harvest now, if the rows aren't lined up and they had planted 8 rows, or they planted 12 rows, but their combine only does 8, and then they've got these things that are offset, the rows have to be dead on so that they can continue harvesting. Or if they're doing things that are planted underground, they have what are called inverters, and they have to dig into the ground to get, let's say, peanuts or sugar beets. I think it's sugar beets. And if their reckoning is off, well, they dig and hit nothing, right? So the yields drop and drop and drop and drop. So Terry had said, this isn't catastrophic, but they'll miss it. This is like a wake-up call for the agriculture community. It's a wake-up call for NASA. It's a wake-up call for all of us who care about space weather. And, we've known about navigation and radiation and flights and all that kind of stuff, but this one kind of really caught us because it's talking specifically about our food supply. Now, even spaceweather.com got in on it. Solar storms are driving the farmers crazy. You can see the headline there. They're talking about our tractors acted like they were demon-possessed. Okay, some of them lurched to the left, to the right. You can even see the picture of the corn rows. See those corn rows? What drunken farmer was doing that, right? That is what AutoSteer did for them, and GPS did for them that night. And they said May 10th wasn't the end of it, because we had another G5 in October that same year, last year. Again, farmers are like, we're getting hit by this. This is a problem. And now they're kind of going back in their head, and they're realizing all the times in the past that they've gotten hit, and they didn't know what it was. And they just kind of blew it off like, oh, it must be my equipment, must be this, must be that. Now they're thinking, was that space weather? And now they're beginning to recognize, because I've seen more and more and more reports during G2 and G3 level storms, which is what I saw in solar cycle 24 just a few times, because I'd have the savvy farmers say something, but now they're all beginning to say it. And they're all kind of like pale in the face because they don't know what to do. So I've been working with Terry. We've got a paper out that's published in Kansas State University, and I've worked with other people. But here's part of what's really cool. If you really want to dig into this and the economic damage, but I pulled out one slide, one diagram for you, because I want to really hammer home some stuff, and this is where your expertise comes in, okay? This is one plot, and you can see what we've got plotted on here are storm events for an entire solar cycle. So you can see solar cycle 17 up here, 18, 19, 20, 21, 22. So hopefully you can see that, and it's January through December. So it's each year just kind of plotted on top of each other. And these are storms that are G2 to G2 and above, okay? What we call KP7 and above. So moderate level storms, not even huge ones, okay? What's in green and gold? Green is the planting season. Gold is the harvest season. And for those of you who remember, I told Terry very early on, I said, you guys do a lot during the equinoxes. You plant and you harvest in the spring and fall equinox. Uh-oh, because the CTU members know, we just talked about the equinoxes. That's when space weather peaks. That's when you get the biggest storms. In fact, as you look at the gray and the blue bars on any of these cycles, right, you see that there's a peak in the fall and a peak in the spring. Again, peak in the spring, there's a peak in the fall, and you see it kind of dips down during the summer period. Well, those are the solstices. We don't have, space weather kind of minimizes at the solstices. It's just how Earth shakes hands with the sun. So this is a natural phenomenon. We know about it. It's called the Russell-McFerrin effect. We've known about it since the 70s, okay? But it just so happens that it's the worst possible thing for farmers. And so there's the Gannon storm right there, okay? That happened at the beginning of the planting season, solar cycle 25. And you know what a lot of farmers and a lot of people who are writing articles say? Oh, it was a one-off. It was a one-off. Never happen again. No, sure it won't. Right? Every single one of those red arrows is a storm that's as big, if not bigger. Look how many fall in the planting or the harvest season. Look what cycle doesn't have it. Any. Cycle 24. This was the cycle we just came out of. This is the cycle that all the farmers cut their teeth on with precision agriculture. It's the one cycle, but the sun went to sleep at the wrong time. So we have built-in susceptibilities that you guys know about. You know what these are. You've lived with the sun and its mercurial nature. You guys remember cycle 19, maybe not 17, but 19, 20, 21, 22. You guys have the corporate memory of what radio propagation does during these cycles, unlike anybody else alive today. And these precision farmers, they've got cycle 24 and 25. That's it. What a difference, huh? So let's think about this super community mindset, because there's so many new insights being that we're capable of doing now. And I'm going to show you some of this. I'll see how much time I have here. I only have 10 minutes left, so I've got to be careful. So I might not be able to show you as much as I'd like. But you can look at the Android phones. They're mapping GPS with Android phones now. They have, we also are doing work with Ampere, looking at the polar caps, looking at how our Earth's magnetic shield changes, and geochron. Maybe some of you guys have the geochron timepiece. We're actually working with them to create space weather layers. But here's an interesting thing. So the radio impacts of the Gannon storm were very widespread, and I'll see if I can play this. Hopefully it'll play. So this is the geochron down here, and you're seeing your radio contacts down at the bottom, color-coded the same as the PSK reporter. So this should not be super surprising to you. But look at the top. We've got Ampere. So you're looking at magnetic field, basically. On the right-hand side, you see field-aligned currents. Those are the currents that cause aurora. On the left side, you're seeing all the currents that are not quiet. We've subtracted off the quiet currents. And look at that, and you can see even the aurora on the geochron map there. Look how radio propagation is changing, okay? Hopefully you can see the date. I know, again, the screen is a little small, but that's May 11th. By May 12th, you're getting short hops. No TEP, well, very little TEP, if any TEP, right? Even on the day side. And look at the United States, it gets even worse. There's almost nothing. That almost looks like a solar flare occurring. That's how bad it got. And while that was happening to you guys, this is when the farmers were trying to plant. If I look at it closer, let's just look at the CONUS for a second. Let me show you something very interesting that we're able to learn. On the left side is May 10th, when you'll see the storm start. On May 11th, on the right side, that's when the storm is ending. But look at the radio propagation on the left. A lot of radio propagation, right? Now you'll watch that storm start here pretty quickly. On the right, that storm is beginning to die down. Okay, so there's the left. You can see the storm starting. You can tell for no other reason that we can see a lot of currents and stuff here. But look at the radio propagation. Yet here, look at the right. Storm is dying down. Look at the radio propagation. So there's a massive delay. Isn't that cool that we're actually able to see that? We had strong aurora, huge currents, huge disruptions in the Earth's magnetic field, but your radio propagation was doing well still at the early onset of the storm. Whereas after everything calmed down, there still wasn't decent radio propagation. It lasted for, what, 3/4 of a day before things began to come back. So that tells you there's a huge delay in the ionosphere. That's great for scientists to understand, but it shows the power of aggregating data from different sources. Another one, this is the Android phones, and I don't have a lot of time, but I'll just play this while I talk a little bit. So on the right, again, you're seeing your radio propagation. On the left, you're seeing the Android, the total electron, what we call total electron content, which basically affects radio propagation of all sorts of frequencies. And you're seeing a big drop. It goes way down right there. And when it goes way down like that, you're actually seeing, that's when you're seeing the radio propagation, the HF radio, if I can get the arrow back, you'll see the radio propagation dip when this red lip drops way down. And we know from current, watching the current, it's actually when the current went from one direction swiftly to the other direction. It changed like very, very quickly, and it caused this rapid wave drop, and we're seeing it like ripple down from high latitudes to low latitudes. So this is what is possible today. And now here's the part where the whole super community mindset comes in. So I'm gonna just let this play. So this is ROTI. This is the rate of change of that electron content, right? The electron content is what you guys care about for the layers for propagation. And this isn't scintillation, but it is a risk factor for scintillation. So green is good, yellow is red is bad. And so what you're seeing is how the risk for scintillation of GNSS signals, so this is higher frequencies, this is now the L band, right, in the gigahertz range, how those frequencies are going to scintillate, right, so twinkle, twinkle, little star, during that storm. But what I've done is I've overlaid the Maidenhead grid on it. See the Maidenhead grid? Imagine amateur radio operators being able to tell, because you guys are doing HF and doing DX, these guys only care about Starlink, or they care about GPS right above their heads. You guys know when it's coming. You guys can sense what's happening hundreds, if not thousands of miles away. And if you just report your grid square, and we got them to understand what grid squares are, and they know what grid square their farm is in, imagine how powerful that could be, right? So one of the cool things about thinking with the super community mindset is that you guys provide, not only do you guys provide the over-the-horizon and early detection arm of this super community, but you get the benefit of all of them joining forces, because I guarantee you, once they realize what you're capable of doing, they're going to want to be part of the club. So there's a new ham, right, in the storm chase community. There's a new ham in the Aurora chase community. I've already seen it. I've already seen Aurora chasers come in, and there's a new ham, right? And I don't know about you, but I love that new ham smell. So to summarize, right, this May 2025 Gannon storm is the largest in 20 years, and it really opened our eyes to the new susceptibilities, especially in precision agriculture. We are now entering the declining phase when that activity increases, but F10.7 drops. So that could be a bigger, even more issues for you guys. And solar cycle 25 is going to continue to outperform its predictions. We're going to have faster streams, stronger storms. Do not use cycle 24 as your benchmark. Go back to cycle 23 or 22. That will be your benchmark, okay? Space weather impacted communities are becoming a super community of expertise and experience. And you guys lead this. And there's huge communities that are going to need this, because you're the over-the-horizon and early detection arm of the super community, and the precision agriculture community is only one of many fast-growing fields that are going to need your guidance in the coming years. So please recognize you're the Elmers to the precision ag community, among many others. And I thank you for doing what you do. So, and that's it. Considering I'm the last person, we've got 3 minutes. Anybody have questions? I'll take questions. Yeah.
Is that a reality, or is that false? Is that really a risk that there are electronics being thrown out by a solar?
If your electronics are the size of Lake Michigan, sure. Because the issue with what happens is that their electronics are in trouble, but it's power grids. They have to be massive. And the reason why is because Earth's magnetic field is only the size, it's only the strength of a fridge magnet. What makes it incredible and very effectual is that it's a fridge magnet the size of Earth. So if you integrate over large distances, then you can get the big potential drops and you can get the big currents flows and things like that. The only other, so that's why big infrastructure has problems. The only other thing that is an issue is, especially at low latitudes, you can get an E3 component of an EMP. So some of the storms that have hit Earth that are super fast, they don't even have to cause a big geomagnetic storm, a big, like what we just saw with the Gannon storm. They can be big, what I call big bumper cars, because they can have the wrong polarity and just hit Earth really hard and cause Earth's magnetic field to wiggle like really fast, and that will actually cause an EMP. It's a slow EMP, but it's still enough to take big infrastructure out. So there's two ways it happens. But yeah, your pacemaker or your, stuff like that, the only time that's a problem is if you're, if you have an implantable medical device, that's when you're flying an aircraft. They might have single event effects, stuff like that, but nothing from big geomagnetic storms. Okay. Any other questions, guys? Yeah. Not right now, but I'll tell you one thing that I'm really interested in is Starlink scatter. Because as these things continue to burn up at a higher rate than they're supposed to, because the cycle is bigger than they expected, and they are being chewed up. Their lifespan right now is only about 3 years as opposed to the expected 5. What is that burning up in the atmosphere? Is it creating nucleation sites and creating, in a sense, kind of like being meteors? So I'd be very interested to know if meteor scatter and sporadic E picks up because of this. Yeah. Yeah. Oh, that's cool. Right on. Yeah, I mean, we can talk about it. We can talk later if you'd like. Come chat with me and we can discuss a few things more. Love it. Sounds great. Yeah. Yeah, the actual PowerPoint slides are about 800 megabytes because the movies are big. I can get you a PDF if that's what you'd prefer. Okay. Yeah, I can get them to you. Yeah, I think I'll have to talk to Tim. Where is Tim? He left. Look at that. He abandoned us. Hey, I love it. I'll be here all night. No, I'm kidding. Yeah. Right. Yeah, I'm gonna get him for that. We should all get him. Yeah, any other questions, folks? Yeah. No, well, let me ask you, you will know the answer to this. Did you have a problem with radio propagation that day? Did anybody have a problem with radio propagation that day? Nope, no problem. And that's the funniest thing, is that they'll blame atmospherics. They'll think there are a ton of people out there that will blame atmospherics. And I said, I don't have to look or think or speculate. I just go to the amateur radio community and go, hey, how's propagation today? Anything unusual? And if the answer is no, definitely wasn't space weather related. Because again, you guys are on the front lines. What ended up happening, I actually was following that quite closely. Because unlike the one in where was it? Not Puerto Rico, it was another low latitude area in South America that had issues. But why I was watching was because I wanted to see what was going on. I am very concerned about renewables. And as it turns out, the Portugal grid, the Spain grid, they're about 80% renewables. And so they've taken a lot of the old big generators offline. And those big old generators with their spinning blades, those things create inertia, right? Which gives us something called reactive power. And when you remove those from the system, then any oscillation does not get damped very well because the system can't handle it. And on top of that, the renewables decouple. When the grid starts going wonky, the renewables go, not my problem, I'm out. So it completely decoupled what little inertia that those wind turbines and everything had from the grid, and it made it worse. So these little oscillations just got completely out of control. Yeah. Oh, right, exactly. That would, if you can leave it on at all times, definitely do, please. And with like the WhisperNet and everything else, that's so wonderful. Yeah, we really appreciate it because we can't mine all this data. Even Nathaniel Frizzell, I pinged him just the other day about it, and I said, "Are you working on the Gannon storm yet?" And he said, "No, we're not working on it yet. We're still doing the eclipse stuff." So it's a personnel shortage, but the data will always be there, thank goodness, and we will get to it. So yes, if you guys contribute to any of those databases, absolutely appreciate it very much. Anything else, guys? Oh yeah.
The implication is that some of the issues that Puerto Rico is having with their power are related to the solar event. Puerto Rico wasn't.
Though there was one. What was the? And I'm short of. For some reason, I'm losing my mind. I did an interview just recently on the one that was down in South America somewhere. And what was it? Dominican? Yeah, not the Spain and Portugal wasn't, but there was one prior to that was actually occurring during a geomagnetic storm, and I believe it actually was. They were having trouble, and it might have been Puerto Rico having trouble again. I think it might have actually been. Was it? Was Puerto Rico? Yeah, it was recent, right? They actually had a brownout, and it was something about a branch being over. And then suddenly, like they had a cascade failure, and one branch on the tree was not going to do that. So I knew immediately from the way that they talked about it that likely a GIC was involved, because what space weather typically does is that it pushes something over the edge. So you already have a weakness and maybe a branch fell on a tree, but it should only cause that one transformer to go. Instead, they had all these relays trip, pop, 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 all the way across the grid, and it caused a cascade failure. That is typical when the grid is like, right at the hairy edge of going overload, and they don't have the right mitigating procedures involved. Because, for instance, in the United States, in the CONUS, starting at a G2 level, okay, so a moderate level storm, we have a ton of things that we do to mitigate. We actually take off all the relays, all the protective relays, we turn them off, because they'll pop and they'll pull these different parts of the grid down. And when they do that, it's just like what happened in Spain and Portugal. You're taking away all the inertia, all the reactive power that you need to stabilize. And so really the best thing to do with big space weather storms, ride them out. Let the transformers run hot, because if you don't, you risk a cascade failure. Yeah.
Are those mitigation factors done at the reliability level or at the individual?
They're done at the NERC and FERC level. They've got actual procedures that they've got running. Now, how they're implemented, I don't know. I'd have to talk to Antti Polkanen. He's been doing this his whole life. In fact, I saw him a few days after the Gannon storm hit, because we all flew to Italy for a school that we were teaching, and he was doing the jig. He was so happy because he spent 20 years of his life as a volunteer teaching the NERC and FERC about GICs, these geomagnetically induced currents. And it's a labor of love, right? It's a very thankless job. But the fact that we rode through our first G5 and he got a real test of how we did, and we had problems, but the operators rode it through okay. So here in CONUS, we're actually doing better than we thought, and he was very happy. So am I. Yeah.
Does space weather affect interplanetary stuff like moving asteroids around and things like that? The vapor for the solar pressure, things like that?
Well, it won't move the asteroids around. It'll move their tails around like comets and stuff like that. But we have planetary bodies have their own relationship with the. Sure, all the time. That's one of the reasons why Mars has very little atmosphere left. Because once it lost its internal magnetic field, its dipole generation, well, the solar wind started slamming straight into the atmosphere, started stripping it off. Yeah, we call them pickup ions. And so that's the reason why, and all its oceans evaporated because it was replacing the ionosphere that was being ripped off. And so eventually, it'll have no atmosphere and it'll look like Mercury, eventually. That's what I mean, yeah, that's Mars. That's exactly why Mars has no atmosphere, has very little atmosphere. Although you can still do radio propagation there. You just have to change your frequencies. You can still do skywave, believe it or not. Yeah. So that's the other thing I talk about is that, you got the Mars generation, right, coming up, and they want to colonize Mars. You guys are also the Elmers to the Mars generation, because you're the colonists for Earth, and you learn how to do over-the-horizon propagation. What are they going to do over there? There's no cell networks, right? And during inclement space weather, the layers get opaque to the satellites. You can't get signals in or out. So they're going to have to do ground wave, right? You guys know how to do that. So you're going to be teaching them too. This is what I mean. The expertise in this room is incredible. And I thank every day that I was brought into this world, because you guys are fantastic. Okay. So talk to Tim. If you want copies of the charts, talk to Tim, please. And we'll figure a way to get them to you. Is he? 800 megs of? Yeah, hopefully. Well, I'll talk with him. Sorry? What did I say to look for? Oh, Tim got AHRL. Okay. Thank you. I'm so glad you guys liked it.
Okay.
and we're getting, without my.
I sent the picture in the group chat.